on this computer.
Juliet, can you switch on the camera?
Okay, recording is started for the day. Yep.
Juliet?
Maybe Juliet start talking in mute.
Sarira?
Yeah, we can hear you.
Okay. Hello, everyone. Good morning. I am Juliet. I'm the Vice President of Administration, San Francisco Bay Area Tamil Mandram for 2020. This second day online workshop has started this morning and will end by evening. This bootcamp is coordinated and helped by the BATM youth volunteers. Dear students, our Tamil poet and philosopher Thiruvalluvar said this around 2000 years back, Karka Kasadara Karpavi Katchabin Nirka Adarku Taga. Learn the appropriate education in a faultless way and follow what you learned throughout your life. So, dear students, stay focused, study well. Okay. I would like to welcome behalf of San Francisco Bay Area Tamil Mandram, Mr. Jyoti Periyasamy.
Thank you, ma'am.
Now I will give the mic to our VP Cultural, Mrs. Indumati.
Thank you, Juliet. Good morning, everyone. I am really happy to welcome you all for the second day session of Artificial Intelligence Workshop with Mr. Jyoti Periyasamy. I'm really warm welcome to you, sir. I was watching the yesterday's program. It was so lovely and interactive session. Hope today's session also it will be really interactive and kids will enjoy the session. Without further delay, let us start our program. So I am handing over the mic to Mr. Ramesh Kupuswamy. Please.
Thank you, ma'am. Actually, so we want to make it very interactive.
Yep. Thank you. I just want to thank Mr. Jyoti Periyasamy. It was a great session. Yesterday, so many participants messaged me and told it was a very lively session and interactive. You made the students, all our students who participate, go live and asked, very interactive. It's a very good session. And also the content of the course was very good. So whoever doesn't know the AI, right, they came to know and they learned a lot in one day. So they're going to be the master with their today's session with all the what you call the experiments, the projects they did. Some of them already sent the projects. Thank you who are sent the projects. Thank you for sending the projects, and who are not completed, you can share the projects to us. And Mr. Jyoti will review and give the feedback. Now we'll start with the program with the BATM youth volunteers. So they will come up with the quiz and you can give the answers to the quiz. And after that, Mr. Jyoti will continue with today's session. And I want to tell you, we want all the kids to be active and participant. And maybe our BATM youth kids will identify few active participants and they might give some gift card. So be active and be answering to all the questions and be lively on the today's session. Okay.
Sure. Thanks,
Kaushal.
Ramesh.
So yeah. Kaushal, you want to take it?
Yeah, I'll take over from here. Hello, everyone, and welcome to day 2 of the BATM AI Workshop 2020. We're going to start off today with a quiz, actually. So we have prepared a quiz from some of the stuff that Mr. Jyoti has taught from yesterday, and it's mostly true or false. So I'll ask the question out loud, and I'll give you guys like 5 to 10 seconds to think. And then when someone raises their hand, I'll unmute them, and they can give the answer. So let's get started with the quiz right away. The first question on the quiz is pretty simple. True or false? Artificial intelligence is a technology that makes machines intelligent.
True.
Correct. Can you explain why it's true?
They're intelligent because they can learn by themselves. They don't need humans like to code them. They can learn by themselves.
Yeah, that's about correct. I'm gonna move to question 2 now. Question 2, true or false? Artificial intelligence is the need of the hour for businesses. Here, Mr. Selvum, I think you can give the answer.
Sorry, my name is Rohini, but I think it's true because many technologies and other devices are dependent on artificial intelligence.
So why would you say that it is like in need in businesses specifically?
I don't really know why. Well, I think businesses because businesses are usually dependent on as if you take right now or any time, I guess like iPhones and laptops and all that stuff, and and then and then they're trying to advance like how industries work too, and they're going to bring in more robots and people who work with hands. So maybe that's why.
Yeah, that's basically it. It's just the one factor that you have to consider is also the monetary aspect of it. Because if they have like AIs doing all the work basically, then they don't really have to have any actual people equipped to supervise them.
Yeah.
So the answer for that question was true. Next question. True or false? AI systems are currently much more superior than humans.
No, false.
False.
Can you explain why?
Because AI is not that developed, and it's still humans can still surpass it.
Yeah, like yesterday, Mr. Jyoti went over the 3 different types from like narrow to superior, and we're definitely not superior yet. And so that's why we're currently smarter than the AI systems that we have developed. Question 4. There are computer games that are developed using artificial intelligence. True or false?
True.
True.
True. Can you guys explain why or give an example?
In some games, they program it where something like an entity in the game, it does stuff by itself.
Yeah, like an example would be like NPCs in some game. So they're not an actual other player. It's just an AI controlling the character. Here, the question 5 is not true or false. Blank is one of the most popular programming language for building AI-based systems.
I believe.
Here, Naren, I think you can answer this.
I think it would be Python or JavaScript.
Yeah, here it says Python because that's what we went over yesterday.
Right, perfect.
Here, question number 6. Describe a chatbot in terms of artificial intelligence.
Can you repeat the question, please?
Describe a chatbot in terms of artificial intelligence. Here, I'm gonna let Vishnu answer this question.
A chatbot in terms of artificial intelligence would be an artificial neural intelligence that has been trained to reply to a human when they converse with it and make it and sound as natural as possible and as human as it can.
So wait, what do you say? Like there's 3 types of AI, so which one did you say that it falls under?
Artificial neural intelligence.
Narrow? Okay, that sounds about correct. Because it basically has some like pre-written answers, and aside that, it gives really basic answers to ones where it doesn't have pre-written answers for.
Wait, can I answer?
Sure.
Oh yeah, I feel like chatbots are more like general intelligence nearing super intelligence because it's not one like definite task, but it's multiple tasks that it has to like identify and like reply. So that's why it would be more general because general intelligence is more of like a bunch of tasks rather than one.
I mean, you can argue for both sides. I just said narrow because it has a lot of pre-written answers as well, and it only identifies like a small portion of the words you type into it most of the time. But I guess some chatbots could have general intelligence. Here, question number, let's see, that was question number 6, so question 7. True or false? AI systems will replace jobs in the future. Harsha, you can answer this question.
It can replace most jobs.
Can you give an example of the jobs it can replace and an example of the ones it can't replace?
For example, factory lines. There are already robots that build things in factories.
Mm-hmm.
And in the future, there might be self-driving taxis and public transport that are programmed to move by themselves.
Mm-hmm. Yeah. So like, I think you said taxis. So do you really think that AI will replace taxis? Consider all like the ethical like situations you could possibly encounter in driving.
Yeah, in the future.
Okay, because like think like if you're driving and let's just say you lose control of the brakes, right? Like the AI is driving for you. There's probably going to be an ethical like scenario where they can either crash the car and kill the passengers, or like crash into another car and like take out both the passengers. So do you really think that like taxi driving would be taken over by AI?
Maybe not now.
Okay.
May I answer the question?
Sure, go for it.
All right, so I agree with whatever he said, except for the taxi part, because there's some jobs that humans are only superior at, such as teaching. Because when you're teaching somebody, they all of them learn in a different way, and they all have their own different learning speeds. So teaching would be one job that humans will definitely be superior at. And in addition, one job that AI could also help develop may be housekeeping, or for example, personal service, such as an artificial intelligent robot that tracks down your habits and codes itself based on what data it already has based on what your daily routines are. For example, what time you wake up or what do you do to start your day. So that in the future, possibly AI could be advanced and it could also take over in that part.
So I agree with a lot of stuff that you said, but you said that like teaching cannot be taken over by AI. But I think that you're also right, but I'm also right. Because maybe like the teacher and the AI can like coexist and teach together. Because there could be a need for both of them. Do you agree with that?
I agree because the teacher can provide assignments and it can also like use AI to help benefit and also help make less stress on themselves in addition to the class.
Can I add on to that?
Yeah, go ahead. This is kind of an open
So,
discussion now.
okay, yeah. So in some places, I think in China or somewhere, they actually have like waitresses, like robots, like you know how like Uber Eat and we have people deliver it to them or like deliver the packages and food to our door. They have like robots doing that in some places in China and Japan, I think. And yeah, the one thing that I do want to say is if we're gonna have AI like also take some part in teaching or a job where humans actually like because like when you're teaching you can tell if someone doesn't understand what you're trying to teach them because like we humans are able to understand feelings and emotions and their thought process. So like if an AI is gonna take over or also assist, like we shouldn't do that till like it's more later like developed so it understands more of human behaviors and yeah and
Yeah, that's also true. That's a pretty good point there.
Yeah, another reason why AI probably won't take over every job is because every job has like a little bit of human resources, which an AI just can't do. Like, yeah, emotions, or like being like a part of being a teacher is also getting your students through some tough times. So I don't think an AI will be able to cover that.
Yes.
Yeah,
So the
like
question, wait, going back to the question, so the question was, true or false, AI will replace all jobs in the future. So now do you guys say true or false to that?
It most likely will be false because, as we all discussed, there are some jobs that humans are better at compared to robots, and but there are other jobs that robots are way, way, way more superior to compared than humans. For example, factory lines. Like, if you go to Intel Silicon Factory, they use artificial intelligence and they use robots in order to produce those chips. And if you use humans actually have emotions. And I mean, we're taking out the silicon chip example, but if you have humans in a human environment workspace, for example, like an in-person classroom, humans can teach way better because they actually have sense. They have senses and they can identify what a person is feeling because of body language better than robots can.
Can I
I feel
add
like
on?
Wait, we're gonna have to move on to the next question. We have like 25 questions, and now it's question 7. But before we move on, I'd just like to point out in the chat, Rohit Naidu said that we can't know for certain, and I think that should be the correct answer, because maybe like AI will take over the world, and then like humans are needed, but also maybe AI just like doesn't take over everything, and humans will be needed. We just have to see what the future holds at this stage. So moving on to the next question, question 9. Data science skills play a big role in artificial intelligence implementation. True or false?
that is true
True. Yeah, that's true.
because like the way that artificial intelligence works in a nutshell is the AI has to analyze data and we have to teach it how to react to that data. But if you can't analyze the data yourself so you know what to teach the AI, you can't really create a good artificial intelligence.
Yeah,
Like adding on to what he said, like the AI has to take in all the data and like think before what it does using that data. You know?
it's just like yesterday, Mr. Jyoti explained in one of his like slides that there's two types. There's intelligence and not like there's autonomous intelligence and there's data science as the other type. And so that's why you kind of have to know data like science for the other type. Here, next question. Question 10. A self-driving car is based solely on artificial intelligence.
That would be false.
False.
Yeah, false is correct. So can you guys explain why?
Well, like first of all, like you need like a car isn't just the person driving it. It's also like the engine, the wheels, like the physical car itself. Not to mention like if you're talking just software, there's also other softwares built into it, like motion detection software, like like navigational software. So it's not just the AI. The AI is just reacting to the information that's being processed by the other softwares.
Yeah, that was very well said. Here, you can add on to that if you have anything to say.
I agree with that. I also want to point out that there are some scenarios in which AI cannot be better than humans, such as if you see someone who's veering onto your lane, AI can process that information like quickly enough and do countermeasures to prevent that from happening because AI probably has our current AI. Thank you, Rohit. Because at the level we are right now, we haven't developed AI that is powerful enough or intelligent enough to analyze patterns and process information and do actions in microseconds or nanoseconds that quickly.
Mm-hmm. So, do you guys think that in the future, like self-driving cars will have like a manual override button?
Yeah, definitely.
Depends on the research and how far we get into self-driving cars.
No, because the thing is, if like everything becomes a self-driving car, then people will not even like get driver's license in the first
Yeah.
place because it might not be necessary. And at that stage, like, do you think they'll still have a manual override option?
Probably not.
Self-driving cars to even get legalized, like in the near future, people will want them to have a manual override because they won't trust the AI at first. But then over
Yeah, that's what I would think. Like, if there's like a really like tough road, like in San Francisco, there's like a winding road thing or something like that. They might want to drive that by themselves instead of the AI just driving all the way.
Not just that, there's like many times when there's different weather temperatures and like when it snows and the road is icy, right? Because then we
Yeah.
have to drive slow so the car doesn't go off the course of the road. So yeah,
And
I
here's another
definitely think there should be a manual.
if
If there's
the
an emergency, you need to drive faster, right? So, or if it's like the police chasing a robber or something like that, you need the car to go faster. So,
and also if the AI malfunctions, you can easily like take control, take back the control of the car.
Okay, so back to the question, like, so do you guys think that like self-driving car is based solely on AI, or will there be human aspects to it too? Like a human override button, like I said.
there will be
Yes.
human aspects
Probably because like we discussed last time, people still don't fully trust AI yet. Maybe in the distant future, but I still think that some people won't trust AI, so they will still have like a manual override button so that
Mhm.
people trust it a little bit more and use it a bit more.
Okay, next question, question 11. Mathematics plays a big role in AI and data science. True or false?
True.
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 Because of statistics and like there's probability.
Yeah, that's a pretty straightforward question. Question 12. Machine learning models are trained using training data. True or false? I don't know if we covered this yesterday, but just like if you don't know, just try to like think of an answer and explain why.
True.
Here, can you explain what training data is then?
Well, I don't know exactly what it is, but based on what you said, I believe that it's something that may not be like completely accurate to what's going on right now, but it teaches the machine on how to prepare with any type of data. So it's like maybe like a teaching method or something.
That's pretty close, but I think like you missed out one thing about it.
Could
Does
you
anyone else have?
one more time?
Oh, I just said I asked, does anyone know what training data is?
Oh, okay. So training data is like feeding in pictures, objects, like for it to know, like you know how there's it can find out what type of like Google Photos. If you type up, I don't know, cat, it'll look through your gallery and find all cats, right? So in a case you're training it right now, if you search up stuff, so it keeps on learning, right? So
So you said in Google Photos, if you type of cat, like it'll look through all the pictures that you have and it'll find the cat. But in that scenario, I will not say your pictures are the training data, because beforehand, I'm pretty sure Google fed the AI like maybe like thousands of pictures of cats, and that's the training data. It's just like to show an example of what like it's going to be looking at, and
Yeah.
based on the previous examples, it'll like make its own conjecture and judgment.
but aren't like I mean Google did train it before, right? Because it can't just like learn all at once. But
Yeah.
we are also training it, right? When we're like saying cat or no?
Yeah, of course. It's like it'll always be training based on the data you give it.
Yeah. Okay.
Here in question 13, we're halfway there. True or false? Data scientists build AI models / systems.
Can you repeat the question?
Sure. True or false? Data scientists build AI models / systems. Does anyone want to take like a guess? I mean,
False.
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 Why do you think it's false?
I mean, I think it's false because you said data scientist or wait.
Yeah, data scientists.
Okay, so I think data scientists. So the thing is, I mean, I think it mainly see AI systems and AI. Okay, yeah. So AI systems is basically artificial intelligence, and it's not very developed like at a state. So if they're gonna use like the AI system to help them assist on the data that they've collected on the different tests, probably I don't think it's going to be very efficient, or they're gonna probably get accurate answers because the machine itself, the system itself, is not very developed and advanced.
I mean, right now, to be honest, like either answer could be true or false, because as a data scientist, like you could still be using like SQL commands and stuff, or like you could be making a machine to do it for you. It could go either way.
That's actually true. But like let's just say an error happened while you were experimenting. It's kind of personally, I don't know. Maybe you can scientists probably do that, but personally I would like to see the results maybe, but yeah, depends anyways.
Yeah. So question 14, R programming is the most important language for data science.
Wait, what programming?
R programming.
That's false because like languages such as Python, they're definitely useful, but like the more important aspect of data science and artificial intelligence is actually like the statistical models and like the underlying like stuff besides that. I guess this is like an arguable kind of idea, but like the way I see it, programming is like Mr. Jyoti said yesterday, was a way of connecting the dots of everything else. And so like the underlying aspect of AI is like statistics, analyzing statistical models, machine learning, and that stuff. And programming
Yeah.
is just the connection.
And if you want to talk like programming languages itself, like there are languages like SQL that are designed specifically for things like data modeling and tables and stuff like that. So we can't really argue that Python is like the main language for that kind of thing, because Python is like mainly designed for like actual code.
And different languages are used for different purposes too.
Yeah. Question 15. Big data plays a vital role in data science. True or false?
Sorry, can you repeat the question?
Big data plays a vital role in data science. Do you even know? Can you even explain what big data is?
Big data is like the companies that collect the most data. Like I would say like Google is an example of big data because they probably like know more about you and your friends than you guys do. And like they know like and like they collect like all the data. Like they can like collect everything like from like your address to like your favorite types of food. So like I would say like they're an example of big data, and they're important for they're important for AI because data like that is what we need to fuel artificial intelligence.
Yeah.
So
So
that's like
basically,
their role.
the big data is like the data itself that like Facebook and Google generate, where it consists like the size of it isn't like the petabytes, it's just that big. And like when you try to parse through it and stuff, it'll take ages unless you have a really fast computer or a really smart algorithm. So given that that's what big data is, do you think that big data currently plays a vital role in data science?
People in the chat are saying true.
Here, can you guys in the chat like open up your mics and like talk? Uh, okay, I guess if you guys feel comfortable typing, that's also fine. So can you guys explain why you guys said that big data plays a vital role in data science?
I guess I'll take this. I feel like big data is very important because that's also like what you need to analyze in data science because it's a big analysis. And so if you have like a generic amount of data, you can easily train models and train AI to like analyze through the big data. And so like big data, if it's like data science and there's a lot of data that you can parse through, it's like it's easily connected. At least that's what I feel like.
Yeah.
Yeah, I agree on that, but to add on, maybe it could find patterns through big data, right? So like yeah.
Yeah, that's basically what the cookies are. Like when you go to a site and it says allow cookies. Here, question 16. Data visualization is a key skill in data science. True or false?
True.
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 Can you guys explain why it's true?
So, I think it's true because visualizing the data or like finding the different data patterns in anything that you're trying to record or find the long-term or short-term effects of any experiment or data you're visualizing would be key because it's like because like the different variations and patterns will actually help you to understand what you're collecting data on and help you to like predict the future patterns and the future outcomes. So I would say visualizing your data is vital and key.
Yeah, it's basically like, would you rather have a graph or a set of points? Here, question 17. What is, oh, we already went over this. Question 18. True or false? Facebook is a company that heavily focuses on big data.
True.
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 Definitely.
True.
Yeah, that is undoubtedly true. So can you guys explain where it gets all its data from?
It collects it from your social status.
And the people
The
you
post we like.
Yeah,
The
what
the posts
items
you
you're
like.
interested in.
the search results.
Stories.
everything
Yeah,
that you need to
The
sign in
things you
with Facebook.
search.
Like if you
those
need
are
to sign in
all
with Facebook.
those are all valid examples. Yes, Facebook gets its data from everywhere. Question 19. Linear regression is an unsupervised machine learning model type.
True.
Here, does anyone know what linear regression is? You guys may have heard it in math also, so you can explain it using those terms if you want.
Isn't it like when a line on a graph has like a downward slope or a negative slope?
Oh, yeah.
Yeah, basically just like it's just a straight line, linear line. It has the word on it. So like it's basically like a line of best fit when you guys have a bunch of points on a graph.
Just like a box, and so it's like a dot plot basically, and you try and find that point or that line that's in the middle. That's
No, it's not like a box plot. It's like it's literally when you have a graph.
It's like when you have multiple points that's like not a line, and it's like the average of those points kind of thing.
Yeah, and then
You
it
kind of find the
descends down.
pattern.
It's regression.
Yeah, got you guys.
Like a
Yeah.
negative.
Question number here. Where are we? Question number 20. What is machine learning? Pretty simple question.
Machine learning is when there's an artificial intelligence and we're teaching it, and then and then like it learns from the information that like it gets fed, like whether that be um like a company's information on like sales and who they're selling to and how much they're selling, or like like if you're like say Facebook, like the private information of like the people that use Facebook, it's analyzing the private information, it's saying, oh, and then it's trying to like figure out how to best advertise to them. Like those are all examples of machine learning.
Okay, this is gonna be the last question, I think. Tableau is one of the most popular data visualization tools currently. True or false? Here, I don't think you guys know what Tableau is, so I'll just explain this question. So this is true. Tableau is a really popular data visualization tool. It's basically like when you have like a bunch of data and you just connect the dots in the data manually, and then you just like drag and drop some data around to create really quick charts and stuff.
For the Tableau, isn't the parent company Salesforce?
Maybe you can search that up. I don't know that for sure. Here, those are all the questions I wanted to ask. And I think that's not 25, but the rest of the questions are pretty like, they're not very well sounded. So that's the end of the quiz for today. I kind of hope that more of you guys would talk, but I only heard a few handful of you guys just talking over and over again, but that's also fine. So I think we can turn this back over to the BATM and Mr. Jyoti if you guys don't have any questions.
Okay, I think. Thank you, Kaushal. Can you hear me? Yeah.
Yeah, I can hear you.
Yeah, okay. Thank you, Kaushal, and thanks for everyone for the active participant. So, dear Mr. Jyoti, can you take it from here?
Sure. Can you all hear me?
Yeah.
Yes, we can hear you.
Yes.
Okay,
Yes.
wonderful. I've been listening to the quizzes and the answers and also active participation. I'm thrilled, correct? Like, someone asked a question, is Tableau a parent company of Salesforce? No. So it's not a parent company of Salesforce. There's a lot of questions you guys answered really great. I'm absolutely very impressed. The one thing that I can tell, regardless of the question is right or wrong, the answer is right or wrong, but I like the thought leadership. I like the creativity that came out of this discussion, right? So that tells me how much you are able to understand all these concepts, and some of these concepts are really advanced, correct? I teach like universities, colleges, professors, other faculties to learn students, but their age groups are different. Their level of expertise are different compared to where you guys are. I'm really impressed the answers and the responses and the creativity and thought leadership. Some of your communications are really very effective. You articulated well, and you put in the context and perspective. You made it very clear. Thank you so much for doing this, Kaushal. It's really well organized. Okay, you did a wonderful job. Thank you. Can you all hear me now?
Yes, we can see.
Yeah.
All right, let's move on. So I am actually going to start from what we are going to cover today, and then we'll dive deep into the specific area, and we also have an example to work on. Okay, and we do have some breaks, don't worry. So it's not going to be in a full stretch. So we'll take break as needed, and we will continue this one. Good morning, everyone. Once again, thank you for coming back again, and the same amount of crowd. So that tells me that you're all enjoying the session. You're all able to follow and understand what's going on here. I really encourage you. I really encourage you to take this next step, right? Like just not staying with what we are covering in the class. What I'm covering, it's just kind of a basic framework for you to understand, but there's more to go. I'm sure if you have interest, you will find some time. You'll find resources, do more work, more research, more innovation. Sky's the limit. So use this platform, learn as much as you can, and move on. Once again, the same statement I want to say again: knowledge is the power. Okay, knowledge is the power that can take you anywhere. It doesn't matter how much money you go. Money can come and go. Correct? Money can come and go. So who you know, correct? So I may know the president. I may know the vice president. That can come and go. If they're lost, you are lost. Correct? And other things that you have, the interpersonal skills, the people you know, kind of who are the people you got to know, the political influence, personal influence. So anything can come and go in our life.
knowledge is the only thing is going to stay until you die, until we all die, correct? And knowledge is the one makes you very commendable, correct? Like, people respect you a lot if you do right things, correct? And of course, there's always a dirty politics, but that's nothing that we can do. But the point is, knowledge is the power. I would encourage all of you, keep that as focus and study, learn as much as you can. And you will see that, correct? Without you realizing, there are many things will happen based on your knowledge, based on the power that you gain from the knowledge, okay? So let's just stay focused on that and see how much we are getting out of this session today. Okay, so today I want to focus on an exclusively machine learning models, okay? So that's the fundamental, that's the easy stepping stone to get into the space. And second, how do we deploy this one? Like, when I say deployment, how does it deploy it in real world, correct? It's just not building one model and saying that we're done with the model. So there is, like, many steps involved. Let's understand. Some of those technologies around, like, Kubeflow, Kubernetes, so those technologies plays a very vital role when it comes to deploying machine learning models. So just not only Python, there are other technology that is involved. I want to also make sure you understand that part. Second, there is the concept of deep learning. How does the deep learning differs from machine learning? Okay, I won't be able to spend too much time on that one because I feel that's going to be too advanced for you. I would encourage you to just stay in machine learning, learn and make yourself very comfortable. So before you go to deep learning, okay? So, but I want to touch this one. What's the difference between machine learning and deep learning? Few points, there's a lot more discussion to be involved, but at a high level, I want to touch so that you can understand. And based on how much interest you have, based on how much knowledge you gain on a machine learning, you can go to deep learning. The last one that I wanted to touch, data engineering. So that is, I would say, out of all the things that what I studied, learned, the most difficult skill to gain is a data engineering. What it means. So some of you answer the question, what is about Facebook? Is Facebook is creating a large amount of data? Answer is yes. So how do you take Facebook kind of a data and process? So when you go to Facebook, you have images, you have videos, you have voice, you have text, you have so many things. How do you connect all these data sets and how do you work with these data sets? So that's quite challenging. That is basically like the most difficult task that I have seen in my life of information technology or software engineering. So I wanted to touch these 3 points. Okay, so understand machine learning really well and see how it's been deployed in a real world example, and then find the difference between machine learning versus deep learning and data engineering. Again, these are all a guided approach. You could use this and build yourself. As I said at the beginning, if you go out and do Google or YouTube, there's a ton of information, but the message may not be very clearly structured, and then you will get lost. Okay, how do we go about it? So this is more of a structure so that you could understand how to deal with these things. Okay, so I'm just going to do a small recap and then we will go from there. So in the last session, we studied about artificial intelligence. So what is it? It is very simple. It's nothing but creating intelligence artificially. What kind of intelligence we are creating, correct? Like we talked about, it could be an intelligence, reading is an intelligence, writing is an intelligence, cooking is an intelligence, driving a car is an intelligence, diagnosing medical problem is an intelligence, disease condition is an intelligence, correct? See, anything that you go for a formal, informal training and gain knowledge, so those are all human intelligence, okay? So when a human reacts based on a situation, such as when you saw a snake, you are going to run away, or when you see something funny in front of you, start laughing. So these are all intelligence that doesn't have to be a formal training, or it has to be doesn't have to be an informal training. So you learn over a period of time on your maturity, correct? On your maturity. So those are all emotional intelligence. So basically, what we are saying, by definition, when we say artificial intelligence, correct? Either it's an alternate or in a substitute or in a replacement for emotional human intelligence or any intelligence what you could think of. I know it's a very broader statement, but that is how it's going to be in the future. Okay? That is how it's going to be featured. We can debate who's superior. Is machine is superior or human is superior? Can the machine could do better than a human? Answer is some tasks could be machine better, some tasks human could be better. So it's all debatable, but the point is where we are leading towards. So we wanted to find an alternate to human intelligence. We wanted to find a substitute to human intelligence. I'm not saying we are going to replace, but that may happen, no question. Okay, no question how the way it's going. For example, the autonomous car, when autonomous car come mainstream, okay, when it comes to mainstream, right now it is not in a mainstream. Still, we have drivers who's driving the car. Okay, you could imagine how the world is going to look, right? If a car everywhere in the world, okay, if the car is drives by itself and no driver is in the driver's seat, correct? Then what does that mean? Correct? Like, why do I need a driver's seat? Okay, why do I need a driver's seat? Correct? So like this, there's a lot of things are not known at this point, but it's leading towards getting into bigger, getting into better. So there will be time that we'll look back and see, like, where we started, where we are, and how it's going to be. So I'm just saying it is debatable, but the point is it is an alternate or a substitute. Ultimately, it could be a replacement for human intelligence or an emotional intelligence. All right. As a concept, we understood, but how does it apply in industry? Okay, when you go out in the business, when you go out in industry, I can say I'm going to replace a human. That doesn't make any sense. But it has to be done in a way. In what form this going to be deployed? So option one, either it's intelligent automation. Option two, either as a data science. Okay. So what is an intelligent automation? What is a data science? Intelligent automation, an automation that occurs without any human intervention, any manual work. Okay. So for example, if you look at a self-driving car, there is no human sitting driving the car. So that means it's a driverless car. Manual work, the car starts and stops by itself. What does it mean? When it sees a red light, it stops. When it sees a green light, it goes. When it sees a yellow light, it slows down. So that is basically not a manual work. You're not dictating, you're not doing anything for the car to function like that. Okay? So there is no manual work involved. Such automations are an intelligent automation. Okay? And those automations are self-learning. That means as and when things happens, it learns by itself. When a car goes on a constant speed, when it sees an object in front of it, okay, the object could be an animal, object could be a human, object could be another car. It acts, it controls by itself, it slows down, or it stops, it does something. Okay, so those are all self-learning. Okay, those are all, we don't know when that is going to happen. These are like crossing an object which crosses in front of the car. We don't know when that's going to happen. If and when it happened, it should know what to do. So that's basically learns by itself, self-learns by itself. Okay, so that is basically the key elements of an intelligent automation. The key elements of an intelligent automation. An automation that occurs, okay, an automation that occurs without any manual human intervention, and it self-learns by itself. That's the key to understand when people talk about intelligent automation. The second is data science. What is the data science? A data science is nothing but, okay, extracting hidden insights on data. We never ever, okay, in the future, in the past, we have not used applying science on data. When we say applying science and data, so what we study in science, we study mathematics, we study probability, we study statistics, correct? So these are all part of science discipline, correct? So we have science and humanities, we have engineering, we have mechanical engineering, we have civil engineering, we have construction engineering, we have XYZ engineering, correct? So those are all engineering disciplines. If you see in science and humanities, mathematics, physics, chemistry, computer science, so these are all different kind of science and humanities. So the reason why it is called data science, you apply science on data. What kind of science we are applying? Such as random forest, decision tree, logistic regression, neural net. What is this? So these are all statistical data analysis, data modeling techniques. Okay. So how do you use these kind of technique to extract hidden insights on data? How do you use these kind of statistical tools to extract hidden insights data? So the objective of data science is not building deeper advanced and automation. Instead of building an automation, you look and dig deeper and identify what is the hidden insights in a given data sets and large complex data sets. So basically what it is, applying science on data to extract hidden insights. That's exactly what data science. Example, when a patient goes to an hospital, the doctor, before the doctor comes and sees the patient, so there will be a machine learning model. There will be some kind of an algorithm which runs the model and determines how long the patient is going to be in the hospitalized based on the patient health, fitness, physical behavior, mental, etc. Okay, it looks at everything and tells, so the length of stay for the patient, most likely 2 to 3 days. Okay, the discharge rate for this person, it's going to be make it happen in a day itself. It depends on how this person is behaving. So these kind of extracting insights on data is the key. Okay, so you can find out Things like how long a patient can stay in a hospital, that's the length of stay. How soon a patient can be discharged, that's the discharge rate. How soon a patient can be readmitted based on he or she what they're doing. So that's basically like occupancy, bed occupancy. So like this, you can extract hidden insights. Those are the data science. So when you combine these two, you could create a digital transformation. So in the last class, we talked about either using Uber as an example or DoorDash an example. So why it is called digital transformation? If you take Uber, based on you were the location from where you have to pick up, the location where you have to drop off, and then the geography and the time zone, the currency, everything the machine automatically figures out. You don't have to dictate, you don't have to program, you don't have to tell anything, correct? So it figures that out automatically. I told an example. I am here in California, Sacramento, California. My family back in India. So I can book a taxi for my family back in India, correct? I don't have to go to India to book this taxi. So while I'm in Sacramento, California, I am booking a taxi for my family back in India. I can tell the pickup location, I can tell the drop-off location, I can tell the time to pick up. So it automatically figures out. If you look at the entire process, there's no manual work, there's no human intervention, there's everything fully end-to-end automated. And also the intelligence is built in. So the intelligence built in is like, it figures out the location, it figures out the currency, it figures out the time zone, because the time zone in India is different than here. The currencies in India is different than here. Even though I may have a credit card attached to my file, but the credit card is based on US dollars, but the transactions takes place in Indian rupee. Correct? So the system automatically understands that's everything. So that's a true digital platform. The information travels from A to B without any manual human intervention. So we studied that too. Okay. All right. So we also studied about how do we teach the machine, or how do we create the intelligence? Very simple, teach the machine instead of a human. Okay. So what's happening in our current school system? In current school system, we study that the teacher comes and teach the students and make the students as a human intelligence. Correct? But that's not the case in the future. You don't have to be a programmer. You don't have to be a software engineer. You don't have to be a developer. Correct? Instead of you teach the machine. Let the machine do the same thing what you're doing. Correct? So the point is, how do we create such intelligence artificially? Correct? So to create that intelligence artificially, instead of teaching a human, you teach a machine. How do you teach a machine? Train the machine. How do we train the machine? That's what machine learning. That's what machine learning. Let's move on. So how the machine is going to be trained? Okay. So based on what the machine learns, you can classify them into 5 different groups. Okay. So based on what the machine learns, we can classify them into 5 different groups. So in this last session, I told 3 and I want you to find out 2. I hope you did this. I haven't really looked at your answers, but we can look at in the afternoon. Okay, if you expect the machine to learn about an image or an object or a video, then that falls under computer vision. Okay, so under computer vision, the machine learns about the characteristics or the features about in a video or an image. So for example, if you want to do a facial recognition, when a customer walks into your store, you can recognize the customer face and then greet the customer based on the customer profile. Okay? So when John is walking into my store, okay, so when John comes to a restaurant, okay, so that in the restaurant, I have in a machine learning model, a digital boardroom. So that basically looks at John's face and identifies John as a known customer. It greets them. Hey, John, how are you? Welcome back. And we have your favorite today. Okay, would you like to try this out today? Okay? So it builds a conversation. To build such a conversation, the machine needs to do facial recognition, gender detection, human detection, etc. So if you want to build such application, that falls under computer vision. So let's say I'm not interested in building a facial recognition, human detection, object detection, gender detection. I'm not interested, but I wanted to build a conversation. I told you, when John comes to my restaurant, I'm going to greet John. Hey, John, how are you doing? John says, yes, I'm doing well. How are you? I'm doing fine. What do you want? Like this, if you want to build a conversation, that has to be natural language processing. So natural language processing, under natural language processing, the machine learns and understands the languages. What kind of languages, whatever language that you want to teach the machine, both written and spoken, So here you do language modeling, sentence classification, words classification, etc. So that's part of the natural language processing. Robotic process automation. So what we talked about it, I want to make a sandwich. Okay, so I want to make a sandwich. I go to a sandwich place, okay? So let's say I'm going to Togo's. In Togo's, I'm saying I need a turkey sandwich. The sandwich maker asks me what size, regular size, what bread, white bread, and do you want a cheese? Yes, I want a cheese. Do you want mayonnaise and mustard? Yes, I want mayonnaise and mustard. What meat, turkey? Do you want vegetables like tomatoes, onions, pickles, like lettuce? Okay? So it asks you. At the end, they ask you, do you need salt and pepper? You see, it's a sequence of things that are going to happen, okay, to get a sandwich. Okay? So this sequence of things is nothing but a set of process that you are going to follow. You cannot change this process, correct? Like for example, if the sandwich maker doesn't ask you what bread, let's say he or she assume that you're going to use sourdough, okay? So, but you may not like this one. You may not like the sourdough. You like white bread, right? The sandwich maker didn't ask you. He or she put a roast beef. Let's say I don't like roast beef. I want a turkey. Like, see this one, you have to follow certain sequence, correct? If it's not, then you won't be able to make the sandwich, correct? So if you want to teach the machine to understand the end-to-end process in a business, then that's for robotic process automation. That's for robotic process automation. A robotic process automation, teaching the machine to understand process and make the machine to do the same thing what a human could do. Example I told you, one of the research that I'm involved, correct? One of the researches that involved in the future, like how do you see a vending machine where you can put a coin and get a soda? In the future, there will be machines to make sandwiches, fresh sandwiches in front of you without any human. So what does that mean? You build an industrial automation, build equipments at that magnitude where it creates a sandwich without a human, okay? So that's what you do in robotic process automation. Under robotic process automation, you teach the machine so the machine can understand how to make sandwiches. I'm just giving an example sandwich, but ultimately a sequence of steps to accomplish something, or a task to be accomplished something. So that is called processes. You teach the machine to understand the processes. So I hope you understand what computer vision does, what natural language process does, what robotic process automation does. Okay. So I told you to spend some time to come up with under-supervised, unsupervised reinforcement learning, what the machine is learning. Okay? So anyway, if you're not done, I will cover this today. And then we also told you to find out deep learning. So the bottom line message is, in all 5 cases, the machine learns. Okay, in all 5 cases, the machine learns. You are teaching the machine learns. So what you need to understand, what to teach, what kind of data you need, that's the key. So that's what I put it here. Okay, that's what I put it here. So anyway, when I send you the slides, you can go back and refresh and understand. But this is the core of the essence of so far what we discussed. Right? It covers everything. Make the machine to learn. Okay, through the machine learning techniques. What does the machine learning? Machine learns when we train the machine. Okay, what does the machine learns when you train the machine? So when you go to school, what are you doing? You are taking different subjects. What subject? Mathematics, physics, chemistry, biology, or language. Okay? Like this, you choose different subjects. Under mathematics, you study the mathematical parts. Okay? So like this, here also the machine learns and understands certain things. So that is what these are all about. Okay, that's what these are all about. All right. Okay, again, what I wanted to say, the same thing that what we discussed. In all 5 cases, the machine trained using data. The machine learns the patterns in the data sets. Based on the pattern that what it sees, it creates an algorithm that's called learning algorithm. That's called learning algorithm. So there are 5 different ways you can train the machine. When you train the machine using the data sets, what the machine does, it understands the pattern in a data sets. It understands the pattern in a data sets. Okay. So when it understands the pattern in the data sets, based on what it does, what it sees in the data sets, and it creates a learning algorithm. Okay. So think about this one. When we go further down, I will be asking questions. What is a pattern in a data set? Okay. You have to think through and tell me. What is a pattern in a data set? You have a large data set. So this is where statistics comes into picture. I'm sure some of you, may not be all, some of you studied about mean, mode, variance, okay? Standard deviation. So these are all things that you may have studied in your probability or in a statistics subjects, like based on how it's been course curriculum has been offered. I'm sure you have studied. If you have studied, and these are all very much falls into the same thing. So you see the pattern what in the data sets, then create an algorithm. If this happened, do this. If this doesn't happen, do this. If these are all combination of things that happen, do this one, okay? So that's kind of the learning algorithm. Okay, that's kind of the learning algorithm. So we talked in the last session the difference between traditional software engineering and AI-based software engineering. Okay? So your father, your mother, or your brother or sister, working in the IT field, ask them what they do. So either they be a programmer or an analyst or a database person or a project manager, etc. It has to be any one of these things, correct? So if they are an executive level, that's different. If they're not an executive level, if they are in the software industry or in information technology, either they do program, they do something correct in that area. So that's what we discussed. So in the context of software engineering, what is learning algorithm? Okay, you can make a note and tell me later. So there are two questions I'm asking you to think through. Number one, what is a pattern in a data set? What is a pattern in a data set? I just need one simple example. Second, in the context, okay, in the context of software engineering, information technology, so what we looked at, there is a traditional approach and an AI-based approach. In the traditional approach, what does learning algorithm means, or what learning algorithm represents in the traditional software engineering? So that's my question. Question number one, define what is a pattern in a data set. Define what is a pattern in a data set. Question number two, in the context of traditional software engineering, what does learning algorithm means? In the context of traditional software engineering, which we talked yesterday, what is a learning algorithm means? It's important. All right. All right. So one last point, then we'll jump on directly into machine learning applied. Okay. So we kept talking about teach the machine, train the machine, data, and all those things, correct? When you want to train a machine, what kind of data you'll be using? And we are going to study more this in detail on data engineering, okay? It is absolutely critical, okay? Absolutely critical you to understand this. You don't have to be a master, at least you can understand. Some of you told me some of you told answers to the quiz was asked by Kausal. So he was asking big data. Some of you did really well, okay? So what exactly all the things, okay? A collection of all together is the big data. A collection of all together is the big data. So what I'm trying to tell to you right now, we talked about what we talked about. In all 5 cases, the machine trained using data. The machine learns the pattern in the data. The machine develops learning algorithm based on the pattern in the data. You see, I have data, I have data, I have data. In all 3, the arrow, I put data here. So that means it plays a very significant key role. What kind of data we are talking? So these are different kind of data we are talking about. Structured, unstructured, semi-structured, videos, images, voice. Okay? Videos, image, voice. So I can bet, okay, what I'm trying to tell you, if anyone in the globe, okay, if anyone in the globe tells, I know anything, everything in data engineering, I can deal this kind of complex data, I would be surprised. There is not too many people can do this kind of work. Taking all these data sets and making the data available to the model, correct? It is not an easy task. It's a huge effort. And some cases it's practically impossible, okay? How do I take a specific customer information and see what the customer posted in LinkedIn, Facebook, Twitter in the form of an image, video, text and connect them? That is heck of a deal, correct? It's not that easy. So working with this large complex data set is the most difficult part, either in artificial intelligence or in data science kind of an approach, okay? If we want to build data science, such as going deeper, analyzing data, okay? That is what data science all about. To do that, we need all this data. In order to make that happen, you have to have all this data set in an interoperable form, So take this assignment also, what is an interoperability, and do some Google and tell me in the afternoon. What is interoperability, okay? What is interoperability? So that is a critical thinking, okay? So you don't have to be a master in those areas, but understand what is an interoperability. So in order for me to extract data from insights from this data, which is data science, I have to interoperate all the data sets together. If I am a data scientist, okay, and I work in this kind of complex data sets, what I have to do, I have to build an interoperability across all data sets. Example, I'm trying to build in a customer engagement platform. So what customer like, what customer don't like. Under the cases, a customer feedback could be in a pre-form text. A customer feedback could be in a voicemail. A customer feedback could be in an email. A customer feedback could be in a video. Who knows what it is, okay? So, or it could be in an image. They just take a picture and send it to me. That's the feedback they're saying. Like, look how ugly this is, correct? All these are all matters. How do you connect all in order to get a customer sentiment or a customer feedback about your product, about your service, about whatever things you do? In that case, I have to interoperate in all the data. That become quite a challenging task to achieve. Okay, it doesn't matter whether you are working at Google or Facebook, or it doesn't matter, irrelevant at this point, right? Irrelevant. It is not where you are working. It's about the deep skill you have to work in large complex data sets. That skill I'm saying vital. That skill I'm saying doesn't exist at a magnitude what we need. It's all trial and error, do this and do that kind of thing. As a student, I would encourage you to focus data engineering as well. Okay? As a student, I would encourage you to focus on these skills because this is very vital skill. Okay, very vital skills. All right. So this is just kind of a recap. I'm going to move on. Any questions so far? Is it bring you all up to speed? Whatever happened last day?
Yes.
Wonderful, wonderful. Let's move on. So now we are talking about machine learning applied. Okay, so this is very focused topic. I really want to stay with this and make you very comfortable. Even if you just study only this, it's worth it. I want you to make sure you are very comfortable. Instead of going out and teaching too many things, let's stay focused on this one. As much time we need to spend on this one, I'm committed, we'll make it happen. And this also involves a lab, we'll do that too. All right, so the type of machine learning that what we looked at, supervised, unsupervised reinforcement. People also talk about semi-supervised, which doesn't require at this point. You can use supervised or unsupervised to solve this kind of problem. You can use deep learning. So don't worry about if someone talks about a semi-supervised machine learning, ignore that. It's not really required. So in a practical usage, this is the main type of machine learning that you do. Okay, either it could be a supervised machine learning or it could be unsupervised machine learning or a reinforcement learning. So let's understand what exactly it means, each one. So now we are talking about a supervised machine learning. Okay, so the name itself says it's a supervised. Okay, what exactly it means? So when you go to school, what happened in the school? So the teacher monitors you. Okay, when a teacher takes a class, what happened? You are not allowed to speak to other people, and you are not allowed to eat your lunch or snacks. Correct? So that means you are under strict supervisor. Okay, yeah, so strict supervision. So that means you have to follow the guideline. You cannot just like that open your lunchbox and eat while the teacher is teaching you. Correct? That's not going to work. And you cannot really talk to somebody when the teacher is teaching you. That's not going to work. You will get points. You will kicked out. Correct? So like this, under supervised machine learning, the machine learns the patterns in the data sets with the very strict guided rules. And that is why it's a supervised machine learning. What kind of rules we are going to talk about it. Okay, so under supervised machine learning, the machine has to have a goal to achieve. Okay, you can't really have a model without a goal. There must be an expected outcome and a goal to achieve. Okay, that's rule number 2. Okay, rule number 2. So the machine has a guided approach to follow. That means when you go to school, you have to follow whatever the rules and regulation in the school. As per rules and regulation, when a teacher takes a class, you are not allowed to open your lunchbox and eat lunch. You're not allowed to talk to people. So those are all different set of rule. And here also different set of rule. So that's the point 1 to consider. Point 2, under supervised machine learning, the machine has a goal to achieve. The machine has an outcome to produce. Okay, that's a must one. Okay, all right. So the next point, under the supervised machine learning, the data set what you provide has to have specific characteristics. Okay, has to have some characteristics. What kind of characteristics? The data what you are supplying, okay, the training data what you supply must have to have the label, which is the outcome. In the training data, okay, in the training data, you tell the machine, hey, these are the pattern to arrive this outcome. These are the pattern to arrive this goal, or these are the pattern to achieve this outcome. You have to dictate the machine. Okay, you have to dictate the machine. So that is why it is a guided approach, or an approach runs under a strict supervision. Okay, so the point 3, what it does, in this supervised machine learning, the machines, the training data what you supply for the machine to learn must have to have an outcome or a label. Okay, what does that mean? In order to arrive at a specific condition or a state or a goal, okay, you have to tell the hypothesis. So these are the patterns, these are the hypotheses to arrive this goal. Okay, you will see that. Okay, you will see that. So these are the key points to consider. Under supervised machine learning, the machine functions in a very strict, supervised, guided approach. What exactly means? When it learns with the goals and objective. I want to achieve this one. When you go to school, you have a goal. I want to be a doctor. I want to be an engineer. My mom is telling me to become an engineer. My dad is telling to become a doctor, correct? That is your goal. That's your objective. The same way here. When a machine learns, it has to have a goal. It has to have a goal. And second, in the training data what you supply, you have to dictate the hypothesis. You have to dictate the hypothesis. How do you dictate the hypothesis? That means the pattern that it should lead towards an outcome, an expected outcome. Okay, expected outcome. So this is something that you must have to understand what happens in a supervised machine learning. What kind of problem it solves? Okay, what kind of problem it solves? So can I solve every problem? Okay, can I solve every problem in the world? Answer is no. We may not be able to solve every problem in the world, but we have to understand. Okay, we have to understand. There are two types of problems typically solved using supervised machine learning: classification, regression. What is classification? 0 or 1, true or false, yes or no, male or female. Those are all classification. I am classifying yes or no. I am classifying true or false. I am classifying 0 or 1. I am classifying male or female. These are all classification. Okay, these are all classification. For example, whether the student is going to pass or fail. Okay, whether the student is going to pass or fail. We have a 70 student. We are going to conduct a quiz. Out of the 70 student, which student is going to pass and which student is going to fail? Correct? So that is yes or no. Is John is going to pass? Yes, John is going to pass. Is Lisa is going to pass? No, Lisa is going to fail. Is Mike is going to pass? No, Mike is going to fail. So see that one? It's a classification. I'm taking a data set. I'm trying to classify them. If that is what you are trying to do, a prediction, then it's a classification. Okay, then it is a classification. So I'm just saying, I'm going to give an image and I want to find out whether the given image is a male or female. That is a very commonly used example. You may have seen a lot of YouTube videos. So that is one thing that you can consider. It's a classification. Whether the patient is going to die or live, that's a classification. Okay, that's a classification. When a patient comes to an hospital, I want to run a model based on the severity of the health and illness. I'm going to run a model. It tells me the probability of the patient is going to live or die. Yes, this patient is going to live or it's going to die, okay, etc. So keep in mind, these are all classification problems. These are all classification problem. Regression problem. What is a regression problem? So regression problems are nothing but a problem has a continuous value. Okay, a continuous value. It is not 0 or 1. It is not true or false. It is not male or female. It is not cat or dog. It is not like 0 or 1 like this. It's not like that. Okay, it is not like that. It is a continuous range. For example, when I say continuous range of value, what exactly it means? What is going to be Lisa's grade? I'm sure based on her performance should be B to A. Okay, either she can get a A or a B. It depends on how she's doing so far. Okay, how about like the patient length of stay? How long a patient can stay in the hospital? It could be 5 to 7 days. It depends on how the patient is behaving, health condition is cooperating. The length of stay, it is not in a defined number. It could be range. The grade that what a student is getting on a specific subject on a predictive model, it could be a range. Right? You see the difference? The difference in this case, a classification is 0 or 1, true or false, yes or no, etc. And a regression is not that. A regression is basically, it's a range of value. Okay, a range of value. So what kind of, any questions? Do you guys understand the difference? It's a key point to understand, classification and regression. Do you guys understand? Do you understand?
Yes.
Yeah. Okay, I'm telling you, if you have to go and look for a material in the internet, nothing comes close to what we have. Okay, it's well thought through. We just get to the point and talks about it. So please ask me if you have any questions. All right. So these are the, yes. So there's a question from Meha. What's going on, Meha? Can you hear us? Okay. See that. Yes.
Can you go over the main difference between classification and regression? Another
Sure.
one.
No problem. So the classifications are problems which has, like, first of all, the supervised machine learning must have to produce an outcome, correct? Must have to produce an outcome. That's the point I want to think. It's not that when you run a supervised machine learning model, that model must have to produce an outcome. What kind of outcome it can produce? It can produce an outcome such as 0 or 1, true or false, yes or no, male or female, cat or dog. It is a classified outcome. If the classified outcome is what you are going to get by running this model, that kind of problems are classification problem. Example, okay? Whether the student is going to pass or fail, that is the predictive model I'm going to run for the entire 72 students in the class. I'm taking Lisa. Is Lisa's going to pass or fail? She's going to fail. Okay, see the answer? It just, no, she's not going to pass, she's going to fail.
Yeah.
How about Mike? Yes, Mike is going to pass. How about John? John is going to fail. You see my answer? Yes, pass. No, fail. Yes, pass. No, fail. Only discrete two answers, correct? Either yes or no, correct? I'm not expecting anything. If my outcome, okay, the model predicted outcome is going to be yes or no, 0 or 1, or true or false, cat or dog, male or female, etc. If it has only two values, then that's a classification problem. Okay, so that is a classification problem. So let's look at the other way. Out of the 70 student, we are going to conduct a quiz. Based on the quiz, we are going to grade them. Okay, on a scale of 1 to 5. 1 means poor, 5 means excellent. Okay, we haven't conducted the quiz, but we are running a predictive model, which is going to predict and tell. So out of the 72 student, what is the grade of each of the students? So this is not going to be yes or no, true or false, 0 or 1. It's going to be a range. So the range could be, yes, Lisa is going to get somewhere between C and B. Mike is going to be somewhere between B and A. John is going to be between C and D. So that's a range I'm giving. Okay. Yeah. So now you see the difference between a classification and regression. Classification is a very straight yes or no, true or false, male or female, etc. Regression, it's a range. Okay. And this goes to Kaushal was talking about in the morning: statistics, probability, mathematics. These are all falls under those core concepts. Okay, core concept. But point what I want you to understand: when you run a supervised machine learning model, the model must have to produce an outcome. Must have to produce an outcome. What outcome it's going to produce? Is that outcome is a classified values, or is the outcome is a range of value? If it is a classified true or false value, then it is a classification problem that you're solving. If the outcome of the model is going to be a range of value, then it's a regression problem you're solving. Hope this helps you.
Yeah, this really does. Thank you.
No worries, my friends. All right. Some of the model that what you could run, okay? Under supervised machine learning, if I wanted to build, okay? Under supervised machine learning, if I wanted to build models, what kind of model I could build? So this is what we talked in the morning: decision tree, random forest, logistic regression, linear regression, etc. Okay, so these are the kind of models you can implement. Again, there are two focus. You can build the model by yourself, or you can use the model. For example, Google TensorFlow, Google's TFX, scikit-learn. So these library already have this model, so you don't have to reinvent this one. All you have to do, use those models and train the machine and solve the problems. Okay? That one approach. Second approach, no heck, I don't want to use Google's TensorFlow. I want to build my own classifier. Okay. In that case, you can write anything, everything that whatever happened, the algorithm insights on your own models. Okay. So what I'm trying to tell you, under supervised machine learning, you can use some of these models. So these models that what we are talking about are used to solve classification regression problem. So for example, for a classification, I can use a decision tree, I can use a random forest, I can use a logistic regression. For a regression problem, I can use a linear regression. I can use a linear regression. So these are all statistical data analysis, data modeling technique. And these techniques already available for you to use. That is where TensorFlow comes into picture. That is where TFX comes into picture. Scikit-learn comes into picture, etc. You can use them. Correct? So these are all already available either as a open source or in a proprietary product from the vendor. You can use them. For example, so I'm currently working in a project with SAP. So they have their own way of implementing a decision tree. They have their own way of implementing a linear regression. So it is not common across the board. You can write on your own algorithm. So these are all classifiers, correct? It's like a function. It's like a black box. You give a set of data, it learns and comes and predicts and tells what it is, correct? So that is basically what it is. In the traditional software world, if you ask your mom and dad or sister or brother, they all know in some form of function calls, okay? In some form of function calls. So what is these guys? So these guys are built-in functions available readily for you to use to run the predictive model, okay? I want to run a predictive model to predict the length of stay of a patient. I want to run a predictive model to predict whether John is going to pass or fail. I want to run a predictive model to determine the grade of every student that's in the class, correct? So like this, you can run a different predictive model, but the point is, you don't have to build this classifier. You can use the classifiers. So these classifiers are already available in the form of an open source product or a proprietary product based on the vendor that you're going to deal with, all right? So what are some of the industry use cases? These use cases we talked about is length of stay, patient risk, okay, customer churn, how soon it, which customer is going to churn, okay, and when they're going to churn, etc. So whether the customer is going to churn, yes, this customer is going to churn. When they're going to churn, in 2 to 3 months or 3 to 4 months, like this, you can tell. All right. So these are some of the use cases. The implementation I will cover later. I have one actual live demo. I will walk you through that one. So this is basically what you need to know as a student to get started with supervised machine learning. I would encourage this the first stepping stone. Okay, take an assignment. So the assignment, what I want you to do, give me a few examples for classification problem. Give me a few examples for regression problem. Okay, so based on your day-to-day life. Okay, based on your day-to-day life, give me some examples for a classification problem. Give me some examples for regression problem. So classification problem in my world, whether John is going to pass or fail. Okay, that is a classification problem. Okay, whether the patient is going to live or die, that's a classification problem. Okay, whether the patient is going to live or die, that's a classification problem. So now in the other side, so how long the patient going to stay in the hospital, that's the length of stay. That is basically a regression problem. What is going to be Lisa's grade? Is it going to be a grade of B to C, or what kind of grades is going to get? So that's a regression problem. Like this, I want you to give some example so that you can think about it, you can come up with this. Any question on supervised machine learning? Any questions? Are you guys clear?
Yeah, it's clear.
Yeah, it's clear.
It's clear.
Awesome, awesome. I love your energy.
Hello.
Yes, sir. How are you?
I'm good. I'm a panelist. There are some questions in Q&A.
Okay, ask. What is the question?
So Vinoy is saying, does classifying into 4 types of grades, like 4 values, A, B, C, D, will that be a classification?
No, it's not a classification. Classification has to be only 2. Okay, it's a binary, 0 or 1. That's it. So those are all going to be regression. Any range of values. Okay, if you are not sure, the range of values is going to be regression.
And thank you. And an anonymous attendee said,
Who's that anonymous attendee?
I don't know. Yeah. How do the models work and what do they do?
Okay, so that's a magic. So we will show you in the demo. I will show you in the demo. Mr. Anonymous User, can you please come forward and tell us who you are?
Yeah, I mean, I don't know who that is.
All right, so we will show them actually how the model works and all. So that's a black box. Okay, so any other questions?
Yeah, which models are classification and which ones fall under regression?
So I gave some examples. The example that I gave you for a classification, you can use decision tree, random forest, logistic regression. That's just an example, few examples. Okay. So for the regression problem, use linear regression. Okay, use linear regressions. So that's just to get started. Okay, that just to get started. Instead of going too broad, let's make sure you learn and practice. Once you understand how to build an end-to-end model and deploy them, you can build anything, everything what you want to. To get started, these models are more than enough. So I would encourage, after the demo today, I would encourage pick one model. It could be decision tree, very simple and easy to implement for a classification, and linear regression for a regression problem. So take these two models, implement with a specific objective, so that you can learn this well.
Yeah.
Any other questions?
Could you repeat the classification models?
Sure. Classification models are decision tree, random forest, logistic regression.
Okay. Thank you.
No problem. I would say that's a good start until you feel comfortable. Okay, if you go too broad, too much, then you lose everything. Okay, you lose everything. Just do only classification problem for now so that you can understand. And based on your interest, reach out to me. Okay, I look for quality people who's interested to do research. We can talk more. All right, any questions?
Sir, what is your email? And if we want to reach you out, can you please tell us what your email is?
Sure. I will type it here. So this is my personal email. Okay, I'm also in LinkedIn. So I teach at the UC, University of California. So if you want to reach out to me through LinkedIn also, it's fine.
All right, thank you very much.
No worries, thank you. All right, yes, any other questions? Okay, so let me quickly cover these topics and then we'll take a break. So it's already 11 o'clock. Okay, so now we talked about supervised machine learning. So what we talked about actually, we talked about basically the machine learns with a guided supervision, okay? In a guided rules. These are the rules we follow. So in order to train the machine, what we need a training data. In order to train the machine, okay, what I'm talking about, okay? So now we are talking about, okay, I'm using my PowerPoint. If you're not able to see, let me know, okay? So question is how to train the machine, okay? How to train the machine. So how to train the machine? Okay, to train the machine, what I need basically the training data, okay? So what we need a training data. So we need training data. We need training data. So we need training data. Okay, in order to train the machine, I need the training data. To test the machine, this is to train the machine. Okay, to train the machine. So to train the machine, I need the training data. Okay, to test the machine, okay, to test the machine, I need a test data. Okay, so this is for train the machine. This is for to test the machine. Okay, so I need a test data. Let's understand what is training data, what is a test data. Okay, what is a test data? So how do I train the machine? I need a training data. To test the machine, I need a test data. So basically what we are talking about, okay? So when we talk about data in the machine learning context, in the context of machine learning, okay, in the context of machine learning, in the context of machine learning, okay, in the context of, I'm just going to use ML. So we need two sets of data, okay? One is we need data, okay? We need data, correct? We need data. So what data we need? Okay, so we need two sets of data, training data and test data. Okay, we need training data and test data. So these are the two kind of data we need. Understand this point. Okay, we need training data to train the model. Okay, we need training data to train the model. So what this will come after the training. Okay, after the training. Okay, after the training. Okay, so the model will creates, okay, the model creates a learning algorithm. the model creates learning algorithm. Okay, learning algorithm. So the model creates a learning algorithm. Okay, once you've done the training, the model creates a learning algorithm. Okay, so you have to understand all these points. Okay, how does it work? I want to train the machine. So to train the machine, I need a test data, training data. So let's say after training, I want to test the model. So I'm done with the training. Now I'm going to test the model. So when I test the model, I need a test data. So what the model does, test outcome. Okay, outcome. Okay, or model outcome. Or keep the phone in mute. The phone in mute.
Oh, sorry. I accidentally unmuted myself.
No, that's fine. Yeah, can you keep the phone on mute? That's fine. So what I wanted to understand. So in the context of machine learning, we need data to train and test the model. We need data to train and test the model. Okay, test the model. So for that, we have a training data, we have test data, we have training data and test data. So once the model is trained, what happened? The model produces an outcome. So the model creates a learning algorithm. Using the learning algorithm, you test the data. Using the test data, you test the model and see the model outcome. So this will give the confidence level, accuracy. Okay, this will give accuracy and confidence level. In what confidence level the model is operating. Okay, this gives a confidence level and accuracy. Okay, so that's basically the overall flow we are going to talk right now. Okay, in the context of machine learning, we need data to train and test the model. The data that what is required for train is the training data. The data is required to test the model, it's going to be test data. At the end of the training, you'll have a learning algorithm. At the end of the testing, you have a test outcome or a model outcome, which is basically tells you the accuracy and confidence level. Okay, whether the model is predicting at a confidence level of 99.9% or how accurate this is. Okay, how accurate this is. So this is basically overall process what I'm talking about. Okay, you see here, I have training data. Okay, so what I'm trying to train, so this is basically telling the machine, okay, on a credit card statement or a bank statement, which statement is valid, which statement is not valid. So let's say I'm looking at my banking statements. Okay, I'm looking at my banking statement. So I wanted to find out any fraud is there. Okay, that means if someone has done a transaction like me, okay, as of me using the credit card, somebody else used the credit card. I want to run a model to tell me out of all the transactions that I have, okay, which transaction is valid, which transaction is not valid. You see, so here I have the transaction ID, when the transaction took place, the date and the location where it took place, the amount and the card, whether the credit card is verified. So during the transaction where the signature is captured, if that is there, then it is a valid. So basically what I'm telling the machine, if this happens, if this occurs, if this occurs, if this occurs, if this occurs, then it is valid. If this doesn't have, then it is not valid. So this is what I call hypothesis. And this is what I call pattern in the data sets. And this is what the machine learns. And it understands the outcome. Okay. So you are giving a sample outcome and expecting the machine to learn. The last column that what you see, you don't have to be a last column. It could be anywhere. The last column that what you see, that's basically the objective outcome or the label, what it's called. Okay. So in a supervised machine learning, when you provide training data, the training data must have to represent the expected outcome of what the model is going to learn. Okay, and that is called labels. That is called labels and the output. Okay, that's called labels and output. So I'm just trying to tell you to make sure the model understands. If a valid transaction, if a transaction comes to be valid, it has to have a transaction date, transaction location, transaction amount, card verified, signature captured. That is a valid transaction. In some cases, the card may not be verified and signature may not be captured, and that is also valid. If a transaction posted, no amount, no card verified, no signature, that is not a valid transaction. So the machine learns and understands all these patterns. And based on this, it creates the learning algorithm. Okay, based on that, it creates learning.
Sir, I have a quick question. Sure. So, on the end, when you use ones and zeros, that's binary code. So, does the machine use
you don't have to be binary, it could be yes or no.
Oh, all right, perfect. Thanks.
You don't have to be binary. You don't have to be binary. But it has only two answers, yes or no, true or false.
So the machine analyzes that, and then it it uses that for continuing its processes, correct?
Answer is yes, but there is the more making it more efficient. Like for example, can so you can inside the model you can encode this into a numeric value. If these are all characteristical values, you can translate it to a numerical value. So yeah, so that is happening inside the program. When you write Python code, you can translate this into a numerical representation than a character representation.
All right, perfect.
The numerical representation makes the machine to learn faster and quicker.
All right, yeah, that makes sense. All right, thank
Yes.
you.
No worries, no worries. Lot of good questions. Lot of good questions. I think you guys are enjoying the session. Is that right?
Yes.
Yeah. Okay. All right. So, the supervised machine learning, correct? When you wanted to perform the supervised machine learning, when you want to implement supervised machine learning, so your job is to make sure you prepare training data and test data. When you prepare the training data for supervised machine learning, you have to make sure the training data represents the expected outcome that what the model is going to predict. Okay, it is absolutely must. So that is why it's called supervised machine learning. Basically, you are teaching the machine, if this happens, it is valid. If this happens, it is valid. If this happens, it is not valid. Okay, so the last column, don't think that it has to be last column. It could be anywhere. Okay, it could be anywhere. It could be any order. It doesn't matter. Okay, it could be any order. It could be any form. Okay, the last column in this case represents the outcome the model expected to predict. So what the model is doing, it learns the pattern and creates an algorithm, which is the learning algorithm. Okay, this is what training data. Now the test data. So in the test data, what I have, I don't have the expected outcome, and that is what the model is going to predict. You see my test data, I have everything. Okay, so this is the training data starts from 1000001, 1002, 3, 4, 5, etc. The test data starts from this one, okay, 2000, 2001, 2, 3, 4, etc. So it's completely different data sets. Okay, it's a completely different data sets. So it's the month of January, it's the month of February, okay, etc. So if you see here in the test data, I don't have the last column, which is basically the expected outcome. Okay, the expected outcome is not there. Since the expected outcome is not there, and that is what the machine expected to predict. Okay, that is what the machine expected to predict. So I'm going to give this data. Okay, I'm going to give this data. Now the machine is supposed to predict the last column, in this case, the output. Okay, whether the given transaction, such as 20001, is it valid? Yes, it's valid. No, it is not valid. 20002, is it valid? No, yes. Okay, 2003, yes, valid. No, valid. Like this, the machine has to do. So this is the test data. So I'm going back in order for it to build a model. Okay, in the context of machine learning. Okay, supervised machine learning. So we need to train and test the model. How do we train and test the model? I need a training data. I need a test data. The training data is basically data that is used for the model to learn and creates a learning algorithm. The test data is used to test how well the model learns and see the accuracy, prediction accuracy and confidence level. Okay, see the prediction accuracy and confidence level. So that is the model outcome. So you have to prepare this by yourself. Don't take something from Google, something from here and there. Okay, if you want to truly learn, take simple problem and construct this by yourself. As I said, I found the most difficult part is dealing with the data, not building the model, not the Python thing, correct? Like, Python could code it like, matter of one or 2 days. But dealing with the data and bringing the data sets together, making it work, it's quite challenging, okay? So what I'm trying to say, I hope you understand what is training data and test data for supervised machine learning, okay, for supervised machine learning. So here, the training data has the expected outcome, which is the label, so that the machine use that, learns and understands. If this happens, this transaction is valid. If this happens, the transaction is not valid. In the other cases, you are not telling the machine which is valid, which is not valid. You expect the machine to find out. So what we are talking about here, model engineering, feature engineering, model outcome, model validation, okay? So what we are talking about, these terms, I'm going to cover later. The terms that what we are using, model engineering, okay? Model engineering. So model engineering, that's the term we are using. Under the model engineering, so we have feature engineering. So we have feature engineering. So what is feature engineering? I'm going to cover this too. Okay, I'm going to cover this too. So feature engineering, then model training. Okay, model training, model testing, model outcome, model validation. Okay, all these are all part of the engineering process. All these are all part of the engineering process. So these are all part of the engineering process. So when people talk about model engineering, what is involved? Building model, training model, testing model, verifying the model outcome. And there's more into it, such as model pipeline, okay, etc. There's a lot of things involved. Okay, there's a lot of things involved. I'm just making you aware. So these are the terminologies we are talking right now. Okay, so what we are talking: building model, training model, testing model, and model outcome, model validation, model pipeline, etc. So these are definitely a core function for you to look at and understand. Okay, so I will be covering this later. Okay, I don't want you to feel like, oh my God, it's too much for me to deal these things. Okay, I don't want you to feel this. All right. So what we looked at right now, we looked at the supervised machine learning. The supervised machine learning, how the training data looks and how the test data looks. What are some of the use cases I talked about in the beginning? In the healthcare, length of stay. So that's basically a regression problem. How long the patient is going to stay. A readmission rate on a scale of 1 to 5. What is the rate of readmission? Discharge, behavioral pattern, value-based care, pay for performance. Right? So some of them are kind of a little bit heavy for you to understand. So these are some of the use cases that we could think of implementing through supervised machine learning. So the other side, customer buying product, whether the customer is going to buy the product, yes or no. No, this customer is not going to buy. Buying frequency, how often the customer can buy, 4 times in a month or 3 to 5 times in a month. Spending power, how much the customer can spend on my business. So maybe $100 a month. Okay, customer churn, whether the customer is going to stay with me or going to leave. This customer is going to leave. That is churn. Okay, sentiment, how they feel about it. Then positive, negative. Okay? On a scale of 1 to 5, 1 means worst, 5 means excellent. How they feel about me, how they think about my product. So like this, these are all different type of use cases we can build. So let's quickly recap. Okay, what is supervised machine learning? So the most simple, easy way to learn machine learning, start with the supervised machine learning. What is supervised machine learning? So it's very simple. Under supervised machine learning, the machine learns in a very strictly defined rules. Okay, under supervised machine learning, the machine learns with a very strictly defined rules. What is those rules are? Rule number 1, it must have to have an outcome. It must have to have an outcome. It has to have to produce an outcome. If the outcome is going to be produced 0 or 1, yes or no, true or false, that falls under classification. If the outcome is produced with a range of values, then that is going to be a regression. Okay, we have given example. So rule number 2, under the supervised machine learning, the training data must have to have a label. The label is nothing but an expected outcome. What the machine does, the machine learns the patterns and understands to arrive the outcome. What pattern I need, and it builds that logic. And that is basically the second rule, what we have to have. Rule number 1, it must have to have an outcome. Rule number 2, the training data must have to have a label or the expected outcome. So those are the 2 rules we wanted. We talked about type of problem it solves, classification, regression. Different type of model for classification, we can use decision tree, random forest, logistic regression. For a regression, we can use linear regression. Some of the industry use cases, we talked about it. All right. Any questions?
No, good.
Okay, do you guys need a break or what? How do you feel?
Maybe a 5-minute break if they want to go to restroom.
Okay. All right. So let's take, what's time now? So 11:18. Okay, let's take about maybe 7.5 minutes break. How about 7.5 minutes or 7 minutes break?
Okay.
All right. So come back fast. After 7 minutes, we'll continue the session. Sure.
Yeah, dear students, I just want to tell you, can you all type your name in the chat window so that we can give the certification to all the participants? Can you type your some of the names are your parents' name or different name? So can you please all type your names in the chat window?
Okay, sir, 1 second.
Right. So Kaushal.
Yeah.
So at some point in time, whenever you feel comfortable, ask them to turn on the cameras and take a picture, like, so that I want to write about this, so that I can use this picture. So what I'm saying, ask the participants to turn their cameras on, and when you zoom in, you will get to see all of them.
Okay.
If you look at my LinkedIn, I had a session 2 weeks before. So that is for, like, third grader, fourth grader, fifth grader, that kind of people.
Okay.
We had around 150 to 60 something participants. So if you see, I put a picture in my LinkedIn and I wrote about it. So I want to do the same thing. So if you can check my link, you will see a picture. Similarly, if you could take, that would be great.
Okay.
All right. So can we get started?
Yeah, Jyoti, can we do it? Ask them to do the now. Take the picture.
Yeah, please do it.
Yeah.
Okay.
Okay. Let's.
So ask them to turn on.
No, you have to promote them to panelists first because they don't have access to camera to the panelists.
Yeah, that's fine. Do it.
Okay.
Do it. Ask them to put the digital banner. We send it to them, right? Or can we take after lunch so that they'll be getting ready?
Anything is fine. It's your call, Mr. Ramesh.
Yeah, we'll tell them, Kaushal. Okay, so everyone just have your digital banner ready. So as soon as after lunch, we'll just have a group picture. And overall, the participants, we are going to give a certificate, which has been endorsed by our San Roman Mayor, Mr. Bill Clarkson. He is going to endorse the certificate and give it to us. We'll give a e-certificate to all the participants. So be in the call to end of the session today. So after the lunch break, we'll just have a photo session and continue it.
Yes.
Okay.
So please make sure you stay till the end. You get the certificate, and also in case if you are looking for a college application or whatever, if you need any recommendation, please feel free. Let me know. So if there's anything that one might help, I'm happy to help you. You can check my LinkedIn if you wanted to connect with my LinkedIn. That's fine too. So ultimately, We are here to help you. We are here to make you to be very successful. That's all this is. Please stay till end and share your name and any other information that you think useful for the Bay Area Tamil Mandram. Please share all of those. All right, let's move on. So the next one, what we want to talk about, unsupervised machine learning. Okay. So what is unsupervised machine learning? Let's understand that. So under the supervised machine learning, the machine learns based on a very defined rule. Rule number one, it must have an outcome. Rule number two, the training data must have a label or an expected outcome so that it builds the pattern, it builds the hypothesis, which is a learning algorithm. In unsupervised machine learning, you don't have these two rules. Rule number one, there's no goal, there's no objective. Okay. Rule number two, the training data don't have to have a label or an expected outcome. If that is the case, what kind of problem we are solving? Okay. So under unsupervised machine learning, we don't have the rules what we had in the supervised machine learning. The rule that we had in the supervised machine learning, rule number one, it must have to produce an outcome. Rule number two, it has to have the label data, which is basically the outcome that what you expect from the model to predict. So in the unsupervised machine learning, you don't have any of these two. Okay, there's no expected outcome, there's no training data with the labels or an outcome. If such, then what kind of problem we are solving? Understand. Problem number one, clustering. Problem number one, clustering. Problem number two, association. Three, anomaly detection. Okay, anomaly detection. So what exactly clustering? What exactly association? What's an anomaly detection? So let's understand that part. So what is clustering? So clustering is nothing but finding similarity and groups them together. For example, okay, we have 72 students in the class right now. Out of 70 students, we want to have some kind of a cluster. How many people like math? How many people like, can you keep your phone in mute? Ladies and gentlemen, please keep your phone in mute. Kaushal, can you keep them mute?
Yeah. Actually, I think they are all muted right now.
Okay, all right. There was some noise, that's fine. So clustering, let's say we have a class of 72 students. So now I want to form the clusters based on an age group, okay, based on an age group. So how many people are in the age of 10 to 12? How many people in the age of 12 to 14? How many people in the age group of 14 and 15, etc. So that is one kind of a clustering that I'm forming based on an age group, okay, based on an age group. So other, I can form in a cluster. So what kind of cluster that could be? I can form this one. So the students who study really well, active participants, okay, the students active participant. How do we know? Based on the question they're asking for, based on the questions, based on the assignments, based on the quizzes, right? So these students are active participants. And I also want to form another one. So people are not active, but they are listening to the class. And I have formed another cluster. So people are not even participating, not even listening, for nothing. So I want to form this kind of clusters based on the data. Okay. So if that is the case, I can use clustering. Here I have no outcome. When I say outcome means I don't know how many clusters I'm going to form. So the machine figures this out by itself. Okay, the machine figures this out by itself. So basically what we are trying to say, you don't have a defined goal, pass or fail, 0 or 1, true or false, A or B, C or D. We don't have anything. Okay, I'm going to give a set of data. Based on the similarity, you form a cluster. The similarity could be an age group. The similarity could be something that based on a behavioral pattern or performance of the class, etc. So that is basically one way to look at how do we use clustering. Association. So what is this connected to which? Okay, I have set of data. Which data connected to what data? So let's say I have a cell phone call. So we got a cell phone bill. The cell phone bill basically for a family plan. Okay, so when I say family plan, so we have 4 people in a family. We all have the same common plan. Okay, we all have the same common plan. Our monthly bill is supposed to be $100, but this month we got a $1,000 bill. and it says we made 100,000 calls. That's impossible. There's no way that's possible. So we need to figure this out. How do we figure this out? Form an association. For the 100,000 call, who made the call? So take each call and associate this 4 calls, okay? And associate to this 4 calls. That's an association, okay? So I have 4 people in a family. The 4 people have family plan. So these family plan, based on monthly basis, I'm going to pay $100. But that's this month, this particular month, my bill is not $100, it's $1,000. Why? I made 100,000 calls. Oh my God, how did this happen? So now I want to find out the 100,000 calls made by only 4 people, because those are the 4 plans I have. So now I need to associate. Each call belongs to whom? So that's kind of an association. Okay, that's kind of an association. So here also, all you're trying to do, you're taking one data set and trying to see which data sets are more closely associated with this data set. Okay. So one side, we are doing similarity, and other side, which data set associated with the other data sets. Okay. So that is an association. So let's say another way. I have a credit card statement. Typically, I spend every month somewhere between $500 to $600. That's my credit card bill. But this month, my bill came almost $5,000. And there is one particular transaction which is made for $4,500. I didn't use my card for that much. But how did this happen? So that's anomaly detection. Finding an odd man out. Okay, finding an odd man out. So something that unusual. Something that unusual. In all 3 cases, either it's a clustering or an association or an anomaly detection, there is no defined set of goal. Okay, so there is no goal that you have to achieve. In the supervised machine learning, anything you do, okay, anything you do, it has to produce an outcome. Here, there's no anomaly, there's no association, there's no similarity. It could possible. Okay, it's all random data. If that happens, no outcome. If it happens, no outcome. So you are giving data sets, but there is no correlation. There is no correlation. There is no association. There's no anomaly. Okay? In that case, I don't have an outcome. I don't have an outcome. So point what I'm trying to make you understand, under unsupervised machine learning, there's no such rules as supervised machine learning. What those rules are? You don't have to produce an outcome. There's no objective to achieve. And second, the training data don't have to have a label or an outcome. If such, what kind of problem we can solve by using this one? So here we are talking about forming a cluster based on similarities, building an association based on the associated data sets together. Okay. The next, finding an odd man out. Out of all the things what I did, which one is odd? Okay. So these are the type of things you can do. What models we can use? I can use k-means clustering. I can use k-nearest neighborhood. Okay, so these are some of the samples of models you can use, you can explore. How does it work in a real world industry? How does it work in a real world industry? What kind of industry use cases you can build? Customer segmentation. Let's say I have a product. Okay, I have a product. So I want to launch the product to the market. Before I launch the product to the market, I want to know who likes this product. Is it Asians? Within Asians, is it Indian or Chinese? Who are the people who's going to like? Okay, within Indian community, what kind of people like? Is it male or female? It's male. In what age group? This age group. What location? This location. Like this, you can go on and on. That's the customer segmentation. Why am I segmenting? Based on a point of interest. Based on a point of interest, whether the customer is going to like or not. Okay, whether the customer is going to like or not. Target marketing. Who am I going to send this email? Okay, I don't want to send everybody. Okay, I don't want to send to everybody. I want to send it to only a group of people who has association to this particular product. Okay, to this particular product. Okay, so these are all some of these use cases that you could build. Okay, use cases you can build. Okay, let's summarize. Under unsupervised machine learning, the machine learns without any guided supervision. No rules to follow. When I say rules, in the supervised machine learning, you must have to follow 2 rules. One is the expected outcome. Second, the training data must have to have a label. Here, not required. Second point, this is not solving the problem like classification and regression. This solves a different problem, and a problem of clustering, a problem of association, a problem of anomaly detection. And what are some of the models that we can use? K-means clustering, K-nearest net. There are other models as well. Some of the industry use cases. So this is more for customer segmentation, target marketing, etc. So these are the things you can do by using supervised machine learning. Let's move on. So I told you the training data don't have to have a label. You can see the training data. You can see the test data. So the training data 1000 doesn't have a label. The test data 2000 also doesn't have a label. Okay? Why? There's no goal to achieve. Okay? All it's going to do, it's going to group the transaction based on what it sees as similarity. All valid could be one transaction, or not valid could be another transaction. It could be forming the two clusters. Okay? So how these are all working, we will talk more in detail later. Okay, but I want you to understand the concepts. Okay, how it forms the cluster, how many clusters it's going to form, etc. So that also we need to know. Okay, how it forms the cluster and how many clusters it could form. So we do need to understand that point. Okay, we need to understand that point. So that's part of the implementation. But right now, let's understand the concepts. Let's understand the concepts. Let's move on. The next one, reinforcement learning. The next one is reinforcement learning. So what is the reinforcement learning does? As a concept, let's understand. So we know what is supervised, what is unsupervised. So as a concept, we understand.
I have a question.
Yes, please go ahead.
About the clustering and the association, which models are for each one?
So the model that you could use for clustering, K-means clustering you can use, and K-nearest net you can use. And for association, you can use a hierarchical clustering because it forms the association of the hierarchy. Like for example, in a school, if you go to school, you have principal, you have a you have vice principal, you have a register, you have like a teacher, you have a student, right? So when you have data sets like this, it forms a hierarchy. It gives an association. So you can use hierarchical clustering.
All right, thank you.
No problem. All right. So the next one, what we are trying to talk about, we are talking about reinforcement learning. So what is reinforcement learning? Let's understand this one. So the best way to understand this before you even touch the concept. So let's take an example. Okay, let's take an example, the self-driving car. Okay. So how does the car changes the lane? Okay, the car is going in a lane, like there are 3 lanes in a track, right? So there are 3 lanes when on a road. The car is in the middle lane. Okay, the car is in the middle lane. Now the car wanted to change either a right-hand side or a left-hand side. Okay, that's the decision the car has to make. Because the car in front of me it's going very slow. Okay, I know there's no traffic. I can change the lane, I can go fast. So now the car has to make a change to the lane. Okay, understand the problem. So the self-driving car is in a road. So the car is going on a constant speed. Now it's slowing down because there's a car in front of me, it goes very slow. It doesn't mean that I have to follow the same speed, but I can change my lane and go fast. Now the car is trying to make it change the lane. So how does it make it change the lane? It does the object detection. So it looks on the back side. Is there any car coming in? No. It looks like, is there any car on the left-hand side or right-hand side? No. Then it changes the lane. No question. That's fine. Awesome. Car is successful. Everything looks great. Done deal. Now let's take an example. Now the car is trying to change the lane. It looks on the back. There is another car coming. The distance between this car and the car behind, it's about 10 meters. Okay, I'm just giving you an example, 10 meters. So now the car has to make a decision. Is the 10 meters sufficient for me to make a change? Because I don't want to get into accidents. The car should not get into accident. So the car says 10 meters is sufficient. I'm going to go ahead and make a change. It changes successfully, no problem. No problem. All right. So now the car is going on a constant speed. It crossed the car in front of it. Now it came back to the middle lane again. Okay. So now the car, what happens? Okay. Now the car, what happens? It has to again change the lane. What happened? There is another car in front of me. It just goes very slow. I want to change my lane. So this time what happened? it looks for back, looks for the side. How does it look? So these are all object detection, image detection, correct? It looks for any image on the back side. It looks for any objects on the back side. Okay, yes, there is an image coming which appears to be a car. What is the distance? It is not 10 meter, it's about 5 meter. So now I'm trying to make a change. Now the car got into accidents. Why? So the 5 meter to change the lane, it is not sufficient. It is not sufficient. So point one to consider, the car is constantly make a decision. That is what reinforcement learning. You learn and make a decision. You learn and make a decision. The car is constantly make a change in the lane. Every time when it want to make a change in the lane, it learns. What it learns? The distance between the car, your car and the car behind you. What is the distance? Is there any object coming in? Is there any object on the right hand side and left hand side? Then make a change. So once it moved, change the lane, then again it want to change the lane. You see that decision of making a change until the car stops, it's a constant sequential continuous decision. If we have a problem such that, in a way to solve this one, okay? If we have such problems where you have to make a constant decision, okay, where you have to make a constant decision, then you will be using reinforcement learning. So this is the best way to understand. In order to implement a reinforcement model, there are certain basic building blocks that's required. So what is those building blocks? Number one, an agent. Number two, an environment. Number three, an action. Number four, positive score. Number five, negative score. Okay, so these are all. So by definition, reinforcement learning is a continuous decision on a trial and error, or an exploration on exploitation, or an exploration, exploitation. So when say reinforcement learning, the reinforcement learning is nothing but a continuous decision based on a trial and error or an exploration on exploitation. So what is an exploration? What is an exploitation? Exploration, it is nothing but trying out something new. Exploitation, just going with what you already know. Going with what you already know, okay? For example, so I want to go from Fremont to Cupertino, okay? There could be 100 different paths. I want to go from Fremont to Cupertino. There could be 100 different paths. So I know I have a specific route. I'm quite comfortable. I'm going to take that route. So that is exploitation. Why? You are just taking what you already know. Exploration, I'm not going to take this route because it could be heavy traffic. I'm going to explore something new. So that something new is basically, it's an exploration. You are trying it out. So this is the trial and error. So under reinforcement learning, the model learns on a trial and error. The model learns on a trial and error. During the trial and error, if the model achieves what it wanted to achieve, then it gets a positive score. If the model failed to achieve, then it gets a negative score. The goal is to get as much as positive score to build a hypothesis. To build a hypothesis. What is hypothesis? An approach to solve the problem. An approach to solve the problem. So how do I arrive that approach? You get the maximum possible positive score. Then you will be successful. In our case, when a car was on a 10-meter distance, the car behind is a 10-meter distance. At the time, I was able to successfully, the car was able to successfully make a change in lane. That is a positive score. When the distance, the car behind me, only 5 meters. At that time, the car was not able to successfully change the lane. It met into an accident. So that's a negative score. Okay, that's a negative score. So understand the type of problem what you're solving. Ladies and gentlemen, don't get confused with supervised, unsupervised reinforcement. Ignore the names. Understand the type of problem what you solve in each of those models. That is most critical. Okay, understand the type of problem what you're solving. If you are trying to build a model where the model has to make a constant decision, driving a car is a constant decision. Why? You have to follow the rules. You have to make a change. Okay, change the lane. Following the rules is what? Okay, red light, stop. Green light, go. Yellow light, slow down. When you see an object in front of you, when you see a dog, when you see an animal, when you see something, slow down or stop. So these are all constant decisions. These are all constant decisions. So if you are going to solve a problem of this type, then you will be using reinforcement learning. Under reinforcement learning, the model tries different things, either in a trial and error or in exploration and exploitation. Exploration, it's going to try something new. When it tries something new, if it is succeeds or if it achieves goals, then it gets a positive score. If it doesn't able to achieve the goal or an objective, it gets a negative score. In the overall process, the model has to gain as much as positive score. That's what the concept behind reinforcement learning.
Excuse me, I have a question.
Sure.
Regarding this.
Yes, please go ahead.
Yeah, so my question was, when you said it has to do like trial and error and it's going for positive, negative score.
Sure.
So in the field of like self-driving cars, how would they do that if it got like a negative score? How would you train the car without causing any like danger issues for like other travelers on the road? Or like how would you train that in a safe environment?
Sure. So the training the car is not like taking a car and putting it in the ground and drive around. That's a software, correct? So I hope you understand that part.
Okay.
So like for example, let's take you as an example. So if you want to learn driving, what you do, you take a driving class. You go ahead and call the driving institute, get registered, and put a schedule in place.
Mm-hmm.
So they come and pick you. So they take you around different places. They will teach you, okay, hey, follow this, do that, correct?
Mm-hmm.
So that is for a human intelligence. For a machine intelligence, we are not going to take the car and teach the car how to drive. So it's a software runs inside the car, okay? So that is what we have to train. So the software which runs inside the car, it's basically what is the intelligence we are trying to create. So how do I train? And that is what these guys, you see the agent, you see the environment, you see the action, you see the score. So those are all building blocks. So in order to make the car to be trained so that it make it change the lane effectively, understands what distance, under what distance I can make a change. If it is a freeway, I can make a change within 10 meters. If it is in a city, I can change in less than 3 meters, because in city, the cars could be, there will be more cars. It could be 15 meters, something like that. Okay? So I'm just saying, training car, it is not taking the physical car and teaching them do this and do that. It's not like you.
Oh,
right?
it's like a physical environment, like a artificial environment.
Exactly. You have an environment. You build an environment, correct? So that basically an artificially created road condition. Okay. So that is what I'm going to talk now. Okay. So that is what I'm.
So, sir, what we're doing here is we're just trying to exemplify and replicate what a human brain would do in
Exactly.
the robot.
Exactly. So it's a fully simulated. It's fully simulated. So I'm not going to take the car. That has happened only for me to test the model. Okay, so I feel confident. I feel the model is achieving, and constantly the model is able to change within the environment. Let me complete and come back. Okay, so let's say if you want to build a reinforcement learning, how do we go ahead and build this one? So this is not like supervised machine learning where we can build a model and then train the model, test the model. So here I need an environment. Okay, I need an environment. An environment is nothing but something similar to the road condition. So when you are driving on, let's say you are driving in 101 North. So in 101 North, how does the road condition is going to look? Let's say you are driving in 880 South. How does the road condition is going to look? Let's say you're driving in 580 East. How does the road condition is going to look? Okay? So like this, you have to create an environment, okay, and a circumstances for the car to drive and learn, an artificially created environments. So the core building blocks to implement this: an agent, an environment, an action or a task, and a positive score, negative score. At least these are the core building blocks. What is an agent? In this case, the car is the agent. What is an environment? The condition under which the car is driving. I told you 101 south, that's a road condition. 880 south, that's a road condition. 580 east, that's a road condition. So those are all your environments. What is the task that the car is learning? Learn, changing. Changing and learn, okay? That is one kind of task it's doing. Is the car is able to successfully make a change under a given condition? The condition could be 5-meter distance between your car, the car behind you. Yes, I'm able to successfully make a change like that. So if it is successful, then it has positive score. No, it failed, then it gets a negative score. So the goal is to what? Gain as much as positive score. You continue to train the car with a distance of 10 meter, 11 meter, 9 meter, 8 meter, and see how many times it constantly gets a positive score between 11 to 8 meter distance of the car. Okay, there's a car behind you. So within that distance, how many times it gets a positive score? Out of 100 times, it got 98% positive score. So that means now the car is learned. The confidence level to change the car, the lane, it's 98%. Okay, so it's good to function. It's good to function. So that is how you build the model. So in order for you to implement, okay, what you need an agent, in this case the car. You need an environment, the road condition. You need an action that change the lane. Positive score every time when you make a change the lane. So you can change the lane when the car behind you within 5-mile distance, 6-mile distance, 7-mile distance, 8 mile, all the way to 11 mile. Then see on what distance you are successfully able to make the change. So 99.9% I'm able to change from 11 to 8 mile distance. So when the car behind me, between 11 to 8 mile distance, I'm able to successfully make a change. So that is basically what is called positive score. If I'm not able to make a change within that, then it's a negative score. The goal is what? Avoid negative score, gain as much as positive score. All right. So what kind of model I am going to use? Q learning, deep Q network. Okay. So deep Q network. So these are some of the models you can use. So I gave you one example of self-driving car. So you all know gaming industry. You all know gaming industry when you play games, correct? So you don't have a defined, like, hypothesis to solve something. You try it out, something, it works, it's great, it doesn't work, you will do something, correct? So when you want to play some games, you follow the same approach. If you are going to do a trial and error, and sometimes you do exploration, exploitation. So a lot of the gaming software could be built using reinforcement learning. So there is one most common example everybody references for reinforcement learning. I'm sure you all know. I want you to find out so that you could tell me after lunch. Okay. So the example that I use for reinforcement learning, okay, in this case, I'm using a self-driving autonomous car. So the example I picked up, lane change. How does a car learns changing a lane? So that is one of the best example that you could think of implementing reinforcement learning. In order to implement reinforcement learning, there are certain core building blocks you must have to have. So what is those core building blocks? Agent, environment, action, positive score, negative score. Okay, an agent, an environment, and a positive score and a negative score. So these are all core building blocks. So with that, you can able to implement reinforcement learning. So what are some of the models that we could use? Either you can use Q learning or a deep Q network. Under this model, what the actual model is doing, it makes a constant decision. When a car drives, it is not just 1 mile or a 2 mile. If you are going on 100 meters or 100 kilometers, 100 miles, so for the entire 100 mile, the car has to make a constant decision. When to change the lane, when to stop, when to go, okay? All these things, it's a constant decision. So if you wanted to implement or if you want to solve a problem where you have to make constant decision, for that, you must have to use reinforcement learning. The example I gave you, it's self-driving autonomous car. What I want you to do, I want you to give me an example which is very commonly used. I'm sure you all know, and some of you already played also. So think about it. Tell me another example for reinforcement learning. Let me summarize. Okay. So what we studied? So we studied about supervised machine learning, unsupervised machine learning, reinforcement learning. Supervised machine learning, the machine has a goal to achieve. The machine training data needs to be in a specific form, which should have to have an output or a label. So the problem type, what you can solve in a supervised, classification, regression problem. Classification, regression problem. Some of the models that you could use, decision tree, random forest, logistic regression for a classification. For regression, you could use linear regression. And there are more models, you can figure that out. Some of the industry use case, length of stay, customer segmentation, customer sentiment, etc. So these are some of the use cases what we looked at. All right. Under unsupervised, the machine doesn't have any goal to achieve. The training data don't have to have a label. So here, machine learns without any supervision. And machine, since doesn't have its goal to achieve, so there's no label data expected. If such, what kind of problem we are solving? We are solving a clustering problem, or we are solving an association problem, or we are solving an anomaly detection. Okay, some of the models are k-mean clustering, k-nearest neighbors. In terms of industry use cases, customer segmentation, how do we segment the customer? What is going to be my target marketing? Okay, what would be target marketing? So those are some of the use cases. The last one, reinforcement learning. So here, I'm not solving classification problem. I'm not solving regression problem. I'm not solving clustering problem. I'm not solving association problem. I'm not doing anomaly detection. I'm solving a problem where a human intelligence, okay, instead of a human intelligence, a machine intelligence need to make a constant decision. The best example, it's driving a car. If you want to travel 100 miles, the entire 100 miles, you have to constantly take a decision, changing a lane, stopping a car, going fast, slowing down, etc. So all of those, it's a constant decision. All of those, it's a constant decision. So if you want to solve a problem where it requires a constant decision-making process, under that case, you can implement reinforcement learning. To implement reinforcement learning, there are some key building blocks, which is the agent, the environment, the positive score, a negative score, and a task to accomplish. Some of the models that we could implement, Q-learning, deep Q network. So I gave one example. I wanted to find out another most commonly used example for the reinforcement learning. Any questions? Any questions? All right. Okay, good. So I want you to do an example. So how does machine learning applied in the real world? Okay. So I wanted to start with something simple. Okay, something simple so that you can understand. And I also have a demo. Okay, I also have a demo. So maybe we could do the demo after the lunch. So now we understood. Okay, one second. So there is whatever we learn now, how do we apply? Okay, so otherwise it may not be going to be fun. Okay, it may not be going to be fun. So how do we apply this in a practical problem or in a real world? Correct? Like I said, there are many things we can do, but we have to get started somewhere. This is just a starting point. This is just a starting point. So how do we apply in a real world problems? The most common problem in majority of the places that you may have seen, predict the customer who will churn out within the next 3 months, 6 months, 9 months. So do you all know what is a customer churn? Can anyone tell what's a customer churn? Can anyone tell what's a customer churn? Nobody knows what's a customer churn? You can do Google.
Like who will stay or who will leave?
Exactly. So can you put this in a context?
Like in the grocery store, like who likes it, like who will leave or who will stay.
Okay, all right, that's fine. Excellent. Okay, so basically what it is, let's say, so you are at least once in a week you are going to Costco. I'm just giving example. You felt, oh man, this is quite expensive. I don't want to go here anymore. I want to switch to Sam's Club. Okay, I'm just giving a hypothetical example. So what do you call? That is called customer churn. A customer is going to leave you and go to somebody else. Okay, a customer is going to leave you and go somewhere else. So that is called customer churn. So what this is all about, out of all the customer you have, let's assume Walmart has 1 million customer. Walmart in Fremont has 1 million customer. Out of the 1 million customer, we want to know which customer is going to stay with us, which customer is going to leave. So that's a predictive model. That's a predictive model. So within next 3 months, 6 months, 9 months, which customer is going to stay, which customer is going to leave. Okay, so that is a problem statement. What kind of problem it is? It's a classification problem. Why? Yes, this customer is going to stay. No, this customer is going to leave. So that is the yes or no, true or false. That kind of problem. It's a classification problem. What model we can implement? We can implement either a logistic regression or a decision tree or a random forest. So can I implement all three or can I implement only one? Can anyone answer this, please? Okay, my problem.
I have a question.
Yes, go ahead.
So isn't this a regression problem? Because you have to like predict it throughout the months, or is it like a classification problem?
So the month part, I am not worried at this point. Okay, it's first of all, you are really thinking very well. Okay, so I'm not worried about the month part. I'm just wanted to know only one statement. Let me take this out. Okay? So when the who will churn out? Okay, so let's assume. So this is my problem statement. Okay, so predict who will churn out. Okay, is John is going to churn out? Yes, John is going to churn out. Is Lisa is going to churn out? Yes, Lisa is going to churn out. Mike is going to churn out. No, Mike is not going to churn out. Correct? So I'm trying to predict which customer is going to stay, which customer is not going to stay. Okay?
Yeah, that's just two options, right? So it has to be classification.
Yes, classification. So the date I put it just for different reasons, I took it off. Okay? So basically what this is, who's going to stay, who's not going to stay. Who's going to stay, okay? Does that make sense now?
Oh yeah, thank you.
Okay, so this is the problem. Who's going to stay, who's not going to stay. So now what kind of problem it is? Classification. Yes, they're going to say, no, they're not going to stay. So what model we are going to implement? Logistic regression, decision tree, random forest. These are all classification problem models. So the question to you all, should I implement all three or should I implement any one or any two? What's your gut feeling? So in a real world, if I have to implement this, should I implement all three models? Should I implement any two model? Should I implement a model? Can anyone tell, please? There's no right or wrong answer. You can tell whatever you feel.
I think you should implement all problems.
Okay, I like the answer. Why? So why do we have to implement all three?
Because if you only implement one, for example, problem type, it won't be very specific. Like if you put all three, it would be more specific than just classifying one.
Sure, sure. I really appreciate your thought leadership on how you're thinking about it. But here's the deal. The deal is we don't know which model is going to perform well. Okay, is random forest going to perform well, or is it going to be Decision tree or a logistic regression, we don't know that. Which model is going to perform? It all depends on the data sets. Some model works well, some model doesn't work well. So it is always good to have more than a model so that you can understand the model prediction accuracy and confidence level. Okay, so make a note. It is always good practice to run at least 2 models so that you can understand which model performs well, which model doesn't perform well on a given data set. So that you can focus on the model that works well in a data set and you can ignore the other model. But I'm not saying it's a mandatory. It's all depends on the data scientist. It's all depends on the data scientist as the person who are building these models. Okay, so in my world, I build 2 models. Why? I want to see the accuracy. I want to see the confidence level. I want to see the field weightage, correct? So I'm just saying, so it's based on how we wanted to see the model performing and model outcome, we can decide. But it is good to implement 1 or 2 models. Implementing model is not a rocket science. It's very simple. The problem where it's going to come, it's on the training data, on the test data. Oh, we didn't talk about this one. So the training data and test data, in what ratio the training data and test data typically used? Let's say you have 1,000 rows, okay? You are talking about a 1,000 customer. So out of the 1,000 customer, how many customer I can use for to train the model and how many customer I can use for the test the model? It's based on the data quality and everything. It could be 70-30, it could be 80-20, okay? So what I'm saying, out of 100 customers, you can use 70 customers to train the model. You can use 30 customers to test the model. Or if model is not performing, you need more training data, you can go 80-20. Out of 100 customer, 80 customer could be used for to training, and then the remaining 20 customer could be used for testing. Okay, so that is the ratio typically industry uses. If again going back to the quality of the training data and test data that what we have, that could change the dynamics. But as a practice, either it's 70-30 or 80-20. 70% of your customers are used for training, or 80% of your customers are used for training. 30% of customers are used for testing, or 20% of your customers are used for testing. It's based on the quality. So coming back here, so we have a problem statement, we have a problem type, model selection. So the reason I'm walking you through, you can apply this in your projects. Okay, you can apply this in your project. You have a problem statement, and you have problem type, and you have model selection.
I have a question.
Yes, sir.
So you said to do 2 models to see which one's better, right?
Yes, which performs well. Ultimately, we need a higher accuracy, correct?
Thank you.
Yes. All right, so let's move on. So how do we...
So basically you choose the model based on which one performs better, right?
The model selection based on a problem type, okay? That is different statement. Out of these 2 models, which model performs well, okay? Understand my language. Yeah. Model selection to solve this problem, the type of problem what we have, classification. To solve this classification problem, what model I need, I have 2 models listed here, 3 models listed here. Out of the 3 model, when I train the model, test the model, I will know which model is performing. Okay, let's say logistic regression predicts at a confidence level of 99.9%. Decision tree predicts at the confidence of 95%. Random forest 98.99. So which one you prefer?
Logistics, right?
Why?
Because that has a prediction rate of 99%.
Exactly. So that is, how do you know that? Until you have this, how do you know that? So let's say,
because you tested it.
Yeah, so let's say that is one set of training data. So now I have other set of training data. Under the other set of training data, logistic regression predicts at a confidence level 98%. Decision tree 96%. Random forest 99.87%. Which one you prefer?
Logistics, right? Wait, no, the one with the highest percentage, right?
Yes. So you have to arrive a state like that, correct? So that means You have to do a lot of experiment. That's why it's data science. Okay,
Yeah.
that is what it's called data science. You apply science and figure that out. So I have 3 model. It behaves based on the different data sets. My goal is to go for higher accuracy. My goal is to go for higher accuracy.
Higher.
How do I know what is the higher accuracy? I have to test all different possible combination of data sets. Then arrive a state. Okay, arrive a state.
Okay.
All right. Is that helpful?
Yeah. Thank you.
No worries, my friends. All right. So we have a problem statement. We have a model selection. Now, how do we implement? Okay, how do we implement? So this is, I kind of touched yesterday. I didn't go in depth. So this is what the steps involved. So if you are going to build this on a real industry, for training side, you may not perform, or learning side, you may not perform all the things, all the steps. But if you wanted to go and implement this in a real world business, in real world industry, so there, these are the steps absolutely critical, absolutely critical. So you may not be able to do all the things by yourself. You may have a team to do this one. So this column talks about who are the teams involved. And this column talks about what kind of skill is required. And this column talks about the primary skills and the secondary skills. Okay. So that you can position yourself during your learning under your higher studies, what subjects, what electives you could choose. Okay, what subject, what electives you could choose. So these are all kind of gives you in a different perspective for your higher studies and create enough interest in terms of like now what you want to study and become. A lot of you asked a question. If a machine is going to do everything, do we need a doctor? That question is still a valid question. We don't have an answer. Most likely we don't need a doctor. Okay. If a machine is going to do everything, do we need an engineer? Okay. What a civil engineer will do? The civil engineer can create in a blueprint, an architectural diagram. Now the machine can do the same thing, which is called building profile. Okay, which is called building profile. So that's one of my use cases yesterday. So what is a building profile? On a building of 2,500 square feet, how many window, how many door, how many floor, etc. It recommends. Why? For energy efficiency, energy benchmarking. So what does that mean? We no need civil engineers. The machine can do. So the way things are going, okay, the way things are going, it is going to be anything, everything we touch, it's all going to be in some form artificial intelligence in the future. That's for sure. That is for sure. Okay. So when you have such things, understanding this at a very structured, methodical way would help a lot. Second, so choosing right subjects so that you can learn in depth and build your career around it or be an entrepreneurial would also help you. So in that context, what I'm talking about, what are the various tasks we perform to implement these 2 models? In order to implement, what kind of primary skills, what kind of secondary skills involved? And what are the kind of team that are going to interact? It just gives them a perspective. So we looked at in the previous slide, what is the problem statement? Predict which customer is going to stay with us, which customer is not going to stay with us. What is the kind of problem this is? It's a classification. Yes, the customer is going to stay. No, the customer is going to leave. Yes, the customer is going to stay. No, the customer is going to leave. In order to implement what model we need, these 3 models. So it starts from problem statement, model selection. Then technology development. Then what kind of data we need? So that data for training and testing. How do we prepare the data? As I said, data could be in any form. It could be image, it could be video, it could be structure, it could be semi-structure, etc. How do you prepare? How do you integrate? How do you make this available for the model to understand? Then it goes to model building. Then it goes to model training, model testing, model validation. So model building, it's basically nothing but like, the entire process, okay, is what it is. Identifying the features, which we are going to talk again, okay? So what feature makes the model to run accurately? What feature has more value to the model? So that's part of the model building exercise, so feature engineering. Then model training. You train the model learns and understands. Test the model. okay, which is basically nothing but see how accurately the model learns. And based on that, you can retrain. You can, once the model is tested, it produces an outcome. So that outcome is model validation, model acceptance. Once it is accepted, then deploy the model in the production. To see the model outcome, you build a data visualization. If the model is not performing, tune the model, retrain the model, retest the model, redeploy the model. It's an iterative cyclic process. So these are the tasks we perform. These are the tasks we perform. So this is basically the steps involved in order to implement machine learning models. Okay, from learning side, you may not have to perform all the steps. Okay, as a learner, you may not perform all the steps, but I want you to understand all the building blocks, all the steps that's involved if you want to build this at a scale. If you want to build this at a scale, these are the things involved. Okay, data collection, data preparation, data integration, data provisioning. Data provisioning, making the data available for the model to run. Model building, which is basically what model to implement, what are the features involved. Model training, okay, using the training data to train the model. Model testing, so based on the trained model algorithm, you see how well the model learns and do some kind of a testing. So that will create an outcome, you validate the outcome. If the validation is up to the mark, then accept the solution. If it is accepted, deploy them in a production. Once it's deployed in the production, visualize the model outcome. Based on how you feel the outcome is right or wrong, you tune the model. When you tune the model, you may end up retraining the model, retesting the model, redeploying the model. The cyclic process continues. Any question? How typically these are all done on a business level or in a industry level?
Question: what does technology development mean?
Sure. So technology development, in order for us to implement this model, do we need TensorFlow? Do we need TFX? Do we need Kubernetes? Do we need Kubeflow? Do we need big data? Do we need IoT? Do we need any data visualization tool like Tableau? Those are all technology deployment. So I felt that's too much to discuss. I just put all in one thing, technology development. Does that make sense?
Yeah, thank you.
Okay, all right. So this is just how it works in a logical. How it works in a logical way. Okay, you see the underlying. These are all different data sets. So in order for me to predict which customer is going to stay with me, which customer is not going to stay with me, I need the customer building data. Why? So based on how much the customers build, the customer could make a decision, I'm going to leave. It's too much money I'm paying. How do we know what is the monthly invoice? Okay, so one is billing, side is an invoice. The next is pricing. The next is customer service data, customer feedback. When you say customer service, how often we are servicing this customer? So during the service, is there any issues? Is there any feedback from the customer? What is that would be? So what is these are all different features to predict which customer is going to churn. So these are all different features. I'm going to talk this in more detail. So I'm just giving you an example. So we have to bring the data into a data lake. Once the data comes, run a data validation and make the data provisioning, make the data available. See this one, there are different sources. It could come from different sources. It could come in a different format. I told you customer feedback. Customer feedback could be in a Facebook post. Customer feedback could be in an email. Customer feedback could be in a voice message. Customer feedback could be a video. Who knows what have this trend? So it could be anything. So how do you bring all of them together? And how do you make this model to understand? Okay, and how do you run the predictive model? And how do you perform the validation? How do you expose the data to the users for a data scientist or a data analyst, right, people? So this is how the overall flow goes, right? It's just a logically organizing everything what we looked at from the source data all the way to data science outcome. How does it work, right? So this is basically in a real world view of how to build simple machine learning models, very simple machine learning models. In this case, we are taking a customer churn. Which customer is going to stay, which customer is not going to stay. It's a classification. There are 3 models to implement. These are the steps we are going to take. once we're done, this is how the production system is going to look like. Okay, the production system is going to look like this, just in a view. All right, there are some terminology I want you to understand. Okay, so this terminology, it's absolutely critical. Okay, these terminologies are absolutely critical. So we know what is a model. When people say model, it is nothing but the statistical modeling names. Random forest, it's a model. Logistic regression, it's a model. Decision tree, it's a model. So these are all different models. There's a machine learning model, there's a deep learning models. Model training, model testing, we talked about. Okay, so make the model to learn, that's a model training. Testing how well the model learned, that's a model testing. Testing the model to understand how well the model is learned. So that's basically testing the model. So at the end of the model training, the model creates an algorithm that's called learning algorithm. At the end of the testing, the model creates an outcome, that's a model outcome. The model outcome has to be validated. How do we validate? I'm going to give a set of data. I know what is the expected outcome. Under the customer churn, I know Lisa is not going to churn out. Okay, she's very loyal and she has been with us for almost last 10 years. So she's not going to churn. I'm going to give Lisa's data and see how the model is predicting. So the model is predicting Lisa is going to churn out. So that means it failed the validation. Okay, why? Lisa is going to stay with us. I know for sure. Okay, so like this, you can take some cases and run the model and see the outcome and validate that. That's the model validation. Model analysis. What is model analysis? If a model is not performing well, okay, either underperforming, overperforming, regular performing. So there are three key terms you can understand. Okay, so three key terms you can understand. So model validation. Okay, when you do model validation, so model validation, it falls under underperform, regular perform, overperform. Model validation. So how do we verify whether the model is performing well or not? So how do we verify whether the model is performing or not? So this is where the graphs that what you are talking about, linear regression. I think in the mornings, like, quizzes, someone was asking about a graph, straight line, etc. Right? You can understand. So regular perform. Okay, regular perform. So that means no issues. It perform as expected. Underperform. Okay, underperform or overperform. So these are the different type of model performance. Okay, this is overperform. So what I'm talking about. So model testing. Okay, model testing, and then model outcome. Model testing, model outcome. So this is model testing. The next is model outcome. So you can verify the model outcome. You can verify the model outcome. So how do we verify the model outcome? You run different testing. So during the testing, you find out how the model is predicting. Is it predicting regular, under, over? Okay. So basically, this is how it looks. So you have model testing. So once the model is tested, then the model creates an outcome. So based on the outcome, so you can do all the things. So model testing, model outcome, model validation. So this is basically the process that's involved where you can identify how the model is performing. So regular performs as expected. Okay, performs as expected. As expected. So it performs as expected. Okay. All right. So it performs as expected. Second, so this is how the model is performing. It performs as expected. All right. So the next one is underperforms. It doesn't perform as expected. So it performs lower than what is expected. It performs lower than what is expected. So model performance is low. Okay, model performance performs lower than lower than what is expected. Okay, lower than what is expected. And this is, it performs above expected. Okay, above expected. Okay, that's not a good thing. Okay, that's not a good thing. Above expected. So let's take an example. Okay, let's take an example. So I'm going back to the same thing what you told. I'm trying to draw a graph. Okay, I'm trying to draw a graph. So what I'm trying to draw a graph. So what is the grade for this, like, students? Okay, so I'm taking students. Okay, I'm taking students and the grade. Okay, what is the expected grade for students? Okay, so predict the grade for the students. So the model is supposed to predict the grade for the students. So I'm putting the student and the grade. Okay, so I'm putting the students in the grade. So this is, let's say, the students, and this is the grade. Okay, I'm just trying to draw a line graph. So this is a grade. Okay, this is a grade. Okay, I'm just giving examples. So this is going to be a straight line. Okay, so 1 second. I'm just trying to do a straight line. So now the points that I'm putting, okay, let's say I have different people. Okay, so let's say this is for John. Okay, this is for John. So this is what I'm doing, this graph for John. So this is first semester, second semester, etc. So this is first semester. Okay, first sem. So this is first sem. Okay, I'm just giving some examples. Okay, I want you to understand the context so that you can do. So this is first semester. In first semester, what is the grade? Okay, so this is first semester. Okay, first semester grade, second semester, etc. So when I draw the line, let's assume that if it is, this is, if it is on the straight line. Okay, let's say I'm putting the points. Okay, so how much grade they got, first semester grade, second semester grade, like this, right? So this is basically where it comes in. Okay, let's say, so this is one of the points it's coming in. So if I have something like this, so this is basically a regular perform. Okay, so if I'm putting a graph, okay, for the students, so this is regular perform. Okay, it is a regular perform. This is regular perform. So the model is performing regular as expected, as expected. So this is the regular perform. All right. Now let's say for another student. Okay, I know for sure. Okay, I know for sure. So for whatever reason, okay, the model is not performing up to this point. Okay, so the lines are going here. The lines are going here. Okay, it goes like this. It goes like this. So what is this? So this is a graph that I'm drawing. It goes like this. Okay, it goes like this. So this graph that I'm drawing, it's basically overperforming. Okay, this is not a regular perform. This is overperform. This is overperform. This is overperform. Now let's say it goes in the other way. Okay, which is it goes like this. Let's assume it goes like this. So what do you call this? So this is underperform. Okay, this is underperform. So this is underperform. So come on, this is underperform. So this is basically what the model validation is supposed to do. This is underperform. So what we are talking about, when you test the model creates an outcome. The model outcome you have to verify. How do we verify? I want to see how the model is performing. Whether it's an underperforms, a regular performs, or overperforms. What exactly it means when you look at it in the graph. I'm an entrepreneurial, okay? It's just getting started. What exactly it means? Sky's the limit. You can go any extent, anywhere. As we learned for the last 2 days, okay? Anything, everything is going to be artificial intelligence. Whatever a human does, whatever, okay? You can name anything. All can be done using artificial intelligence. In the future, we have a question. Do we need a medical doctor? Probably not. Do we need a civil engineer? Probably not. Do we need an electrical engineer? Probably not. What does that mean? So all such intelligence can be created artificially. Who's the creator? That could be you. So what to take to create? And that's why we have entrepreneurials. People who had dreams and ideas and transform their ideas and visions in strategy, and strategy to execution, and execution to build a bigger business. So both Mr. Lena, Mr. Ram, so they have proven track record in what they have accomplished in their life. So it's our honor to hear from them, the journey they took and what accomplished they made and where they are in right now would be a lessons learned for us. Let's hear from here. Let's bring both of them online. So let's bring both Mr. Lena and Mr. Ram online. So I don't want any further time on this, waste any time on this one. So let them speak about it. Let them give us more insights on what it takes to be a successful entrepreneurial and what does the journey make someone to be very successful. Let's hear from them. Thank you, Mr. Lena. Thank you, Mr. Ram. Back to you. Mr. Lena?
You're on mute.
You have to unmute.
Yep.
Yes, we can see you.
Yeah, okay. Good afternoon, everyone. Thanks, Jyoti, for this opportunity to address a lot of students here. I think both middle school and high school. I'm really honored to be part of this session along with Mr. Ram. So probably I think the way we will do this session, we will do a quick intro about ourselves, then we will do a small fireside chat where we both will ask each other a few questions so that the audience, students here can hear more about what we went through in our entrepreneurial journey. And then we will open it up for a Q&A session for students and others to ask us questions. I think that's how we both have planned this session so that we can make it more interactive between us as well as with the audience, right? Again, I would like to thank Bay Area Tamil Mandram for hosting this event and inviting us. Yeah, go ahead, Ram. You want to say something?
Ram, unmute Ram, please.
Yeah.
Oh, okay. Good afternoon. Good afternoon, everybody. So, very pleasure to meet all of you and all the school children. So, would like to share our experience and the journey from the time we did schooling and college education and coming to US and what we are doing, how we are doing. So, so that will be like the children is the next generation. So they should know what, how did we travel from India to here? What are the things we achieved? So they have to take it from here. They have a lot of potential, a lot of opportunity, unlike we had it in India. So how they are going to utilize all the opportunities here? So that is where we are going to give, give a more energy to them. So start thinking about it, what are the things they have to keep it in mind to become an entrepreneur or whatever it is. So let's say that I can say that when we did in the school and all in the college, until the college, so we never seen cell phone, okay, best example. So we have an experience with the communication, effective communication, not even the cell phone. So we had to go look for a landline. So even after coming to US, I came here 95. I studied in College of Engineering, Indiana University. And that's the same university Jyoti also studied. And back in +2, like I studied with Lena Kanappan in Tanjavur. So we always like share our memories. How did we do over there and what we are doing here? So back here, I came to United States 95. Even then, there's no cell phone. Okay. So, and then 97, I came to Silicon Valley. I didn't see any cell phone. So 99, slowly it came to cell phone, all the communications. Right now, everything is easy. Right now, they made it easy. So the technology is evolving. So these things you have to remember, the children. So how we travel, what experience we had it from India to here. So what's happening right now? Probably the best way to check all this transformation happen over a period of time is your parents. They're the best teachers for you. You know? They can give more experience. So you can keep those things in mind, and you have to take it from here. So what are the things you can achieve? There are so many things. There is no limit. There is no limit. So the way you have to look at it, each and every one of you, you have to see what best you can do. What is your knowledge? What is what there is your best interest line? So if you're going to think and you're going to align with those areas, so you can excel. You can excel, and you can be anything. Not anywhere. Like you can be high position in technology or non-technology. You can see not only technology. You don't need to worry about technology. There are so many things, so many industries. You can get into some chemistry, physical, astronomy, biology. Now biology has more value than technology. If there is no biology, no technology. That's the way it is. See COVID. So everybody is waiting for vaccine. When the vaccine is going to come, then whether the vaccine is going to work or not. So we have to be live. So we are suffering. The whole world is suffering. How to live? How to overcome this COVID-19? Where is the vaccine? Where is the medicine? Is there any cure? So the biology is a best science right now. It's a topmost, even more than technology. You have to be live to find a technology. So those things you have to look at it in that way. So you have to aspire yourself based on your strength. Identify your strength. Focus on that. You can excel whatever is based on your interest. Lena, I give it to you. Like you can say a few words.
Yeah. So definitely, I was going to ask you a couple of questions, but before that, maybe I'll say a few words about myself. Thanks, Ram. It was always inspiring to talk to you. Who handles multiple different areas of entrepreneurship, as I know. So, folks, I came to this country in 1991. Many of you, for sure, you were not born by then. So, I used to be born in a village. Then I studied in a small town until 5th grade. Then I moved to a little bit bigger town and did my high school, middle school and high schooling before I even got to know much about Chennai. And until I left the country, I've not even visited Mumbai or Delhi or even outside of my state. Right? I just like many others, many other successful entrepreneurs and people who have moved to this country. I also had only $60 in my pocket when I that too, I just changed some rupees my dad gave me to convert to dollars. Those days it was 13 rupees per dollar. So I was able to carry $60. That was like big money for me. So I landed in LA in 1991. So I continued, I used to design nuclear control systems, but since the time I landed, there are 2 or 3 things really got me going, right? One, my passion for Tamil language and Tamil people and people from, especially from our homeland, where I was born and grew up. The second thing really got me was get into some sort of entrepreneurship. So that I had in mind for a long time. So as Ram just mentioned about, why you have to keep thinking about entrepreneurship. That's where you can really come up with new ideas, and you can be creative, and you have to push the edge to come up with ideas which can solve a specific problem. So unless you think today, you cannot plan and then give it a shape and really execute on the plan, on converting that idea. So every day I would say, you really start putting some, jot down some notes in your diary, or whatever nowadays is the Evernote. Or you have to keep capturing ideas, right, on a daily basis, on a weekly basis. You can even set aside like a 1 hour or 30 minutes on a Sunday, right, every week. But you have to do it regularly, right? It doesn't matter whether you're ending up in a big college, big school, or whether you're going to continue your life as working for somebody. This actually keeps you really motivated, energetic in life, right? That's something I learned. The reason why I'm bringing that up, in my experience, you believe it or not, in 92, 93, I used to sell jewelry, right? I used to go and because somebody came from Mumbai and from India. They wanted us to really put up a jewelry, a diamond shop in a booth. And I wanted to learn. It was not that, I wanted to continue life in jewelry. I wanted to see how that feels. And then I've also tried to sell things from, I don't know how many of you are familiar with Tirupur, which is near Coimbatore. I was interested in merchants, and really the ideas came to me was, why not I just pick up the phone and talk to vendors and companies here. So I used to take my lunchtime off to make these calls. These I'm talking like almost 93, 94, was way long ago, right? Because if you want to become an entrepreneur, you have to keep trying and keep thinking of trying different things. And in 94, I put together the first internet website, and I got so excited. And I was writing, I don't know how many of you are familiar with Python. So Perl was invented in 1994. I used to be in touch with the founder of Perl, right? And I created a website, and then we registered something called CooperTires.com. There is a big tires company, Cooper Tires, just like Goodyear. In fact, later on, we built a system. This all I did it part-time, by the way. I was not full-time. What I learned over the years, if you want to be an entrepreneur, you just have to take the fire in the stomach and leave your part-time and go full-time. It may take some time to get to really believe in yourself, but generally that's what I would encourage. Take a step by step, but your real success will come only when you become full-time. So there are really super books, right? You have to continue your reading habit. Even today, I learn things by watching videos and reading articles, and as much as possible, I read books as well. Read books like Rich Dad, Poor Dad. Read books like Crossing the Chasm. I don't know how many of you heard about Guy Kawasaki, who was one of the very early employees of Apple. And in fact, he used to tell stories. He was one of the first engineers that Yahoo wanted to hire him. He did not join the job because it was too far to drive. He was living in, I think, somewhere in Peninsula up north, and he didn't join the job just because. But he left and he started something called Garage.com. Why Garage.com is so close to me? Because I attended right from the first Garage.com conference to the third or fourth. And this is where I got so motivated from 96, 97, 98, 99, because I was attending these things. I was living on the East Coast, but I used to travel to attend these conferences. So the passion and the inspiration can come from any direction, anywhere. As Ram mentioned, we all grew up with no phones, no communication. Our parents don't give us a lot of money to spend, right? So those things really helped me as I built my companies. on a, how to be frugal, how you have to really on your, how you burn your expenses on a monthly basis, because when the investors put money, it's not your money, it's their money. So you have to safeguard that more than as if it's your money. Anyway, I think this is kind of it's a very, I'm always passionate about entrepreneurship. This can go into a very long conversation. So let me stop there. Where I stand now, we have built a company which is over 650 people, valued close to 200 million. And we are one of the top players for healthcare in Amazon ecosystem, one of the top 10 players in the Amazon Web Services ecosystem. And we are growing further and further. We acquired 6 to 7 companies in the past several years, and we are doing a spin-off in healthcare considering COVID-19 situation. So I think I'll come and say more, but I'll let Ram say a few things, and I'll ask you, Ram, a couple of questions. What made you to really become an entrepreneur? What were you doing before starting a Madras Cafe or before getting into entrepreneurship, Ram?
I came to United States. See, I studied mechanical engineering in College of Engineering, but I didn't much work. Very few, like a couple of years. I was working as a mechanical engineer, but during those days, all the computers, like everybody is excited about seal, just looking at the computer. Nobody has computer, even no desktop those days. So we used to live with the desk operating system, DOS, DOS. I still see the DOS and the symbol. Okay, that's where we started. So then the Unix system came, all these things. So I transitioned from mechanical engineering to computers. So I started learning computer myself and started teaching computers like Oracle. So I came to US like as an Oracle DBA, database administrator. And I used to work in IT companies like Sun Microsystems, HP. We used to build database, design database, data modeling, and build a data warehouse. And from the warehouse, we'll extract all the data required for the analytical, like sales and marketing. So becoming an entrepreneur, like always, like as Lena told, like inspiration into my mind. So I thought, okay, this is how I learned. Okay, what we can do, like it's all happened in 2001. So I just had an opportunity. I just did a test drive. Like it is not something with the technology. So okay, let me make it short. I want to do a service. Wanted to do a service with respect to food technology, food. So what you can do with high quality with affordable price. Okay. So that's all I just landed up in Madras Cafe. So anything like I always whenever anybody is talking about the restaurant operations, everything, this is how I look at it. This is how I convey to them. Like say, it's all like end-to-end operations. So we procure raw materials, do production like a manufacturing and the sales. So I always correlate whatever the operation happens here with respect to any industries, including software life cycle. So we have different processes. We have to monitor different processes and troubleshoot the processes, fine tune the processes, and the customer service, take it to the customer, making sure that it has a quality, like a quality control. So that's where the success comes into picture. Whatever we do, we have to keep it in mind. What we can do best, whether it is restaurant, whether it is store, or whether it is technology, whether it's a mobile app.
Yeah.
So like for example, Zoom is there. So what was there before Zoom? WebEx. What was there before? So what this evaluation happens, what you can do best? What you can make it easy? How you can make it easy? So another example I can give you. So some 4 or 5 years back, if I want to book a taxi, I have to call some number. So now how much it is easy? Like a Uber, whatever it is, just to press, the taxi comes. You don't even tell you where you are, what address. Before you have to tell all the information to bring a one taxi. Same thing, take food. So you have to call the restaurant and go and then take the food, bring the food home. Now just press the button, food comes. So this is the technology evaluation. So this is how you have to look at it.
Actually, I agree with you, Ram, just to make it a little interactive. So I was reading about WeChat. WeChat is a popular app from China, right?
Yeah.
The way they designed the whole WeChat was morning to evening lifestyle. If I'm a citizen or a consumer, what do I do in a day, right? Whether I go on, right from I listen to music, I read books, I go to school or I go to office, I come back and then I continue my offline things, and then I go and buy order stuff online, or I go to the shop in person. I mean, unfortunately now COVID-19 days, we're not able to get out much, but so they really, and then they wanted to build products or apps which will support each one of this. See, that's how they brought the whole e-commerce into WeChat, even before Facebook introduced the support for shopping, which Facebook has now partnered with Shopify.com, so that you can actually have items added to your wish list and then really buy things from your Facebook Messenger. So I think that's something you just touched on, I think very nicely, that the innovation can come from anywhere, anytime, but we need to have a problem or a space that we want to address. A simple thing is just watch anyone's lifestyle. If there is any gap, you go and think of a new idea. And this is just to focus on consumer. Because for example, my son works for Facebook. And today, Facebook, anything they develop, is for a 2 billion people focus, right? So that's kind of that's where the world is going. I mean, if you look at Google, what is the basic charter and the basic vision behind Google was, how can I organize the information, the world's information, in a proper way, and how can I deliver that information to consumers? So while you are thinking about new ideas, you have a bigger vision. What you want to do in the long run. How do you want to solve certain challenges in the community or in our lives? Yeah, go ahead, Ram.
Exactly, you are correct. So basically, this is how you have to think. What is a record? What is the requirement? What do people expect? What kind of sophistication you can give? Like before Amazon, nothing. We have to go to all the department stores. Now just order Amazon, they just bring everything, whatever nobody goes to buy anything right now. So even all the stores are closed, still people are buying, right? So you have to make sophistication and easy to use, easy to get, easy to interact. So that's where the world is going. And also, with respect to AI technology, Lena, we both were talking about what's going to be the future with the AI technology. Is that going to be changed? The world is going to be changed. The people are going to be changed. How the machine is going to be rule the people? Like, is it going to take away all the people's job? Yeah. So it is all going to be like evaluation, like we don't know. So that's the way it is going right now. So there are so many question marks. So go ahead, Elena.
Yeah. So Mark Cuban, I'll just add one quote here. Mark Cuban, who is on Shark Tank, who also owns Mavericks basketball team, right? He came out and said the next $1 trillion entrepreneur, that means next trillionaire, he's not talking about a billionaire anymore, is going to come from AI. Someone with artificial intelligence, someone doing a startup, because of the opportunity there, right? The AI, as you said, I hear reports that almost 50% of the jobs, monotonous jobs we do today, are going to go away. even taking a sheet and making a copy in your Xerox machine. You don't need to do all those mechanical jobs. Everything is going to be automated.
Absolutely.
Robotic process automation. I mean, I was even surprised to hear from Shasta Mani, sir, Shasta Foods, when I went to see, he has a robo which goes and picks these items from different aisles in racks. So he's applying AI. I mean, already in his food distribution store, I think. So the AI can really impact. I think one of the things I can say, because we work closely with Google Cloud, Google is really advancing very aggressively in the AI space. They are one of the first ones to come up with a vision API, video intelligence API. And I also understand 80 to 90% of the hospitals in the US, they still use fax machines. So what AI can do in these cases, now you can actually convert these fax papers, I mean, whatever data that you have about the patients, and convert them into electronic documents through OCRs. You can use OCR technology to capture that information from the sheets, right? By scanning the faxes. And then you parse the information about the patient. Once you collect the patient data, because it has personally identifiable information or personal healthcare information, they put it in a secure way to store it. And they integrate it with the existing electronic health record systems. So what this means is 80 to 90% of the hospitals you're using fax machines may need solutions from Google, Microsoft Azure, or Amazon Web Services, who are building these AI solutions. That's just one example, right? This is something easy to understand. This is how things are done today and where things are moving. So likewise, the AI I see applied AI based on each industry, whether it is a manufacturing industry, whether it is healthcare. You talked about, I think, life sciences. There's a huge opportunity for AI and machine learning to play a role in the life sciences space, right from predicting the disease to helping to prevent the disease. And AI can be also in the treatment. And then they call it continuum, post-surgery and post, where you can really continue to monitor the patients. Again, you can apply AI there. And I think in terms of really doing clinical trials, the way clinical trials are done in different phases before the drug is released in the market, now people are looking at ways of collecting data, clinical trials data, right from reaching your home. If you're a patient at home, there are enough technologies to help you to collect the data and then use the data before they come and announce vaccines and all that. But we are in a very very challenging times now. So hopefully, these things really help. Yeah, go ahead.
Another thing, so it reminds me, like in hospital settings, if you look at what's going on with each and every hospitals, you know how much they're struggling with their resources to monitor each and every activities. Yeah. Okay, this is how, this is how we are going to make it easy, how you are going to make efficient. So let's say that there's a patient, okay, that the patient has to be there for a week. They're going to continuously give a medicine and continuously going to give somebody should monitor. There is a big nursing station. If you go to every hospital, like big like a 5-star hotel, like they just assembled everybody looking at everything. And on top of that, every nurse go every 10 minutes or 15 minutes, go to each and every patient, look at what is doing. Okay, well, so these things has to be transformed. There's a high potential for AI right now. So we can use AI technology, monitor all the patients, not physically, every nurse go and stand next to them and see, look at the patients, all they're going to do is just reading. So there's a big scope for that, so for AI, using AI technology, we get all the information remotely.
Yeah.
And, and also in other areas like retails, like customer interface, and customer recognitions, there are a lot of technologies coming up, it's evolving. So so the using AI, like they, by looking at the customer, you can come up with, okay, what is this customer wants. So I know, like I know what this customer wants. So the using AI technology, they can recognize the customer. They can come up with the recommendation to the customer, what they want, what they wish. It makes it easy, like interaction. So that's how the technology, AI technology is going to be going forward.
Yeah, no, absolutely. No, I agree. I think I wanted to see whether the kids have any questions. Maybe we can continue the dialogue if students have questions. Ramesh or Julie, you can.
Anybody? Raise your hand, please.
I had one question.
Yes.
Sure.
So one of my questions is, as like an entrepreneur, when you're trying to create a when you're trying to make a startup company, how do you make sure that your idea isn't something that other entrepreneurs have thought of? Like, how do you come up with something original?
Yeah, that's an excellent question. Maybe I think Ram can also answer his perspective. See, number one, you run into such challenges when you want to build a new product or idea. You want to do it better than somebody who's already doing it today, right? For example, when Yahoo was already a popular engine, but it was not the perfect search engine. When Google came up with the idea, so they really expanded the reach beyond Yahoo. And similarly, I think Ram mentioned about Zoom versus WebEx, right? So there has to be always some new innovation, new creativity around what you do. So the best things, either you completely come up with a new idea or you come up with something better than what people are already using today.
So something more efficient.
Yeah, that's right. So the way you can protect your idea is to always think about filing a provisional patent. The provisional patent will help you from the date you file. You pretty much have the upper hand, or you have the first hand owning that intellectual property. So then you have to file a core patent to really get it released at a patent under your name. So this is something I even used to hear. Priceline. How many of you have you heard about Priceline? There's a company called Priceline.
No.
Priceline.com. Okay.
Where we book the tickets.
Yeah. Priceline is a first generation internet company where you if you want to book airfare or if you want to book hotels, everything, you go to Priceline. So the reason why I'm saying Priceline, they tried to file 50, 100 patents, and the patent office did not agree because they were saying, you are trying to file a patent around a process. It should be a novel idea. It has to be a real idea to be patented. But if you look at life sciences space, if you look at in a chip technology space, people always file many patents. So anyway, Ram, maybe go ahead with your.
Yeah, as Lana, as you mentioned, there are two kinds of entrepreneurship, like start from scratch, new innovations, or enhancements, existing services, existing products. So you can add more value for that. So this is how you have to think. Don't worry about that. Whatever you are thinking, whatever is somebody going to collide with you. So what all you have to think is how you can make better, best, so most usable for the people. So that's how you have to look at it. And as Lana mentioned, that do a patent. So as you come across any new ideas, just file a patent, just so we can protect that IP.
Yeah, and especially if it's a long-term opportunity around that idea, I would encourage to do at least a provisional patent. Provisional patent will not cost you much. It's like $100, $200 kind of expense. But when you want to file a core patent, then it's more expensive. One more thing I'll tell you, first in the beginning, I said, you think about new ideas every day, every week, or every month on a regular basis, right? So you will come up with the n number of ideas. You cannot file patents about every one of them. So you pick, what you feel the best, and you go out. And it's not about the ideas; it's about the execution. So if you can go out and execute, even while you are studying, I've seen a lot of successful student entrepreneurs, and even they start companies while they are in high school. They start companies while they are in college, and even they have an idea while at high school, but once they join college, then they start the idea. These colleges have entrepreneurship centers or entrepreneurship, they have separate funding. They can help you. There are accelerator funding they can give you. So, never, if you are really motivated to be an entrepreneur, I'll say, keep it going. Yeah.
So Lena, can I ask you one thing? So I have a question about the ATA. So is there any scope, like, we have to make use of ATA as a platform for our Tamil community and all our children. So is there any scope for them to give an opportunity through
Yeah,
ATA?
yeah, absolutely. So I think there's ATA stands for American Tamil Entrepreneurs Association. It is an organization or an ecosystem which brings new entrepreneurs, which brings investors, mentors, and academic institutions, and potentially even support from local governments and other organizations, venture capitalists and seed investors and everybody in the system. It also has an academy which teaches how to become an entrepreneur, right? Very much focused on entrepreneurship. And the youth, they can choose to participate in boot camps, or they can connect with people, because they're very nice people. They always like to help youth and others to come out in life. So if you have an idea, you want to bounce off this idea with some of the accomplished entrepreneurs or people who are as part of ATA, they can help you for sure. Thanks, Ram. I think it's not, since it is a mix of youth and adults, we see that both benefiting from each other. In fact, who expected Box to be a this big company, Dropbox to be a this big company, or Facebook? They all came out of college, right? So I would say people on this call, probably they're only 3-4 hours away become starting another Facebook.
Thank you.
Yeah. So any more questions from kids?
Yeah.
Oh yeah, I have a question. So, sir, so if you were to start a nonprofit organization, how do you get all the legal work done quickly? And if you want to gain support and if you want to actually have a goal of helping others, then what do you think is the best way to get better outreach in a time like this?
Okay, Narayan, that's a very good, very thought out question. I tell you. So there are two things I want to address. If you want to start a nonprofit, there's no other country on the planet other than US, I tell you. Not only in terms of the process to really start a nonprofit, also the kind of support you get, the community support, community service support. At least I've not heard or I've not seen it anywhere in the world. So that's the first thing. The second thing is, as part of a nonprofit, and since you asked the question about legal, I can give ATA as an example. ATA does not invest in startups. So as much as possible, we leave it to the investors and the startups who both to deal with it on the legal side of things, right? So that I know I trust this company. I make my own judgment. I come and invest in this company, and I'm taking risk. I know, right? Those things are all. That's one aspect. And this is like potentially getting into litigations, right? But on the side of formation of the company, from a legal perspective, there are a number of legal firms who can help start a nonprofit. Okay, and if you're thinking of a social entrepreneurship perspective, let's say you want to help in healthcare or environmental, or if you take even alternate energy like solar lighting that you want to enable in outside of US, some second tier, third tier countries, right? you can actually start a social entrepreneurship. You can really generate revenue just like a regular entrepreneurship, regular business. So there you definitely need to structure your legal and just like a corporate. Only thing is it's a non-profit. If you look at the United Way today, if you look at a lot of people in this country, they work for non-profits, right? Even after, I know some of our friends' kids who went to UPenn school, University of Pennsylvania, Wharton School, they work for non-profit today, right? Managing money or managing investments. So non-profit is not, you cannot really take it light. I always see as a huge opportunity to just think about non-profits and go in that direction, even build your career around non-profit. Sorry, there was a long answer, but I think there's a lot. There was a very well thought out
Thank
question.
you.
Yeah.
Thank you so much.
Another question. So
Yeah.
how would you take a prototype to the market, and what challenges did you
So we-
face in the process?
Okay.
Did you hear that?
Answer first. I think his question is, her question is, how do you
Go to
prototype your
market.
product?
Go to market.
Go to market. Yeah. You want to answer first, and maybe I can tell in the other. Yeah. Go ahead, Ram.
Yes, Naren. So, okay. So you have a prototype. Okay. There are two things here, most important. Okay. You have innovation. Okay. If you're going to do only innovations, and then how the outside world going to know? So that is what, after the innovation of any particular area, so the very important aspect is go to market. So you have to follow the process, like what are the things you're supposed to do. So what are the subject specific expert you have to bring in for the go to market. So that it's all altogether different areas. So you need so if, let's say that you do only innovations, so there has to be somebody take the innovation, take it to the outside world. So to the marketing, different corporations, or so that's called go to market. So that's altogether different process you have to follow.
Yeah. So I would like to just add to that. When you have your prototype ready, proof of concept ready, in terms of, you have to first identify the demographics and which market you're in, whether you're addressing a consumer market or an enterprise market. Consumer market is, when I say demographics, is it only for US audience, or is it for international audience? Is it for women or men, or is it for kids, students, youth? See, that's very important, right? So you have to really segregate your market you are going after. And then once you do that, you have to spend your money in terms of both marketing and sales. So you have to have your basic sales strategy ready.
Lena, are you there?
You mean muted, Lena?
Lena, what happened?
I think he got.
Okay. He has some internet connection problem, I think.
Yeah. It automatically got unmuted.
Wi-Fi connection, like poor Wi-Fi connection, maybe. Yeah.
Am I back? Are you able to see me?
Yeah, you're back. You're back.
No, I was just saying, then you have to also think about basic marketing and sales strategy while you are, thinking about the go-to-market, and always think about a channel. See, if I have a product that I built, let's say I built a product from Chennai or Madurai or Coimbatore, and I want to sell into US. One of my channel partners I can do is I can just go and talk to Shasta Manisar. Shasta, sir, can you take it to Silicon Valley market, right? Because he has connections to so many stores in the Bay Area and everything else. So you need a channel partner, whatever you do, right? Every big level, if you see all these Amazon success of Google and everybody, it's all about channel ecosystem. So that's another aspect to the go-to-market if you're really building a company. But there was again a very good question. Maybe I think this is too much overwhelming answer for that question, but so that you know what is involved in go-to-market.
Thank you for your answer.
Yeah. But any other question? I saw someone else asking earlier. Any other simple question?
Dear students, don't miss the golden opportunity. Our great entrepreneurs here. Go ahead.
I have a question. Well, it was a little similar to the previous question, and you could personalize this to what's happening now or in previous, but what are the risks that you guys have faced in your company, or what risks are you expecting to face later on after this COVID is over?
Wow, that's a good question. Yeah, I'm scared to answer, but so I think in terms of risk, there's a lot of risk. Right? Number one is your salary risk. Every month you earn salary for the family, and if you are completely coming out full time, you are trusting and believing in the business. There is nobody to pay you salary every month. How will you support your family and children, right? So that is the biggest risk in life. And you have to take calculative risks. Anytime, any level of risk you want to take in life, you take calculative risk. That means you want to take risk for 6 months, 12 months, or 18 months. In fact, one of the most successful entrepreneurs in the Bay Area, you always have a mentor, by the way. Anything you do in life, you always have your own personal mentors and advisors. So one of my mentors told me, Lena, when I came to the US, and then I really wanted to become an entrepreneur, and I was trying a little bit of consulting job here and there, but then I told my wife, give me 12 months time, working with no salary, and in case if I don't come out successful, if I don't succeed, then we will go back to India, right? So he took clearly two things, right? 12 months, no salary, he's ready to work. And after 12 months, he's ready to go back because he cannot survive in this country. So that's the biggest risk, but there are different levels of you have to be ready to take risks, but also you should know how to raise capital at the time that when you need money. The capital is mainly to grow your business, and you should be in a position to return the capital to the, basically encourage the investors to come in and believe in you, right? So that's where the whole entrepreneurship really starts from there. So I think I'll let Rams say more about the risk and
yeah. So in addition to that, the capital is very important in the entrepreneurship, and also inventions and the prototype. So when you have a prototype, let's say that you're going to start with a prototype on your own expense. So as Lena told that there's no salary. Okay, let's say that it's going to take a year to have come up with some subject area and some prototype. So what to do next? So you cannot keep working on the product without the next level. You have a prototype. So the best way to take it to the next level is you should look for a seed capital. You have to see basically like you have to sell the prototype to some other VCs or seed VCs. So that's the next level. So if your prototype is attractive and it has a scope, if it has a scope, and definitely you will get seed capital. And the next level after the seed capital is, even you can get the VC investments as well. So if you look at the Silicon Valley, so there are so many thousands, I don't know how many thousands of startups, but not all the startups going to be successful. That is what the risk comes into picture. So after all the investments, let's say that you're going to work on prototype and investments and even seed capital. So there's a risk involved. So in order to be entrepreneur, you have to take a risk. So it's goes hand in hand.
Yeah. So just I want to add two quick points, Ram.
Excuse me. Ram, please have a water. Help yourself. Please.
What is that, Julie?
Please have a water. Help yourself.
No, that's
Tanni,
okay.
tanni
I don't know
kudinga.
water bottle here. That's okay.
Yeah. Continue, Lena.
Yeah, I have a try. Yeah.
I think two things I want to add. One is your first seed investors are your dad and mom, and your uncles and aunties. So they call it friends and family. They are the people who will trust you. They will trust your idea. The first people to trust you, right? So you always think of an idea. I always encourage my kids, right, in the beginning. And I told my son, when you are ready, come and ask me how much money you need. The funny thing was, he came to me. I thought he will come and ask me for $1,000 or $2,000. You know how much he asked me? His first ask was $100,000. What are you going to do with the 100,000? And where am I going to get that 100,000 for you, right? So at least I was happy that he was thinking big. His first ask itself is not 2,000, 5,000. So you feel, you should feel comfortable asking your parents. Okay, even Jeff Bezos of Amazon, he first got his money from his parents. First seed money came from his parents, right? Parents' savings. The second thing I want to say, you always have to think about while you are taking risk, how do you mitigate and minimize the risk? For example, if I'm creating a software application, I should get the free cloud credits from Amazon Cloud or Google Cloud, so that I don't have to spend money to build my application on the cloud. So at least for 1 year, they have special, benefits for students from colleges and schools. Maybe you can get it for free for 2 years, right? So you can try your new idea on the cloud. So anyway, go ahead. You want to say more, or maybe ask for anyone else? Has
Another
any
question here?
Yeah. Yes.
Before, I just had a question about so how long should you be exposed to normal workforce, like trying to get a job in a standard company before attempting to become the boss of yourself or having your own business?
So you don't want to become like Mark Zuckerberg, start a company while you're in college?
I don't know. I'm asking you guys what's the best approach. That's all.
Okay. No, I think that's a good question. It depends on the individual to individual. I mean, if you look at Bill Gates and others, they dropped out of college. I'm not saying you have to drop out of college, but and I think in a simple sense, having a 3 to 5 years experience in a corporate or a startup environment after you leave college is a good benchmark before you start doing your own. Because by working for these companies, you will understand the process, you will understand the structure, how they all operate. They have a HR division, they have a finance division, they have sales, marketing, product development, engineering, right? Product management. They have research and development, R&D. So you will get to, especially if you go and work for a technology company, especially in the Bay Area, most of them are technology companies. Even if Uber is a technology company today, right? So that's my feedback. But I think let's hear from Ram.
So just in order to add more on that, so this is you have to look at it. So let's say I have one experience. When I used to work in HP, Palo Alto, I think there's one building. So no, there are several buildings, but they still retain the I think garage. The garage. So I was asking question, what is this garage? Why they put a garage picture here? Okay, this is how the invention happened. The HP, they came up with the first calculator. the calculator invented from one garage, one person's garage. So that is a like, you know, just an invention. So it will happen. So it's based on your subject area, your interest. It could be any form. Like it could. So you can start from the college, like Bill Gates. Even after you graduate, so it might happen any part of the phase of your lifetime. You don't need to be like a college dropout or college degree or anything. Like you can start that kind of innovations or transformations anytime on your life. You don't need to be like, you know, be like sophisticated or rich or anything. You don't need anything. All you need to have a platform, some ideas, some kind of minimal support. That's what I would say.
So Ram, there is a question on chat. I'm just reading chat for the first time. Asking, who are all the celebrities have visited Madras Cafe? Sundar Pichai visited Madras Cafe. That's a question by.
Yes, see in Silicon Valley, all the CEOs and executives, they used to come to Madras Cafe, but they will not identify themselves. Okay, it's all surprise. Nobody knows. Like unless you know, I notice somebody, like then I just go and chat with them. So they come they come and go like quietly. I wouldn't know. So even including Sundar Pichai, they may have come. Like I may not be. Wouldn't have been there. So in my experience, I was told many of our employees, oh, this person came, this CEO came, this CFO came. So there are a lot of fans for Madras Cafe, I would say.
So, Mr. Ram, Mr. Ram,
yes, Jyoti.
So I want to take the privilege to add something what he said. I hope you don't mind.
Yes, sure, go ahead.
Please.
So Ram and I was talking. We have this we call deep space.
Jyoti, your voice is
Jyoti,
breaking.
you couldn't hear your voice. It's breaking.
Okay, hold on 1 second. Can you hear me now?
Yes.
It's breaking.
Better.
Better now.
Okay, I don't know what to do. I have to maybe drop and rejoin. That's the best I could do. I'm using my laptop.
Now it's okay.
No, it's clear now.
Okay, wonderful. So I just want to take the opportunity to talk something about what Mr. Ram said in the same token. So we had the startup company DeepSphere. I would say for the last almost I'm talking about from the month of December 2019 all the way to February, we were heavily engaged with so many institutions, so many universities, so many colleges. You can't believe this, right? So we were in 14 days in Hyderabad, all top colleges, universities like Osmania University, JNTU, like anything you name, we were there, we were speaking. It was so well received. Then we came back to Tamil Nadu. There we met with SRM, BIT, like anything you name, SSN. There's so many different colleges we met. So almost 1.5 months, continuous speaking, continuous education, continuous engagement. So I asked Mr. Ram, how do we do the same thing in Silicon Valley or in New York? So Mr. Ram said that it is not something that we want to pursue, but Mr. Sundar Pichai's parent, a regular customer of Madras Cafe, and Mr. Ram knows them, but he said that. What he said that when I said this one, let's not ask them. Let us do our own thing. Let us come to us. Instead of we going to them, let us come to them. So that is what I learned from Ram. So he doesn't want to use his political power or a personal influence or anything to take a business to the next step. Let us focus on the quality of the product, what you deliver. Let the product speak by itself. Let customers identify by the product. I believe that's what is success. Correct? So I can't comment anything on Mr. Lena. I haven't had an opportunity to work with him, but I've been interacting with Mr. Long for the last 2 years. For the last 2 years, the one thing that I learned, quality, product commitment, customer satisfaction, and I believe that's what makes him to very successful. And that's what makes him to very unique and different. Right? So I really want to thank you, Mr. Ram. And I really want to thank. So we are just looking at the time. And I think we are a little over on the time side. So if there is anything specifically if you want to tell to the students, please feel free. It's very inspiring to get to hear from you, especially the lessons that what you learned, the things that what you accomplished based on all the hard work and commitment that you put forward. It makes us feel we are talking to a real people. It makes us feel it's very inspiring and motivating for everyone. Thank you so much once again. Please, if there's any closing statement you would like to make, please feel free.
Hi, I have a question.
Yes, go ahead.
Okay, so what is the biggest challenge you faced from moving from the nuclear to the technology industry?
Okay, that's a great question. So the way I moved from designing nuclear control systems to software world, I used to code every day evening when Intel introduced their early processors. I built some applications and things like it was really hard to leave that space full time because it was more focused on nuclear instrumentation, right? That is like helping nuclear power plants to function better and also build the nuclear power plants in Austria and England and all of that. So then switching my mind to work in B2B e-commerce, and that's when I saw the opportunities in Silicon Valley and I moved to Silicon Valley by late 90s. Then I picked up this whole startup and internet trend, and then I got involved. I think that it was just my mind. You have to make up your mind when you're switching from one field to another field, but you have to put a lot of hard work while you are doing that. Even today, if I want to change my hat from an operating startup entrepreneur to become a venture capitalist, I have to work a little bit hard to wear the different hat. Where I look at today through ATA, I can tell you on a weekly basis, I talk to at least 4 to 5 new entrepreneurs every weekend. So I keep certain number of hours in the weekend to help these entrepreneurs, right? To create new companies. So I think that so you have to தமிழ்ல கஷ்டப்பட்டு செஞ்சாலும் எதை செய்தாலும் இஷ்டப்பட்டு செய்யணும்பாங்க. ஓகே, அதே மாதிரி நேசித்து செய்யறதை விட சுவாசித்து செயல்படுன்னு அப்துல் கலாம் சொல்லியிருக்காரு. அதாவது எதையுமே நேசித்துனா பேஷனோட ஒர்க் பண்றது ஒரு பக்கம், ஆனால் யூ ஹாவ் டு டேக் இட் இன்சைட் in your heart and in your feelings, and then you put your full focus and effort, and you can be very successful in life, anything you do in life, right? Whether you become an entrepreneur or whether you become a scientist, எதுனாலும் உங்களுக்கு வந்து focus வேணும், effort and hard work will really pay off. Maybe that's my last word. Thanks, Mr. Jyoti, for inviting me.
Thank
No
you.
pain, no gain.
Yeah, that's right. Well said, well said. No pain, no gain. Well said. Okay, Mr. Ram, would you like to?
Thanks, Jyoti, and thanks for organizing this entrepreneur segment for me and Mr. Lena. So it was nice, a very pleasure to talking to our kids and the future scientists, future entrepreneurs. They could be anything. Like
Absolutely, absolutely. So we have great potential here, actually. Like, you know, so I have seen a lot of interaction, a lot of questions, a lot of challenges are there. Actually, I'm sure there is a lot of entrepreneurial, a lot of, like, you know, like you said, scientists, researchers. There are many people out there. Thank you so much.
Yeah, whatever point, Jyoti, I think I really liked all those questions, right? So if the kids can feel free to reach out to us for any new ideas, anything they want to get feedback on, we'll be happy to respond.
Absolutely, absolutely. I told them before you both come in, actually, I told them it's an opportunity for you to sell your ideas or an opportunity to find an employment opportunity. Like, you know, whatever way you want to use them, right? So they have power, they have connection, they have people, they have vision, they can help you in all forms. So I already educated them. I'm sure, stay tuned, they're going to look for you.
Okay, thank you so much. Yeah, thanks to Bay Area Tamil Mandram whole.
Thank you, Ram.
Thank
you, Lena. Thank you, Lena. Thanks for your time.
Yeah, we would like to thank behalf of San Francisco Bay Area Tamil Mandram, Mr. Ram, and Lena Kanappan. Thank you so much. Thank you, Jyoti Periyasamy.
I'm going to teach further.
Okay.
Yeah.
Still
Thank you.
continuing for the teaching.
Yeah.
Thank you.
Yes,
Okay.
I'm going to continue teaching.
Yeah,
Actually.
thanks to all the kids for their patience. Patience. Yeah.
Yes.
It was so interesting to hear the stories. Good.
Yeah.
All right.
Thank you.
Thanks,
Thank
Meena.
you all.
Thanks, Julie. Everybody, thanks for everything.
Thank you. Thank
Thank
you.
you. Yeah. So can someone make me to share my screen?
Yeah, let me make you.
Is it possible to get like the contact information of the guest speakers as well?
Yes. 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 We will share with you.
Thanks.
No problem.
So you are a co-host to Jyoti now?
Yes. Yes. I have the control now.
Okay, thank you.
All right. Sorry, we kind of went a little over, and let's see how best we can accommodate to cover all the topics. If it is not, then we have to do something. Okay. All right. So I'm just going to start from where we stopped, and then we will pick it up from here. Okay. So we were talking about the model pipeline and model analysis. Like that's where we started to, like, what's model analysis, what's model pipeline. So that's the thing we talked about it. And then the model deployment we talked about training data, we talked about test data. We did touch about data provisioning. So what is data provisioning? Making the data available. That's part of the data engineering discipline. Okay, that's part of the data engineering discipline. So when I say data engineering discipline, it is a new approach to your data warehouse. It's a new approach to your ETL, extract, transform, load. Okay, it is not the traditional approach. So how do you do that? So that's a specific topic. I don't know whether I have time to cover this one. Let me see. So before you put the data, you have to run a validation. What kind of validation that is? So at the beginning, we had a slide. We talked about, you see the data validation, completeness, accuracy, integrity. Okay. So again, each one of them is a big topic. That's something that I was planning to cover in data engineering. I can see if I can. So that is what data validation. Then the data pipeline. The data has to flow from the source all the way to the model. Correct? You see this one? So these are the different sources. I need billing data. I need invoice. I need pricing. I need customer service. I need the customer feedback. So that has to go through the entire pipeline. It has to go to the data lake. It has to go to the data provisioning, modeling, outcome, and the end user. Correct? So that's how you do. So this whole process is called data pipeline, how the data flows. Okay, so that is what it's a critical step. And the last one is the traditional approach, AI, which we talked about, you could ignore. So what we looked at in terms of analyzing data, how am I going to analyze? So typically you take the outcome and see how the model predicts. If the model predicts well, that means the expected outcome, that what you're expecting, it's been predicted by the model. It means it performs regularly. Okay, that's a regular perform. So when you flag them in a graph like this, you can understand whether it's a regular performance or an overperforms or an underperform. Okay, so overperform, as I told you, you expect something, but it performs more than this. So what may be the final grade for John Smith? John Smith final grade may be like, G, C. But what the model says, it says A. Why? But that's how this John was performing. So that means it's overperforms. What would be the final grade for Lisa? So Lisa's predicted final grades are supposed to be A, but the model says it's a C. So that means it's underperforms. Okay. So what is Mike's grade supposed to be? So my grade is supposed to be A, but the model predicts the A. That's a regular performance. Right? So these are the different way you can measure the model outcome. Once you run the model, how the model performs, that's what this is. All right. There are two other topics I want to touch before we go for the actual demo and implementation. What is model engineering? What is a feature extraction? So all the steps that we talked about, those are all model engineering. Correct? For example, model training, model testing, learning algorithm, model outcome, model validation, model analysis, pipeline. So those are all an engineering principle. That's called model engineering. So what is the feature extraction? Okay, what is
Your voice cut out.
feature extraction. So if the customer,
Jyoti, your voice got to break down. Like now.
huh?
A few minutes.
Okay, I am not sure what's going on with this. How about now?
It's
Now,
fine now.
now
but
it's fine. Yeah. Earlier it was like it's a muted and then just came back.
Okay, I'm not doing anything.
Okay.
Okay, sorry.
Sure. Okay. Keep going.
Okay, all right. So, so what I'm trying to say, feature engineering is what? Feature engineering is nothing but identifying the hypothesis, correct? Identifying the hypothesis to solve a problem. So that is, yes, still the same problem. Can you hear me?
Now it's okay. Yeah, you can. Yeah.
Okay. So feature engineering is nothing but identifying the hypothesis and developing the hypothesis, correct? What is a hypothesis? So in this case, what I'm talking about, predicting whether the customer is going to churn or not. What does that mean? Who's the customer is going to stay with you? Who's the customer is not going to stay with you? How do you know that? Okay. For that, we're going to run a predictive model.
Excuse me.
In the
presentation isn't up. We can't see your screen.
You can see my screen?
Yeah, we can't see it.
Okay, 1 second.
Thank you.
No problem. Can you see now?
Yes.
Yeah, thanks.
Yes.
Okay. Okay. So what I'm talking about a feature engineering. Okay. What is feature extraction? So feature extraction is nothing but to solve a particular problem. In this case, the problem that what we are trying to solve, who's the customer is going to churn and when they're going to churn. Okay. We are not predicting the when part, but we are simply predicting who is the customer is going to churn. Okay. So in that case, we run a predictive model. To run the predictive model, I need to know what kind of information the model need to know so that it predicts. So I can look at customers' billing information. How much we are billing. When the billing price goes up, some cases the customers are dropping. Invoices. So how much invoice we are having. So there's the 100 invoices. Out of 100 invoices, 20% of the invoice is not paid. So customer who's dropping or who's churning out, those customers are who's not paid our invoices, unpaid invoices. And pricing. The customers are churning out when the price increases. When I go and increase the price, the customers are dropping. Okay. So customer service. When my quality is going down, the customers are dropping. When the customer feedback is not great, that the next week they're dropping. So what is this? So these are all features. These are all features. So basically what I'm trying to say, a hypothesis to arrive, the problem to be solved. So what is the problem in our case? Who are the customer going to churn and how do I know that? To know that, I have to look at the features. What are the features? The billing information, that is one set of feature. Invoice information, that's another set of feature. Pricing information, that's another set of feature. Customer feedback and sentiment, that's another set of feature. The service that what we provide to the customer, that's another set of features. So these are all called features. Okay? In a nutshell, so let's take one example. The data what we provide is basically represent the features. The data that what we provide to the machine to learn, that represent the feature. So point is, in order for you to come up with good features, okay, just simply running a model, it's not going to work. The model has to have all the combination of features and data sets. Then only it is going to work. Okay. So here I have another example. So what I'm saying, that's the example we are going to do in the lab. Okay. Hopefully. So what I'm trying to say, I wanted to predict how much quantity I'm going to sell. Okay, in a specific city like Fremont or San Jose or Sacramento. Okay. So I wanted to understand how much I'm going to sell. So this states predict the quantity of the product or a SKU. SKU stands for stock keeping units. SKU stands for stock keeping units that we will be selling in a region, in a country, in a state or a city. To keep it simple, let's say you made a laptop. Now you want to know how many laptops you are going to sell in a month of January 2021 in Fremont. How many laptops you are going to sell in the month of January in San Jose. So I want to run a predictive model which predicts. That is what this is. So in order for me to achieve what I need the region, I need the country, I need the state, I need the city, I need the customer, I need the product family, so and so. And what do I call this one? So this is called features. This is the hypothesis. Okay. So this is the hypothesis. So hypothesis is nothing but to arrive a state, how much I'm going to sell. Okay. I need to look at my previous historical data. In the historical data, what am I going to look for? This is what I'm going to look for. Okay. I'm going to look all this information. So the biggest challenge for you when you go out and build applications, when you go out and build machine learning models, coming up with this feature. And this is the reason why it is difficult. This requires deeper business knowledge. Okay, deeper business knowledge. If you recollect what we discussed yesterday, so we discussed about different skills that what you need to become an artificial intelligence expert. One of the skills is a business skill. One of the skills is the business skill. So to arrive at good features, okay, you have to really know the business and you have to really understand the problem that you are trying to solve. If you don't have insights on the problem you're solving, you would not be able to come up with a feature. Okay, so let me ask you this question. If you have any questions on what is feature extraction or what is a feature, ask me. Any questions? If it is not, I would like to ask my question. Do you all understand what is a feature and what is feature extraction? Do you understand that part? Yes or no, please? Yes. Okay. So you understand what is feature, how do you extract and all? Mike, is that a yes or no?
I just had a question about like a feature.
Okay.
So were you saying that the feature was kind of like the hypothesis that you want to get out from a specific like model?
Yes. So the model doesn't understand how do I solve the problem. Like for example, okay. For example, let me give you a very specific example. I wanted to make a sandwich. Okay. I wanted to make a sandwich. What is your first question? What is your first question to me? Let's assume that you are a sandwich maker. Okay. You are working in Togos. You're asking me, I'm coming to you. You're asking me like, questions. So what question would you ask me?
What bread would you want? Like what?
Okay, what bread do you want? What is that? That's a feature. Okay. What is the next question?
What kind of cheese do you want?
That's again feature. That's the second question. What's the next question?
The next question is like the other ingredients like vegetables and meat.
Exactly. So those are all features. Okay. To make a sandwich, what you need, okay? You need, the first question is, what kind of sandwich you want? I want number 9 pastrami. What is number 9 pastrami? All right, understood. So second question, what size you want? I want a regular size. What bread do you want? White wheat sourdough. I want sourdough. Okay, all right. So do you want mayonnaise and mustard? Yes, I want mayonnaise and mustard. So you see the series of questions that what you're asking, those are all features. Those are all features. Why? Without that, I can't solve this problem. Okay. Without that, I can't solve this problem. I'm just giving in a simplified way for you to understand. Technically, feature is nothing but building a hypothesis for a model to learn. Do you understand?
Yeah.
Okay. So here is my question. How do you, question number 1, is it a good practice to have more feature or a less feature? That's the question number 1. When you build a model, is it a good practice to have more or less features? That is question number 1. Second question, how do you identify the most influencing feature? In the sandwich case, okay? In the sandwich case, at the end, I wanted to ask the customer whether the customer needs salt and pepper. Compare it to the meat. Do you think the salt and pepper is the most influencing feature? So when I ask the customer, I'm supposed to ask, what meat do you want? Do you want chicken or a turkey or a roast beef or a pastrami, etc.? Compare it to that. Do you think the salt and pepper is most influencing feature? Someone can answer.
No.
Exactly. Why?
No.
Why?
Because if there isn't the salt or the pepper in this situation, it wouldn't make much of a difference on the so-called on the sandwich. It would still be the same.
Excellent, excellent. You are not going to lose the taste, correct? It may be slightly different, like people who used salt and pepper, but the core of the product what you have, which is in this case like pastrami, so that is not going to change. That is the core feature. So my two questions are, first question, having more feature, less feature, is it a good practice? Okay, having more features is a good practice or a less features is a good practice? Under what circumstances the machine learns well, either good more feature or a less feature? That is first question. Second question, let's say you have a 10 feature. Out of the 10 feature, which feature you think may have high influencing factor? Okay, if I'm going to say John is going to turn out, people not going to believe me. I have to tell why John is going to believe. Okay, the reason why John is going to leave, that is basically the influencing factor. That is going to be the influencing factor that comes from the feature. That comes from the feature. So what I'm asking you for, take a few minutes, think about it. Having less feature or a more feature would be best practice to make the machine to learn. That is first question. Second question, let's say you come up with the 10 feature. Out of the 10 feature, which feature you think is most influencing factor to arrive your problem solving technique? Okay, so think about it, tell me. All right, so who can answer this question?
Can you repeat the question?
All right, the first question is, let's say we have, for the same problem, okay, the customer churn problem, we have 20 features. Okay, let's take an example. In someone coming up with 20 features, okay, and the other person coming up with only 10 features. So there is no hard and fast rule. There is no basically a defined guideline how many features you can have, how many features you don't have. It's all dependent on, like, for example, I told you the sandwich example. To make a sandwich, what are the number of features that I need? Every ingredients that I'm going to use, those are not features, which makes a sandwich, right? It could be 10, it could be 20, right? Who knows? Who knows? Togos could be making different, or Subway could be making different, Jesse May could be making different. Who knows about it? Okay, so my first question, having less feature or more feature, which makes the machine to learn faster, efficiently, correct? So in a simplified way, would you prefer to have less feature? Would you prefer to have more feature? Which is the best practice? Is the question clear?
Yes.
Yes.
Hold on. The second question, let me make it clear. The second question, out of the 10 features, which feature is the highly influencing feature? The example that we are going back, we have features like salt and pepper, pastrami. The pastrami is the most influencing factor. Why? If I miss that, then the taste is going to spoil. Okay, the sandwich is not going to taste well. If you put less, it's not going to taste well. If you put high, it's not going to taste well. It has to be balanced out. But at the same time, salt is not that critical. Of course, it is needed. It is not critical. Pepper also is not critical. So out of all the features, the most highly influencing feature, the meat, in this case, pastrami. Right? So I'm just telling you, in the context of feature extraction, question one, having less feature is good or having more feature is good? That one question you need to answer. Second question, out of all the feature, which feature is highly influencing to arrive your problem solving technique? I hope it's clear now.
It is clear. I have an answer for the first question.
Please go for it and tell your name, please.
My name's Mega Nisankaro.
Okay, Meha, how are you?
I'm good. How are you?
I'm doing okay. Thank you for asking. Go for it.
So for the first question, I think fewer features is better, because if the couple features you have, like let's say you have like at least like 5 or around 5, and they're like really important, and they kind of they have like they play a big factor in whatever you're making. They like it's much more like I'm gonna use the example you said before, like the sandwich thing. If you had like the bread or any of that meat, it would be completely fine, because that's the main core and it would stay the same. So the fewer you have and the stronger they are,
okay,
the more important it is.
Wonderful. Excellent. All right. How about second question?
could I answer that too, or?
Yeah. So go ahead.
I think for the second question, out of the 10, maybe the beginning ones or the initial steps might be
Okay.
more important because that's like the foundation, the core.
Sure. Excellent. So anybody else? Thank you, Mahat. Thank you. Anybody else?
Yeah, over here. So my name is Satya.
How are you, Satya?
I'm doing fine, thanks.
Grade are you in?
What? Sorry, what?
Grade you are in?
Oh, 12, senior 12.
Senior. Okay, so you are ready to graduate. Okay, go ahead.
Yeah, so I think that I think that there's a notion that if you're gonna make something, it has to be super complex, but it's important that you don't over-engineer something or give it too many features, because if there are too many features, then there will be more margin for error.
Exactly.
So this could hinder. I mean, it might increase the performance, but it could also hinder the performance. So it's best to not take the risk and keep it as simple as possible.
Excellent. So the rule of thumb, that's why it's called data science. That is why it's called data science, data scientists. Okay. Do you know why, it's called data scientist? So why it's called data scientist? What scientist will do? Can anyone tell what a scientist will do?
Conduct experiments.
Exactly. Exactly. You all right. You do experiments. Okay. You start with the limited feature and see how it performs. Then go one. That is how you build the model. Okay. Model building is not sitting and writing a code. It is an art. It's an artistic work. So you paint and see how it looks. If it doesn't look, go back and repaint. Go back and change the color like this. Correct? So it is a research kind of a work. You try a lot of different options, see which one works best. So that's why it's a data scientist. That's why it's the data scientist. So going back, my question, start with the less features. It's important. Second, out of all the features, which feature is most critical? That is absolutely most important for you to identify. How do you know? This is where your business skill comes into picture. Okay. So if you notice, I'm speaking about a Togo sandwich. I'm talking about number 9, pastrami, this and that and all. What does it mean? That's my expertise. I understand how those sandwiches are made. I understand what is involved. If I had no clue, I wouldn't even speak about it. Okay? So what does that mean? Having business knowledge would really critical for you to identify these features. If you don't have business knowledge, you wouldn't be able to identify the features. Then you will be a tech guy. Okay, so what it means, you can just do programming, you do coding, that's about it. You don't have much value there. So I would encourage, learn some business domain, whether it's a healthcare, or it's energy, or it's oil and gas, or it's a consumer, or it's a retail, whatever the case may be. Okay, learn this one. Without this, absolutely impossible to build a model. Absolutely impossible. Okay? Like I said, in YouTube you could watch finding dog or cat, male or female. Those are all okay. But it doesn't tell you how does it work in the real world. How does it work in a bigger, larger picture? Okay? So in a bigger, larger picture, you do have to understand what it takes to arrive at good features. Start with a less feature and evolve and see how the model performs. Add more features, and see which feature has a dominant influence. When you add a particular feature, the model really performs well. When you take the feature out, the model is not performing well. So these are all called feature extraction. It is an art, it's not a science. It's a research. You do experimental work. It's a scientist work. You do experimental work. Okay? So that is why it is always required, as a data scientist, you should know how to work with large complex data sets. Okay? How to work with very large complex data sets. It is really, really important. Any questions on what is feature extraction? Do you understand? All right. So what we have studied, problem statement, data collection, feature, business need, feature extractions. Okay. So there are some questions I just really wanted to think through. What is the role of feature extraction in machine learning? Why feature extraction is so important? How do we know which feature we need for a particular problem? Out of all the features, which is the most important? What is the role of each feature in the model outcome accuracy? Can we change the feature after reviewing the model outcome? Having more feature is a good practice. So if you understand all these questions, I'm sure you have great insights on how this works. Okay, so this is really something that, yeah, good view on feature extraction. Okay, good view on feature extraction. So I would encourage, spend some time, do some research, and come up with answers. Okay, all right. I'm just going to skip all those things. All right, so this is an example I quickly wanted to walk you through. Okay, it's an example that I am bringing as a project that I worked on. Okay, so this is one of the projects that I had worked in by past, and it's a model that we implemented. I'm just going to walk you through how it has worked. So before I get started, can anyone tell what is time series data analysis? Can anyone tell time series data analysis?
I could explain what time series is.
Okay.
So a time series is like a series of data points that's like ordered in time.
Excellent.
And in a time series, the time is often the independent variable.
Sure.
And the goal is usually to make a forecast for the future.
Sure.
So yeah.
Okay, great. Great. What's your name?
My name's Mega.
Mega. Okay. All right. So Mega is a very active participant. Thank you. Anybody else? Have you heard about the term time series data analysis, or at least time series?
I think time series data analysis is like when data is sorted in chronological order.
Mm-hmm.
And then I don't really know what the analysis would work, but I think it's like.
All right, that's fine. No problem. Okay.
I know what predictive analysis is.
Sure. Go ahead.
So predictive analysis is like the likelihood of something. So like kind of like a probability.
Sure. Okay. Understood. Understood. All right. Okay. Have you heard about planning, budgeting, forecasting? I'm sure you all heard about planning. You may not have heard about budgeting, may not have heard about forecasting. Can anyone give an example for what the planning means based on what you know?
To plan something.
It's like.
Can you give me an example? Again, like instead of simply saying plan something, can you give me an example?
Maybe like
planning for like a trip or something, like packing your clothes and stuff.
A to-do list or a schedule.
Excellent.
Maybe like planning like different parts and then like using feature extraction later when you need it.
Excellent. Excellent. Awesome. Okay. Wonderful. So what we are trying to do, how do we use machine learning models to solve this problem? Analyze data, time series data, analyze them. When I analyze the data, I understand what happened in the past, what happened now, what's happening now, and also I can predict what's going to happen in the future. Okay, those are the three things. Why am I doing this one? That is the part of planning, budgeting, forecasting. Let's take an example. Okay, so let's say your family want to go to India. Okay, that's a big deal. Correct? 4 people, you have to book a ticket. So once you book a ticket, then you have to arrange someone to come and pick you, drop you at the airport. And then you also have to pick someone to pick you back in India. Okay? Then if it's going to be for 2 weeks, you have to plan where the 2 weeks going to be spent. Like this, there's a big task to accomplish. Correct? If you look at anything you do, it has a time attached. So when am I going to leave? I'm going to leave in the month of January 2021. What day? 2nd of January. See, there's a time. All right. What time will flight? 9:45. Where are you going to go from there to Singapore? Are you staying in Singapore? No. I'm going to from Singapore straight to Chennai. What time you're landing? So local time 11:50. Where am I going to stay? I'm going to stay in a hotel. See, all has time attached. Okay, all has time attached. So analyzing this data and coming up with based on what happens. Let's say on your travel, your flight got delayed in Singapore. Okay, due to weather condition, the flight has been cancelled and delayed. First it was delayed, then it got cancelled. So now everything got collapsed. You have no flight for the next 3 days. So what happened? Now you are forecasting everything. Okay, why? It didn't go as planned. So my plan was, I booked a hotel. So I was hoping that on the day of 11:45, I'm going to land. Then I'm going to be at the hotel around 12 o'clock. Then I will go next day, etc. So now the entire thing is got cancelled, changed. Why it is changed? Because my flight in Singapore got delayed and then it got cancelled. So this is a huge impact. So predicting something of that kind, okay, if it happened like this, then what's going to happen? Other things. So that's kind of what we wanted to do. So I would say it's more of understanding the time-based data, both past and current, and coming up with for the future, which is the forecast. Okay, which is a forecast. Let's understand this one. So what you see here, so there is the number of students enrolled in a particular department, year 1, year 2, year 3, year 4. How many students enrolled in computer science, IT? Okay, this is like in a student enrollment in an undergrad school. Okay, in an undergrad school. So how many students enrolled? I am looking at historically year 1, year 2, year 3, year 4, etc. So then I have an idea. Correct? Year 1, how many students? Year 2, how many students, and etc. So what does this represent? This represents past data. Okay, this represents past data. So now I'm going to use my past data is 2019. My current data is 2020. The future data is 2021. Using this, I can arrive planning, budgeting, and forecasting. So based on my past 2019 data, I can tell how many students I'm expecting in 2020. All right. So based on the 2020, I can plan for future, how much I'm going to expect in the 2021. So in the past, I have 100 students in computer science, which is in 2019, I had 100 students enrolled in 2019 in computer science. In 2020, I'm expecting 115, but it's not 115, it's only 85. Due to various reasons, it's 85. So in 2021, how many students are there? So I'm going to expect less than this one. That's because the current enrollment is not that great. Okay, so this is basically analyzing data, past, current, and future. It's the time series data analysis. Okay, time series data analysis. So this is basically tells you what is actual, what is planning, what's budgeting, or what's forecasting. Actuals, 2019, it's actual. So 2021 is the planning. The budgeting could be both actual and planning. How much money I need to run the business as of now and in the future. And forecasting, if something doesn't go well as planned, then you make an adjustment. That's what forecasting is, right? Understand? So what is forecasting? Okay, it's very simple. So you have a plan in place, as we talked about, as per plan. So we are going to reach Chennai in January 2nd, 11:55 p.m. of 2021. What happened? We got stuck in Singapore. Our flight was delayed. Ultimately, it got cancelled. So now there's no way I can go. I don't have any flight for the next 2 days. So now what I have to do, I have to forecast everything, what is going to happen. So why am I making this adjustment? That's because I have a change in my plan. When there is a change in the plan, then you will basically make an adjustment. As an example here, so in 2019, we have 100 students enrolled in computer science. Based on the 100 students, I planned in 2020, I will have 150 students. Unfortunately, due to COVID-19, I don't have 150 students. I have only 80 students. So now what I have to do, based on the 80 students, I have to do what is going to be the number of students enrolled in 2021. Okay, so that is future analysis. So this adjustment that what I'm making, what is that? It's nothing but my forecast. How am I forecasting my 2021? Okay, how am I forecasting my 2021? Based on what? Based on my current data. Based on my current data. So that's what I'm talking about. actual planning, budgeting, forecasting. Again, it's a big topic. Okay, so I won't be able to spend too much time on these things because I just wanted to give you an idea what model we are building and what problem we are solving. So basically, I'm getting to the root of this issue. Okay, let me go into real world problem. So this is an actual problem that I have been asked to work on. Perform a product on a product SKU level 6-month rolling forecast at different regions. Okay, at different regions. Okay, that is the underlying problem. Perform a product and product SKU. So what is a product SKU? That is the lowest level of a unit that you could sell. For example, you take a printer. So printer is a product. The printer also have tapes, inks. Those are all SKUs. So you don't have to buy the whole printer. You can also buy the ink, or you can also buy the tape. The tape and ink are the SKU level. Okay. So what they are asking us, how many product we will be selling in a given geography? How many SKU we will be selling in a geography on a particular period of time? That is the underlying problem. They ask us to build a machine learning model which does the forecasting. Okay, which does the forecasting. So what kind of problem this is? As you all know, it's a regression problem. Why? It's a range of value. It's a range of value. How many printer I'm going to sell in Sacramento? 100 to 200. How many product I'm going to sell in San Jose? 1,000 to 2,000. How many product I'm going to sell in San Jose? 150 to 250. You see, that's a range. That is the problem type. What model I'm going to implement? Linear regression. What model I'm going to implement? Linear regression. Understand all these points what I'm talking about. It is a real problem. It was done for a very large retail company. Okay. So when I say product, these are all the features you need to understand. When I say product, how does the customers are using the product? You see, everything has a hierarchical flow. So they have a product family. Under the product family, they have a product group. Under the product group, they have a product under the SKU. Example, product family, hardware. Under the hardware, I have a group printer. Under the group, I have a product, color printer. Under the color printer, I have a SKU, printer cartridge. You see how it is flows? In the real world, this is how it works. So your forecast could be various level. So what I'm doing at a 2 level. One is at the product level, at the SKU level. That's what they're talking about. Perform product and a product SKU 6-month rolling forecast at a different regions. Okay, at a different region. So that is basically you are trying to run a predictive model which predict how much you are going to sell either a product or a SKU in a given location. Okay, so this is how the locations are organized. The company I'm talking about, it's a worldwide company. It's a global company. It is just not only in the US, they have operations in worldwide. Take an example, Walmart. Walmart is a global company. They operate very much every part of the world. Okay, so when you have such company, so region is North America, then the country, then the state, then the city. Okay, so what is this? So this represents where the product has been sold. The product has been sold at a region, at a country, at a state, at a city. Example, region is North America, country is United States, state is California, city is San Francisco. So this is how you sell this one. The forecast could take place at any level. Okay, the forecast could take place at any level. All right, so how this works? The problem statement is predict the number of product and SKU you are going to sell in a region, country, state, or a city. So that's a prediction. Okay, at each level, what you're going to sell. So that's what they're expected to predict. How do we implement this one? So this is implemented using a machine learning model. In this case, we are using a supervised machine learning model, linear regression. So to do that, I need a configuration INI file. Okay, so I'm configuring all the things what I'm going to use. And second, once I have that, this is a technical implementation. Okay, I'll walk you through in the system as well. Okay, and that would be in a stopping point. After that, we'll stop this one. Okay, so the reason I'm using the INI file, I don't want to hard code anything. Okay, I'm going to change my screen. Let's see if you're able to see my screen. Okay, so tell me if you're not able to see. Can you all see my screen?
Yes.
Yeah.
You see the slides.
Oh.
Yeah, we can see it.
What are you seeing?
The slides.
See the slides.
The linear regression implementation slide.
Okay, wonderful. Let me change this one to the other one that I'm talking about. Okay, can you see me now?
Yeah. File Explorer.
Yes.
Yes,
You see this
yeah.
one? This is basically the demo actually I built. So you see this one, time series analysis. That's what this is. You see there's a DL and ML. There's a deep learning model. There's a machine learning model. There's a machine learning model. You see there's an INI file. There's an INI file. So what does this INI file does? It has all the things what I need. If I'm connecting to different data sources, this gives you the connected information. Okay. And if you see further down, if I'm using any specific path to get data, I have those paths here. Okay. So basically what it is, I don't want to hard code anything in my Python program. I created an INI file where I can configure everything in one place and deploy anywhere. Let's say, for example, if you have to run the same program on your laptop, I just have to change the INI file. I don't have to change anything on the source code. Okay. If you scroll down, you see I talked about a feature. What are the features? These are the features. Okay. I'm just giving some labels for this one. Okay. So all these things I'm using to avoid any hard-coded thing in my program and also make the deployment simple. When I say make the deployment simple,
I can't. I can only see the Windows File Explorer, not the actual window you have up.
All right. So
Full screen, like
Yeah.
yeah.
this is which is a full screen. This one is a full screen.
If you click share screen, and then there's like this, there's a on the top first layer, there's like, let me see if you want.
I don't see this boss.
Don't click on different tabs or anything. Like there's one thing that says screen, I think.
Yes, that's what I'm clicking on. So what do you see now?
Now we can see the.
We can see it.
Okay. All right. So this is basically the INI file. Let me close this and go back and open this one actually. Okay. So let me start from here. So it looks like someone is not. So time series analysis, that's an implementation. It's a machine learning model. That's the actual folder. You see there are different folders here. There's an INI file. There's a model outcome. There's a source code. There's a test data. There's a training data. So I want you to make sure you follow and understand. Even if you wanted to learn, if you want to practice, you follow the structure. It's easy to deploy. And also, it kind of helps you to organize yourself instead of just writing here and there. So you can follow some structure, and the same structure can be used everywhere. Okay. So when you go on to work on a project, if someone asks you, let's say you apply for a position, you apply for an internship, they ask you, who have you, what have you done it? Okay. You can walk them through, hey, listen, I did a predictive model to predict how much product I can sell in a region. And to do that, I implemented a linear regression, which is a supervised machine learning model. And that's how we did it. Right? So you can tell them, you can walk them through. So that's the idea behind why I'm taking this time to explain to you. Okay. All right. So the INI file has all the information that's model needed and a runtime. Okay. So where it connects and get the data. Okay. So the connection string for if it has to connect to an SAP, if it has to connect to a Hadoop, on Oracle, Microsoft, etc. And also all the features that I'm going to use here. So this has a lot of information. The intent of using this INI file, avoid any hard-coded value inside your program. So that is what the first step. Step one is read the INI file. Okay. I'm back to PowerPoint. I hope you're able to see the PowerPoints.
Yeah, we can see it.
Yeah, we can see it.
Okay. So second step, once you've done this one, import the required libraries. So what are the libraries that I'm using? I'm using Pandas. I'm using MATLAB, and I'm using scikit-learn. Okay, like this, the library that what you need, import them. Step 3, import the training data. Okay, so before you get to the program, you have to understand training data. How do you create a training data? You have to understand the features. So then for that, where do I get this kind of features data? Okay, so if I'm going to run a predictive model, which is going to predict whether the given image is a male or female, then I need a training data. A set of data which represents a male, a set of data which represents a female. I have to get that one. So that is the training data. Okay, so you have to import the training data. That's step number 3. So once you import the step number 3, then import the time series model. Right? Like in this case, the model that we're going to use, linear regression. Then train the model. Once the model is trained, then I'm going to import my test data. So once I test the data, once I import the test data, then I'm going to run the forecast, which is nothing but I'm going to test this one. I'm going to test this one. So once the model is ran for the forecasting, write the model outcome to a file. Once the model is written to a file, then verify the model outcome. Okay, write the model outcome to a file, verify that one. So let me go back to the folder. You see here, I have test data, I have a training data. I'm going to select this one. So this is my training data. I'm going to open this one. Okay, you see whatever I talked in the PowerPoint, it's all here. So I have a region, country, state, city, customer. These are all my features. Okay, so these are all my features. Okay, you see this one? So these are all my features. So all the things what I have. Okay, so I hope you're able to see my notepad. Can you see my notepad?
Yes.
Great.
Yes.
Okay, I'm so happy
Yeah,
that.
we can see it.
Okay, so you see this one, these are all my features. These are all my features, and that is what you see here. So it is not anything that what you have in the file has to be feature. You can have any data. So for example, I have a unit price. That is not my feature. I don't need the unit price. And I don't need my revenue also. Revenue is nothing but the quantity sold and unit price. That's why it's a multiplication. I don't need that, correct? So these two columns are not required. Okay, but I can have it in the file. The point I'm trying to make, so whatever data you have in the training, whatever field you have in the training data, it doesn't mean that you have to use them. You could ignore them. Okay, you could ignore them. And you also wanted to understand, you see this one, I have time representation here. Year 2015, month of January, okay, month of February, month of March, April. So I have all the data in a time series form. You see this one? So this is a time series representation. It represents year, it represents a month, it represents the time when it took place. Okay, so it tells the machine in this region, in this country, this particular product has been sold this many number of units. Quantity sold, units skewed sold. Correct? So this is what the training data. Keep in mind, in a regression model, I'm not predicting yes or no. I'm not predicting 0 or 1. I'm going to predict a range of value. I'm going to predict a range of value. In order to predict a range of value, I have to train the machine. So what am I training the machine? I'm using the previous sales, the sales that took place in 2015, the sales that took place in 2016, the sales that took place in 2017, etc. So for those sales, I'm telling what I sold by region, by country, by state and city, and a product level, SKU level. Okay, so this is my training data. So this is what I need for the model to be trained. Okay, again, in a real world, it's much complex. Okay, this is just we are understanding from learning point of view. All right. So what I was trying to say, these are all the features we are trying to use it. Okay. So now let me go back one more time. So what is my test data is going to look like? Okay. What is my test data is going to look like? So I'm going to take that too. Okay. 1 second. So this is my test data. So here I looked at the training data. I'm looking at the test data. In the test data, what you see, you don't see the predicted quantity for the product, the predicted quantity for the SKU. If you can scroll down, I have everything. I don't have the SKU, the unit, how many units that I'm going to sell for the product level and SKU level. You see this one? So those columns are not there. Like I said, the unit price is not required. It's just in a field that's sitting there. So I don't have the actual, okay, the quantity that I'm going to sell. So that is not there in this one. So this file doesn't have the quantity that I'm going to sell. Without that, it has this one. So what the model is supposed to do, it learn from the training data and then predict in the based on the test data. So in the test data, what you see here, you see I'm not giving 2015, I'm not giving 2016, I'm not giving 2017, I'm giving 2020, I'm giving 2021, okay, and 2024, etc. So these are all feature prediction. These are all feature prediction. So in the feature, in a country, in a region, in a city, for this particular product, how much quantity I'm going to sell. That's what the model is going to predict. It is a 6-month rolling forecast. I'm sure you may have heard about it. If it is not, I would encourage you to read what is a 6-month rolling forecast. That's a 6-month rolling forecast. It does that 6-month rolling forecast. So what we looked at our training data, we looked at our test data. Okay. So those are the two things. I'm going to run, I'm going to delete the model outcome so that we can run the model and see whether the model is predicted or not. Okay. So I'm just going back to the folder and I'll show you the model outcome. So the model outcomes are written in a file, okay, so that we can understand. So we looked at INI file, we looked at training data, test data, model outcome. So the model actually predicts all these things, okay? The model actually predicts all the things. So let's open this and see what it is. I'm going to delete this one first so that we can run the model and see it is. Okay, so let me go ahead and, so my laptop has some issues. So I have to use this mechanism to delete. Give me a minute. Okay, so these are the model predicted outcome. So what it does a 6-month rolling forecast. That's one outcome. Second outcome, it also predicts at a SKU level and a product level. You see there's the model outcome, forecasted quantity product, all. Okay, so model outcome, forecasted quantity product, SKU level. Okay, so this is another calculation that I'm doing to calculate the revenue, to calculate the overall quantity. Ignore these two, last two is not required. So I'm going to delete these guys. Okay, I'm going to delete this one. So I don't want this file. I don't want this file. I'm deleting this one. So now I have to run the model and see how it works. I'll walk you through the code as well. Okay, I'll walk you through the code as well so that you can understand. Okay, so sorry. So I deleted everything. Okay, I'm just going back to the model folder. You can see. So the model outcome, right now there's nothing here. Okay, so there's nothing here. So we looked at all the different folders. We looked at the INI file. I will send you this one. You don't have to worry if you want to. And model outcome, there's nothing there. Test data, there's a test data. There's a training data, there's a training data. Okay, so I'm going back to my PowerPoint. So what we looked at, okay, what we looked at. So the problem, what we are trying to undertake, perform a product and SKU level 6-month rolling forecast at a different level. That's the problem. What kind of problem it is? A regression problem. What model we need? Linear regression. How do we implement this? So these are the technical steps. So I'm not saying you have to always use an INI file. The INI file, okay, it's kind of README file. It has the information for the model to understand certain things, such as what feature I'm going to use, from where I'm going to read my training data, from where I'm going to read my test data, where I'm going to write my model outcome, etc. All of those are going to be in the INI file. Step number 2, in this case, we are going to use some libraries. The library that I'm using to read the data, I'm using Pandas, which is part of Python. The programming that we are using, Python, okay? And the library that I'm using, Pandas, and also scikit-learn, and also MATLAB for the graphs, okay? The visual representation of data. And then I have the training data to be imported. So once I have training data, then I have the model to train. Which model? Linear regression. Then train the model. Then import the test data. The model has been trained, model is ready for testing, import the test data and test the model, which is nothing but running the forecast. So once you test, which is running the forecast, write the model outcome to a file. Once the model outcome is done, you can verify the model outcome. That's the last step. So that's not right here. So it has to be model outcome. So this is step number 3, verify model outcome. Okay, verify model outcome. So those are the steps we do. Okay, those are the steps we do. All right. So what I need in order to do this one, I have to install, as I said in the yesterday class, Anaconda. So if you install Anaconda, launch Anaconda, it's already running. I'm going to show you. So you see this one. So when you have Anaconda installed, okay. So when you have Anaconda installed, you can see the Anaconda navigator. Okay, you can see the Anaconda command prompts, correct? Like also the power prompts. So you can open this one. Okay, if you installed already, it should be there. All right. So in my case, it's already running. Okay, so you see this one. I have launched the Jupyter Notebook. It's running right now. All right. So all you have to do, launch this one. So the Jupyter Notebook, it brings here. Okay, so where it comes, you see the time series analysis. Can you all see my screen?
Yeah.
All right. So this is the source code. Okay, this is the source code. Can I expand YAML? And then you see the source code. That's where I have to go. And this is the source code. Okay. So what I have, see the actual source code is here. So all the steps what I listed in the PowerPoint, it's inside the source code. Okay. INI file. So okay, this is basically set of code written to read the INI file. You see this one? So get environment variable. So that's a variable that I'm using to store the INI file value and path. Okay. Then if I go, like, I can go line by line. I'm sure you can figure this out. I'll send you the code. It's not a big deal. Second, once I have the INF file, import the required library. So I am using scikit-learn. Okay. I'm using pandas. I'm using NumPy. You see this one, pandas? I'm using NumPy. I'm using scikit-learn. So what is scikit-learn? It's a Google's open source, okay? So that's basically like, where I get the linear regression model. I'm going to use this one. And I can use also TensorFlow too. I can also use TensorFlow too. So whatever model you wanted to use or whatever library you want to use, that's fine, no issues. So that's the second step. Next is importing the training data. You see the INF file has the path to the training, okay? So this is basically read Excel. So it's going to read this from the path which is from the INF file. Okay, so if you scroll up, you understand. So once it's read the INF file, it constructs the training data. So the entire logic that what we have, it constructs the training data. So now the training data is ready. Now I have to import the model. Okay, so what model? Linear regression. You see this model, linear regression. So that's the model I'm importing. The next is training the data. So this is basically model fit. That's the training data. Okay, it trains the model. So now the model is trained. What is my next step? Import the test data. Again, it reads from the INF file, it imports the test data. I'm preparing my test data. My test data is ready. Okay. All right. Now I'm running the forecast. Okay. I'm running the forecast, which is nothing but predict. You see this one? It's a prediction model. It runs the prediction. All right. It writes the model outcome to a file. You see this one? It writes an outcome to a file. It's going to look like this. Okay. Then these are all calculations you could ignore that I'm doing for various purposes. Okay. You can ignore. I'm doing this for various purposes. But at a high level, what I explained, that's what it is. All right. So before we run, do you guys understand how we are connecting all the dots? Okay. Someone asked me, what is Python is doing? Nothing. It just connects all the dots. Okay. Beyond nothing. Do you guys understand what we discussed so far?
Yes.
Yeah.
Okay.
Yeah.
All right. So no problem. So what I will do, I will go ahead and run this one. So how do I run this one? But before I run, I want to clear everything. Okay, restart and clear outputs. So I'm going to do this one. Yes, I'm done. So basically what it is, I'm just keeping it everything clean. So you see this one, there were some outcomes are written here. It's all gone. It's cleared everything. Okay, so the entire code block is now ready to run. So I'm going to kernel and then restart, run all. Okay, now it's going to run. So how do you know whether it's running or not? You see the star indicates it's running. Okay, the star indicates it's running. So it may take a few minutes. So basically what it is, all the steps what we talked about is performing this one. The star means it's running now. Okay, it's running now. So now if I go back to the model outcome, it may have written all the files. Okay, so once the run process completes, it's going to basically write everything. So it performs all the steps that what we talked about. So that is why I said Python, it just connects all the dots. Okay, so it brings the INI file, it imports the library, it trains the data, etc. Okay, 1 second. Yeah, waiting for the model to run actually. So you see this one? So the model ran, it wrote all the outcomes. These are all like, you see this one, this is the output, correct? Like, so basically write the model outcome to a file. It writes also on the console, you can see them. So the overall outcome is here. Okay, the overall outcome is here. The model ran successfully. So now I'm going back to my model outcome. You see all the files, whatever file that we deleted, you can see the timestamp. Okay, you can see the timestamp, it's created. So you can see what the 6-month rolling forecast is going to look. So it has the column. You see this one, it predicts for the month of January, and it predicts the unit price. Ignore these two columns. The product, the last two columns, you can see the forecasted product quantity, forecasted SKU. So these two columns you could ignore. So that's not something that you want to write down. So these are the columns it predicts. Okay, so for the month of January, okay, how much it's going to be for 2020, like this, it's going to predict for all the months. So this is a 6-month rolling forecast based on how the time has been set up. Okay. All right. So I'm just going back to the PowerPoint, what I have. Okay. So this is a live demo that what we did. So in a real world, how this works, this is how it works. Again, you don't have to worry too much about it, but this is just an idea to show you what exactly used in the real world. Okay. So I'm going to skip this one. Any questions? Any questions?
How did you get to the Jupyter notebook thing again? You just went to Anaconda, and above that, you just like pressed on Jupyter notebook. That's it, right?
Yes, I'll show you. I'll show you.
Isn't it through like the Anaconda Navigator?
Yeah.
Okay.
Okay.
So the first step is launch this guy. Go to Anaconda. So you see this one? So you see the Anaconda power prompt, hit open.
Okay.
So now when I open this one, I have to go to the folder where I set up everything. So I have a folder. In this case, it's ./AI. Okay, so this one I have. So here I'm going to launch Jupyter Notebook. Okay, type Jupyter. Can you see?
Yeah.
Okay, so when,
Same thing on command prompt too.
say that again.
You can also do it on command prompt. Like this is.
I can do that actually because this gets, in my case, I use a lot of environment variable. I have a lot of paths set up actually. So if I get there, the path won't set. So I have to use this one.
Oh, okay. Yeah, that makes sense.
Okay, this will launch the Jupyter Notebook. You see it launching?
Mm-hmm.
Can you see Jupyter Notebook now?
Yes.
Yeah.
Thank you.
Okay, so you know, like you said, like if you run into problems, if you have any questions, don't hesitate. You have my email. Shoot me an email. We'll go from there.
Okay. Thank you.
No problem. So this, yeah, this kind of brings all the book parts together, come to an end. I wish I could have more time to cover the other topics, which is basically what I promised in the morning. Like talking about machine learning versus deep learning, and also deployment, data engineering. Unfortunately, already we lost a lot of students. So we had 70. I think we came down to 50 or something. So I don't want to take too much of your time. I know you have a lot of commitments, and also it's Sunday, and we have the Bay Area Tamil Mandam has other things to take care. So I'm going to stop here for a minute. Okay. So first of all, I really want to thank the Bay Area Tamil Mandam for giving me an opportunity to teach this class. It's been amazing experience. I taught courses for students, faculties at a different level, and this is a different experience for me. I truly enjoyed it. And thanks for the opportunity for the students, and thanks for the opportunity for them from the Bay Area Tamil Mandam. I sincerely appreciate that. As my closing statement, I always believe in knowledge is the power. It doesn't matter what it is, how much money you have, who you know, what political influence you have, irrelevant. Okay, that can come and go. That can come and go. The power of knowledge can buy you anything. Okay, it makes you a very commendable person. It makes you very everything that what you want to achieve in your life you can. But it's not easy. So I would encourage, keep knowledge as the power and work towards getting the knowledge as much as you can. That will take you wherever you want to go. Okay, wherever you want to go. I wish you all the best. Good luck. Thank you so much. I truly enjoyed the session. Thank you. Take care. Bye.
Thank
you.
you.
Thank you.
Thank
Guys,
you.
guys,
The session was
can
amazing. Thank you so much.
Thank you. Guys, can you please?
Hello.
Hello.
Thank you.
Yeah. Can you hold?
Your voice is breaking.
Hello.
Hello.
Yeah, we can hear you.
Yeah. So just 1 second. Shubha, are you there?
Yeah, Shubha is coming, Ramesh. Just a second.
Okay. Can you ask Malik to join us?
Hi, Ramesh.
Hey, Shubha, can you call Malay so to give a
Malay
speech
is
from
here only. Malay is
Malay is here? Okay, yeah. Just want to let
Malay. 1 minute. Malay.
okay.
Subha, I'm here, Subha.
Yeah.
Okay. Just want to Malay, you want to give a thank you note?
Okay. Okay, thanks, Ramesh. Thanks for giving me the mic. First of all, thanks to Jyoti Pirisamy for accepting to do this session, the 2-day session for the students. And that was an excellent session both the days. I think student might have got a lot of knowledge from whatever it was intended to be. So thank you once again, Jyoti, for giving this wonderful
Sure. Thank you, sir. Thank you very much. It's my absolute pleasure and honor to be part of this community. And this is my third attempt.
Yeah.
So I've been doing this for the third time, this one. Thank you so much.
Yes. And I would also take this opportunity to thank a few people who have helped here, and particularly thanks to Scott Coffin for the keynote yesterday, and also thanks to Mr. Ram of Madras Groceries and Lena Kannappan for giving the entrepreneurial touch to this workshop, which was also a good thought. Like students can understand what they have from the point of view of entrepreneurial thing after doing this artificial intelligence. So thanks to them, and thank you, Ramesh Kupusamy, for bringing up this and helping the youth volunteers to put together a good 2-day workshop. And I think the youth volunteers did a great job here. And while saying that, so would like to thank all the youth volunteers who have helped, starting from Kaushal Ramesh, Akil Kanagaraj, Akash Tyagarajan, Jai Suraj Kalishwaran, Shivaji Ganesh, Shatya Pugal, Vishnu Titarappan. So we would like to thank these youth volunteers, and thank you, Shubha, for taking this up from the EC and coordinating the event along with Ramesh Kupusamy and putting together a very nice 2-day workshop, which is good. And I hope all the students had benefited through the 2-day workshop, and all the best to you for the future years. And I think Bay Area Tamil Mandram will be doing more and more such events in the future. Thank you so much.
Thank you, Malay. And just want to, 1 second. So students, I hope you got a very good knowledge on AI last 2 days, right? Okay. I hope you all got it.
Ramesh, one second. So I would really appreciate if 1 or 2 participants step forward and speak about the program. It is not about how good I am. I know where I stand. It's not that. It's about what you learned, what makes this program look different. Because we have so many people like Subha, we have Ramesh, we have the youth volunteer like Meena. There's so many other people are behind the scene. Correct? So let them hear how you felt about it. Correct? So can 2 or 3 participants speak about what you achieved, what we achieved for the last 2 days?
Okay, I will speak.
Yes, go ahead.
Okay.
Tell your name.
Well,
Tell your name.
my
and
name
then
is
go.
Sibish, and I'm in 8th grade. And at the first of this like boot camp, I didn't know anything about AI. But like as soon as like I got into this boot camp, in like the first like 10 to 15 minutes, I learned like so much, and this like really helped me get like a good look into different like jobs, like how you guys brought in like the entrepreneurs and like showed us how like the how they became entrepreneurs and stuff like that. And it really helped me see how there's like so many different things to learn about, and it really helped.
So what is the best part you like?
I like talking to the entrepreneurs and the guests that came onto the show.
Okay,
And
nice.
also and how interactive this like boot camp was.
Okay, so the interactive boot camp you liked it.
I
Okay.
also wait. Sorry, go.
Yes. So go ahead, the next participant.
Okay. My name is Srivatsan. I'm gonna be a freshman in college. I just when I started, I was more focused on like knowing like the basics of like computer programming for machine learning, AI, and like I was not like I only wanted to focus on like that aspect. But then after I went through all of this, I realized that to fully learn about AI, machine learning, data science, and deep learning and all of that is to actually learn like the concepts behind it and all the aspects rather than just the programming. And as I've gone through this, I learned that there's a lot of statistics and modeling and all of that stuff that kind of like helps me understand a lot about machine learning
Sure.
and those concepts. So that's what I learned. So I just wanted to thank everyone.
Sure. Thank you all. Thank you. Who's next?
Who's next?
My name is Mega, and I'm going to be a freshman in high school, and I'm from Connecticut. This is the first time, you know, I've been on this type of call, and I don't know much about machine learning or much about AI in general. And when I went into this class, everything was so deeply explained that I was able to understand every single topic here. And it was really a great experience talking to the entrepreneurs, and I was able to ask a lot of questions and interact with everyone, which
Sure.
was really great.
Awesome.
My favorite part was learning a lot about how AI is implemented in the world and
Sure.
how it was kind of shown if that was the case, what would
Sure.
happen.
Sure. Sure. Awesome. Thank you. Thank you so much. Last person. Anybody else? One more person.
Hi, I'm Harshita.
Yes, Harshita. How are you?
I'm good. How are you?
I'm doing good. Thanks for asking. I'm tired. Where are you from?
I'm from the Bay Area.
Okay.
Yeah, I'm going to 7th grade,
Oh
and
my God, you're a 7th grader.
yeah,
You are like my daughter.
yeah. So I really liked this 2-day workshop because in just 2 days we covered like a lot of parts of it, and the teaching was like really nice because we went into different parts. And my favorite part was using the examples instead of just like teaching, like using different examples from different things to show machine learning and all, which is really cool.
Okay, awesome. Awesome. Thank you so much. I wish you all the best. Back.
Okay. So students, I think now you are know what is AI, and we want to go to the next level. So we want your parents to know, especially your moms to know what is AI. So we have a next session coming by Mr. Jyoti on September 19th and 20th. This is for women's and
Women's empowerment.
Empowerment. So it's all about AI. Your mom should know what is AI. Whatever learned, she will ask question. Now from now to next September, she might not know. You can tell whatever. After September 19th, she might know. Okay, she can also ask all the questions and guide you through that. And Mr. Jyoti is going to take the session for the 2 days for the women's. So ask your mom to sign up for the session. We'll have the release the session soon. So use that opportunity.
Yes, yes. So the Women Empowerment Opportunity session is actually the session that I conducted for one of the university back in India. It's SIET college. I don't know the full form. It's in Chennai. It's one of the most prestigious colleges called SIET. So I trained the entire campus, the faculties, as well as the deans and all those people. So it's more an employment-oriented program. So how do I learn this one and become an employable resource? So it's going to be a good program. Please attend.
Yeah, please ask your parents, your moms to attend it, the session, and we will send all the recordings to all the participants. And I just want to share the so just share the news. Right, we got this course being endorsed by San Roman Mayor, Mr. Bill Clarkson. I want to share the screen so that we will give the certificate to the participant who attended this session. But for now, I just want to share some of the sample certificate right now. Just give me a second.
Ramesh, please show the sample for the youth volunteers, so that Jyoti can give it to them.
Sure. So can you see the screen now?
Yes, we can see the screen.
Yeah. This is the certificate. Yes.
Will this be emailed to us?
Yeah, we will email you. Yes, it's all e-certificate. We'll email you.
So our parents or our email?
Whatever the email you registered, we will send it to both the parents. So that's the reason whoever attended this class session today, I think you all entered your name, your name. So we will just go through the name and send their certificate. Okay. And also we want to thank all the youth volunteers, as we have a youth certificate to all the youth volunteers. I'm just sharing this. Yeah.
How do we get the certificate?
We will email you. We will email you the certificates.
Oh, okay. Thank you.
Okay. Yeah, Jyoti, yeah, you can just share something.
No, the only message that I wanted to say, these credentials definitely adds value to your resume or in a school application, college application. Please take it serious and save them with you and add in your resumes. Tell them we participated in a 2-day AI boot camp and we understand the basics about artificial intelligence. We know how to work with these things. That has a lot of value. If you're applying for a college's schools, make sure you apply this with these credentials.
Okay.
Thank you, Jyoti. Thank you so much for conducting this workshop. And I think kids are benefited from this 2-day workshop, and the entrepreneurs, they gave a very good experience, and they're sharing the stories. It was a good, awesome surprise for us too. Thank you, Jyoti. Thank you so much.
No problem. That's fine. Actually, I spoke both of them. Then I told them to come and speak about it.
Yeah.
That's what it is.
It was a very good experience for us also. Thank you.
Sure. Thank you.
Thank you, guys.
Okay.
Thank you.
Okay. Thank you. Okay. Bye.
Bye-bye. Take care.
Bye-bye.
All right. Thank you.
Thank
you.
Excuse me.
Yes.
So will there be like any other classes like for the kids?
That we are done for the summer. If anything, we'll let you know. You can follow us on SF BATM or webpage or Facebook.
You can San Francisco Bay Area Tamil Mandram Facebook channel. So if you could ask your parents to go and like that page, then we would be updating all of the informations in that page. Okay.
Okay. Thank you.
Ramesh, you can end the.
Stop the session.
Yeah, you can end the meeting.